Okay, I like this music. I thought it was fun.
Absolutely. I was into it, and then I was thinking about like you were kind of sending me a message. It's like, why do you like this music? And I was thinking like, well, obviously because it's super easy to dance to it, and definitely.
You're at a standing desk, so it's easier for you to
I'm
dance.
gonna
I'm
study
doing
this.
my little chair dance here. Well, welcome to Posette, an event for Postgres. This event is now in its 4th year. And I'm joining from San Francisco Bay Area, California. And where are you?
I'm in Prato, actually, in Toscana. This is not my usual desk. This is my friend Jonathan's who let me his office so that I can talk to you from here because this place has much better internet than where I'm living in Belgium. Yes.
Okay, so you had to go from Belgium to Italy in order to make this all happen here today.
It's not the only reason. Today is Simon Rick's birthday, number 60, and we are celebrating his birthday, although he's not here with us, but physically he's here in his soul, and we are all with his family and friends celebrating his birthday here in Toscana because that's what he wanted to do when he was going to turn 60. It's a very special day for me. I'm super happy that you invited me doing this co-hosting, Claire, because I can share my joy with everybody in the community of Postgres.
Well, and Postgres is certainly something that Simon Riggs was dedicated to. He spent the better part of his career working on this project. So, all right. Well, I hope you have a wonderful celebration in his honor. Let's get started with Posette, an event for Postgres. We have a big show in front of you. Well, first of all, there's 4 live streams, and this is number 2, right? And
Yes.
this one's targeting people who are awake during the EMEA, Europe and Middle Eastern kind of time zones. But there are more. Boris Mejias, I'm so glad you're here to co-host with me today. I'm Claire Giordano.
Thank you very much for inviting me. I'm super excited. Yes.
Shout out to the other co-hosts. Flor Drace was with me for live stream 1, and we've got some amazing people on the schedule for live streams 3 and 4, who, if you come back, you'll get to meet them. This event is brought to you by the Postgres team at Microsoft. So there's a lot of organization that goes on behind it and a lot of funding, and I'm super appreciative that we all get to come together and do this in an accessible way.
I would like to add to that is that this is an event for the community. It's organized by Microsoft, but definitely it's always with the community in mind. And me being from EDB, invited to participate here with you guys, it makes it even more like collaborative. And actually, this is also one of the things that Simon said in his last keynote in Prague, when he was inviting people to participate more in online conferences because we can reach out a lot more people. So I think this is a very good thing, and I'm super happy to be a Posette once again.
Well, and I think it's pretty natural. Like, people enjoy in-person events. There's this warmth that you get from being able to hug someone, shake their hand, look at them close in their eyes. And it's pretty awesome. I was just in Montreal at PGConf Dev and had an incredible time. And that in-person conference, it's hard to beat it. But a lot of people can't travel. They have little kids. They have older parents. They don't have budget. They're between jobs, whatever it is. And so I love the fact that we're continuing to make this effort to make all this content accessible. As long as you have an internet and a laptop, I suppose.
Exactly. And there is also the possibility to watch recording for in-person conferences that are there, but then you don't have the interaction with the people while the video is being broadcasted, like we are having in Discord, where we can talk to each other and then ask questions and have a very particular connection with the person who is showing the video at that moment. So that's a very good thing. Now, the only disadvantage of online conferences is that you cannot see how fantastic the shoes that Claire is wearing today. So,
I have new shoes on. I really do have new shoes on. You didn't know that. That was not intended. Okay, I thought the next slide was going to be on the virtual hallway track for Discord, and it wasn't. So I went to the next one. I went to the next one. I went to the. It's not in the next few slides, so that's why I came back. Okay, code of conduct.
Yeah, I wanted to remind actually the people that while we are talking in the Discord channel and we are interacting and then asking questions, it's super important to have a collaboration again. And then if you behave well, then you're going to be within our code of conduct, because there is easy way of talking to people when you behave correctly, and then everybody can have a better fun. And then, yeah. But we have some rules. So maybe, Claire, you want to highlight one of the rules today?
Oh, I think it just comes down to being respectful and listening and being inclusive of everybody. There is a QR code and a short URL on the right side of the screen, posetteconf.com/2025/conduct. You can go and learn more about the code of conduct. And if you run into any problems or need help, there's also near the end of the code of conduct an account that you can email to contact and ask for help. So there's a whole process that you can go through there.
Yeah, so it's a team that can support you if something goes wrong, of course. Yeah.
Accessibility, captions. Today's live stream, the one that you're watching right now, is available with live captions in English. And then after the conference, when all the individual talks are published on YouTube, they will not only have really high quality English captions, that they will also hopefully be, I believe they're going to be translated into like 16 languages.
Sí, esto es especialmente importante para la comunidad hispanohablante, para que tengamos un acceso mucho más fácil a mirar los subtítulos de las presentaciones. Y además, si alguien quiere hacerme preguntas en español en Discord, estaré dispuesto a responderles sin ningún problema.
Sí, podéis namilas español. Your Spanish is so good.
Thank you, Claire.
Yeah.
Your Greek is also very good.
My Greek is questionable, but it's there. It gets me by. If you are live posting the event, please use the hashtag PosetteConf hashtag when you do that. That way it'll make it easier for people to find your posts. I don't know how many of you are into social media these days. It's very fragmented. We've got LinkedIn, we've got X, we've got Blue Sky and Mastodon. And we do have accounts on each of these socials. So if you're not yet following PosetteConf, you might want to do that. So just do a little search and it should pop up.
Yeah.
And now.
And now, if you can see here, this is a fantastic wall of speakers that are bringing their knowledge to share it with all of you. And we are going to have 1/4 of them today in our live streaming. You can see a list of all the speakers on that URL over there. You can also check interviews with them where they explain what the talk is about and also when they explain a few things about their personal life, because these are all humans. This is not AI speakers auto-generated. So.
And if you're listening to this and can't see the screen, it's posetteconf.com/2025/speakers. That's where you can find all the information. These 45 speakers, there's 42 talks, but they come from 21 different companies, which I think just highlights what Boris said earlier in the introduction, which is that people get together in this community from all sorts of different companies, many different countries as well, to share expertise and help each other and collaborate on the open source project. So huge gratitude, because without these speakers, this conference wouldn't exist. And to help you decide which talks you might want to, obviously you're here now, so you're probably going to watch some of the talks in live stream too, but maybe you're trying to figure out which talks you want to watch after the fact on YouTube after everything gets published. And so I did write this blog post to try to help you understand which ones might be most relevant to you. So I categorized, I subcategorized, I tagged, I tried to help make it easy to figure out which talks are relevant. So there's a QR code and a short URL on the screen.
Yeah, this is something that you do constantly with Posette, and with a good consistency about the quality of this blog post. It always helps me actually to figure out what are the talks that I want to see first. So thank you, Claire, for doing that.
It's a bit of work, but I'm happy to do it. Okay, virtual hallway track. What is a virtual hallway track? What is it? What is a hallway track?
Yeah, so the hallway track is that when you finish watching a presentation in a conference in person, then everybody goes to get some coffee, and then in the hallway you meet some other people and you start discussing like, hey, what do you think about what he was saying or what she was saying? And it's like, yeah, well, I actually agree with that, but I disagree with this entirely. And then you start having a conversation. So that type of the conversation is what we usually miss the most from in-person conferences, but we have that in Discord, as we were saying, where you can ask questions to the speakers and to the other people in the audience, where it's very important, again, to behave and be friendly with each other.
So we put the faces of all the speakers on this screen as well, just as a reminder that most of the speakers are going to be on Discord while their talks are being live streamed, because you might think they're giving their talks now, but the talks were pre-recorded. And so that enables them to answer your questions. And I think on Livestream one of the speakers, Tomasz Vondra, actually joined the Discord from an airplane. He was just boarding. He still had internet. And so he was there for a little while before the plane took off. So people are definitely making the effort. And when you get to Discord, the channels are all on the left-hand side. There's a sidebar, and you want to go to the #PosetteConf channel, obviously. So join us, please.
Yeah, so there is a pop song from the 80s that says that girls want to have fun. Well, do you know what speakers want? Speakers want to get feedback. So there is also going to be important feedback for the speakers so that they can improve their talks for the next conference. And also you can actually do some suggestions to some speakers. It's like, oh, I think that you gave a very nice talk about table partitioning. Can you give me a little bit more information about this maybe? And this also help speakers to get more ideas, or maybe help you, while you are writing the feedback, saying like, maybe I should give a talk about this. Just by providing feedback, you get some nice ideas for yourself. It's good to get feedback to people.
And if you've never given a talk, I don't know if it's obvious how much work goes into it, how much work goes into the outline and the storytelling and the slides and the practicing and the practicing and the practicing, sometimes in front of the bathroom mirror, making sure that, you're making eye contact. Anyway, there's a lot of work involved. And so in terms of feedback, we'll give you links in a moment where you can give survey feedback. And that's really important because that's something that will be written down. But people, if they showed up on Discord, they probably would love some questions or compliments that are live on the hallway track as well. Okay, there's swag too. So if you go to the Discord, there will be constant reminders about the swag that you can get. Just by attending and requesting it, there's stickers available, cool Postgres stickers, Posette stickers, talking Postgres stickers. And then if you do a written survey, then you will have access to these super cool Posette Year 4 socks.
Yeah,
so
this is one of the things that people say, like, I don't go to online conferences because they don't have swag. Well, this one has. So there you go.
There's 2 different surveys. So last year we got feedback that with 42 talks, people didn't like doing a talk survey that had questions about all 42 talks. Apparently it was like too much scrolling. So this link, the QR code on the left and the short URL that ends in LS2, that only has the 11 talks from this live stream. And we'll share later in the wrap up the links to the other live streams if you need that. So it should be easier to deal with. And then the event survey is something that we hope you all do after you're done participating in the event, because I know some of you are coming to multiple live streams. At the end of each of them, there should be a voucher, and that gives you a code. And then you take that code and you cut and paste it into the Posette swag thing. We wanted to keep the surveys anonymous, but obviously to get your socks, you got to give us a shipping address. So
I'm going to be completing some of the surveys, especially today when I watch the talk. And after watching the talk, of course, is better because if you do it preemptively, it will be like kind of time traveling, but we haven't get yet with the technology for doing that. So you probably better watch the video yet first, and then you do the feedback. Okay. Are you going to provide feedback, Claire? You don't need the swag, but are you going to be still providing feedback?
I am absolutely going to provide feedback. Although today, while I'm juggling being a host, I find that I'm not able to fully watch the talks. So I will fully watch the talks after the live stream is over, and then I will give feedback on each and every one.
So you can submit feedback afterwards. Until when is this possible?
Oh, so the deadline is, it says Tuesday, 18th of June, which is another like time travel thing because 18th of June is a Wednesday. So it's the deadline in the top left should be Wednesday, 18 June, and it'll be 11:59 p.m. anywhere on Earth. But yeah, better to get the feedback in earlier because if you're like me, you might forget some of the details. And it's the details that those speakers really and the organizers care about.
Yep.
All right, so let's look at the schedule for today. We're not going to dive into this. This is just a bit of an eye chart to say we have 11 fabulous talks for you. And instead of diving into this, why don't we let people speak for themselves in a trailer? Super quick, little short clips of each of today's talks. Sound good? Let's do it.
I want to watch this.
Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hi everyone, my name is David Rowley and I'm a Postgres committer at Microsoft. And today I'm here to talk to you about what's new in the Postgres 18 Query Planner. And this talk is going to be useful for anyone who's thinking of upgrading to Postgres 18 when it's released later this year, or anyone who's thinking of migrating to Postgres and wants to check in on the latest features.
Hi, I'm Jelte, and I work at Datadog, and I'll talk about how PGDuckDB can make your analytics queries in Postgres faster and easier to write.
Hello, my name is Heikki Linnakangas. I am going to talk about how we made Postgres serverless at Neon. Stay tuned if you want to hear how do cloud providers run services in behind the scenes.
Hello everyone, thank you for joining my session today. My name is Shinya Kato and I'm a database engineer at NTT Data Japan Corporation. Today I will talk about Postgres extensions. The title of my talk is Can we use Rust to develop extensions for Postgres? If you're someone who is passionate about Postgres extensions development or curious about how Rust fits into the picture, this presentation is for you.
Hi there, I'm Johannes from Mercedes-Benz R&D in Sindelfingen, Germany. In my session about Azure Postgres security, I'll dive into details how you can make your database more secure. And I will focus about network security and access management. I'll cover all the basics and explain how it works together. So no prior knowledge is required. I want you to be ready to build your own solution in this space.
Hello everyone, myself Palak Chaturvedi. I am a software engineer at Microsoft.
Hi everyone, myself Nitin Jadhav. I'm a senior software engineer at Microsoft. Today, myself and Palak are going to talk about debugging data corruptions in PostgreSQL, a systematic approach. We will explain our experience on handling corruption problems first, and then we will summarize with the approaches to handling corruption cases, including best practices. The attendees can apply these techniques to avoid corruptions at first place and also learn how to detect and recover from the corruptions if it happens.
Hello, I'm Ashutosh Bapat, major contributor to PostgreSQL. I'm part of PostgreSQL contributors team at Microsoft. Today, I will talk about logical replication, which is a relatively new PostgreSQL feature, and it receives a lot of improvements in every release.
Hello, my name is Polina Bungina. I work as a senior software engineer at Zalando, a European e-commerce platform. But I'm also a co-maintainer of Patroni project, and today I want to share with you some insights about how it works, which might be helpful for everyone who is building or operating high availability for PostgreSQL.
Hello, my name is Silvano. I work on Postgres in Microsoft Azure, and I'm here today to talk about .NET and Postgres as the next open source application development stack for your solutions that can run on your on-prem, cloud, mobile, and many other platforms and interacting maybe with the next-gen AI models that Azure is providing.
Hi everyone, my name is Nacho Alonso Portillo. I'm a principal technical product manager in the Azure Database for PostgreSQL team. In this session, I'll be introducing a fantastic feature in which we keep investing to extend its scope and evolve its functionality. You're interested in this session if you're a system engineer, a developer, or a database administrator who is struggling with performance issues.
Okay, that was pretty awesome. I love these trailers.
I made a mistake.
What?
Last year, when we did this with Jelte, we were wearing sunglasses, and I forgot to bring them today, and my eyes are hurting a little bit with all the lights from these stars that are going to be talking today. Because today is actually the best live stream. I'm happy that I'm invited for the live stream too. You can see, you can watch live. Oh, excellent, Claire. That's why you put them on while this live stream the
I
trailer
came
was
prepared.
happening. Yeah. Well done. So today's the best day, actually. No. I mean, the other days are also very, very good, but this one is the live stream that you have to watch. I'm super happy that they invited me to watch, to present this and to go host this. And actually, I would like to start with our keynote. So it's always good to have keynotes in conferences when you have time for allocate them, because it's a way of inviting somebody who is going to be giving you key knowledge, but also to kind of bootstrap every day of your conference. In this case, we are going to be having one of my colleagues, one of the person that I also enjoy watching and then talking about things inside Postgres, and not just Postgres, but databases in general, because he has a long history of contributing to the community and increasing the knowledge of many, many people. Now, that thing is not the fact that he's just talking about things from the past, because this keynote is actually going to talk about the new challenges that are in nowadays everybody's life. Everybody's talking about artificial intelligence and stuff like that. Now, a reminder, none of the speakers here is AI generated. None of the talk is being AI generated. So this is all people, humans that you can interact with in Discord and ask questions. And probably you're going to have many, many questions coming from the presentation of Bruce Momjian, who is actually also a fan of science fiction. And I remember that from a previous conference that we were discussing about this. So maybe there's going to be some discussion about how AI can influence science fiction and the other way around in the Discord channel. But now we are going to see his keynote, where he's going to be talking about databases in the context of artificial intelligence.
Let's do it. Let's watch.
Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. Today, I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation. Okay, let's get started. It's wonderful to be with you today. I really love this talk. I spent so much time working on it and trying to understand the intricacies of artificial intelligence. As you may know, I already have an artificial intelligence talk on my website, but this one is much newer, and it covers a lot of the new information about generative AI and RAG and so forth. If you're curious about these slides or any of the other presentations on my website, you can see my URL right there and a QR code underneath it. And that's where you basically see these slides and 62 other presentations if you're interested. We do have 86 slides here, so I am going to be skipping or going quickly through certain sections. As I mentioned before, I do have another AI talk called Postgres and the Artificial Intelligence Landscape. Again, URL there at the bottom. If you do download these slides, anything in blue can be clicked on, and therefore you would go right to that slide deck or to the website or whatever supplementary information I've shown here. But what are we going to talk about today? We're going to talk about the AI explosion, the huge amount of new information, new details, and interest in AI that is surprisingly new. Surprisingly, this whole AI sort of excitement is only in the past 18, 20 months. So we're going to talk about that. Then we're going to get into a lot of complexity. I am going to go kind of quickly through that. We're going to talk about hyperdimensional vectors, which is fundamental to AI. We're going to talk about how training happens, again, fundamental to particularly generative AI. We're going to then get more practical. We're talking about semantic and vector search. We'll talk about transformers, which is sort of the internal part of generative AI. And then we're going to talk about retrieval augmented generation. There's a lot of database use there. And then finally, deployment options. This is where I'm going to focus most of the time because there is a large component where databases can help. And I think this will be probably the most interesting to the audience. But again, you have to understand how AI works to understand where databases can help. If you just kind of launch in and try and use the database without understanding how they work, you can't really make the best use of the database. Where does it fit? Where does it not fit? I have some details about that. I think those will be particularly helpful. So the AI explosion, November 30, 2022, big date. I know it doesn't really register as a big date for you right now, but historically we may look at that as a big date looking back. The big interesting part was the release of ChatGPT 4. And it's basically the ability to have human-like conversations and human-like output, particularly at that point, text-like output from AI. And this was just foundational and really set the AI world in storm. And we're still really living in the ramifications of that date and that release. If you're interested about generative AI, I do have a URL right here at the bottom. It's basically a 6-part, probably 5-hour YouTube series about generative AI. Feel free to look at that. But to really define where we are today, we have to talk about the two types of AI. And up until, I would say, the ChatGPT 4, the general understanding of AI in the public was one that was discriminative or predictive. So things like classification, fraudulent credit card, that's a classic, image recognition, recommendations for websites, predictive trends, and even language translation were pretty much the bread and butter of AI before ChatGPT 4 became popular. But generative AI came in and really changed the public's perception of what was possible. Particularly ChatGPT 4, which was for text, and DALL-E, which I'm not going to talk about too much today, which is for images and allowed for the creation of AI image content as well. Generative AI use cases, we're still trying to understand what all of those use cases are, but things like chatbots, semantic search, which I'll talk about, summarization, language translation, of course, image creation, that's one of the creation of text, creation of images. And there are some software aspects, particularly code creation, code analysis. I've used that a couple times. Even programming language conversion, I've been pretty impressed with what is possible there. So you might want to look at, again, some of the URLs there at the bottom to get more details. Comparing the two, discriminative, again, before ChatGPT 4, really focusing on domain-specific problems and supervised learning. And it usually outputs some kind of prediction or recommendation, whereas generative AI requires much more training, but is much more of a general solution, and it outputs new content, which has really shocked a lot of people. Again, the concept of generative here is significant. For discriminative, you're doing the training, trying to basically create boundaries between various outputs or various probabilities of output. Whereas with generative AI, you're effectively creating these vectors in very high dimensional spaces, which I'll talk about in the next section. And those vectors are actually used to generate unique content. Really creative use of AI, I think. So hyperdimensional math, again, I said we were going to talk about some complex stuff. We are going to be talking about some higher dimensional math because that is fundamental to generative AI. Mathematics is very good at representing things that aren't possible in the real three-dimensional world. For example, thousands of dimensions, numbers of atoms that are far exceeding, numbers that far exceed the number of atoms in the universe, for example. Calculus, another example of representing infinite values or infinite processes. Again, really interesting. But there is a concept called duality, which effectively you can look at things in different representations, physical, computer, or even abstract. And that's where mathematics comes in. Now, most dimensionality vectors in generative AI use typically between 1,000 and 12,000 dimensions. Now, we live in a three-dimensional world, so it's kind of hard to understand what that looks like. But what I have here is an image of a 10-dimensional graph. And again, if this is 10 dimensions, imagine what 1,000 looks like. The range of values in that much of a dimensionality space is so vast that we really have trouble as humans, I think, conceptually understand what that looks like. Basically, that's all I wanted to talk about in terms of dimensionality. Then I want to talk about the training aspect. Again, generative AI requires a huge amount of training. That you basically create. I'm just going to go through a very simple example where you take every word in the English alphabet. Let's suppose that's 50,000 words. And you basically create a vector randomly for every one of those words. So imagine 1,000-dimensional space or 12,000-dimensional space. You just randomly create these vectors. Now, 50,000 vectors in 1,000-dimensional space, they have there's nothing near these vectors. They're just kind of floating there with no vectors near them at all because 1,000-dimensional space is just huge. So what happens after that is that you take a huge amount of documents and you basically adjust these vectors in these 1,000-dimensional spaces to make them closer or farther away from other words. Now, that might sound kind of like a non-useful thing to do, but what happens is you can make small adjustments to represent relationships between words, and that's typically how generative AI actually generates its output. Again, a lot of URLs here at the bottom, a lot of detail. But let's look at a simple example. I took the words king and queen, man and woman. This is the traditional 4-word example that most generative AI uses, and I randomly placed them in this 2-dimensional graph. Again, not 1,000 dimensions. But what I do is I take some statements like the king is a tall man, and I basically move each word closer to the other words in the sentence. So king moves closer to tall, king moves closer to man, and so forth. So you basically take the thing, you break them up into words and you move them mathematically, because king is normally appearing with the word man or tall or whatever. Queen is normally appearing with woman. Beautiful is normally appearing with woman or queen. And castle and throne are typically together. And you can see how words start to move a little bit. And again, they're in such a huge space, it's actually not a huge problem. But again, the words are moving closer a little bit at a time. A lot of mathematics involved here. This is particularly why it's a very compute-intensive process to do training for generative AI. But at the end, what we have is a new relocation for these vectors. Man and woman are very close together. As you can see, king and queen are very close together. But also, the distance between man and woman is the same as the difference between king and queen, because in that training process, we've kind of moved things toward each other as part of the training and the math. So what you end at the end is something called a text embedding. This is not a picture of that. This is just a basic implementation of what a vector would look like, where it has so many different components. And again, you're making small movements for each word, depending on how one word appears near another word in the text. So having done that, I'd like to talk about semantic and vector search. We're all familiar with text search, full text search, which effectively has a word and tries to find another word in the same text. But semantic and vector search really is a new way of doing searching. And it uses the training data that we just talked about to allow you to basically search for a word that is near perhaps another word in that 1,000 or 12,000 dimensional space. I know that's kind of hard to grasp, but I'm going to show you some examples, and I think it should be useful. So what we do is, to do semantic search, we first download a pre-trained text embedding. So somebody's gone through the training process for us. We don't need to do that. We're going to create our own text, and we're going to basically download one, or we might create our own. And then we're going to chunk the text into sentences or paragraphs or documents. And then we're going to basically find the text embedding of every word that is in our search. We're going to average those vectors, and then we're going to store them in a database. So in step 3, we're basically going to take the document, not search it yet. We're going to take each each sentence, break it up into words, look up the words, average the words into a vector, and store that vector in a database along with the chunk. And then to do a search, we're effectively going to take the search. We're going to take the words in the search. We're going to average the words in the search. We're going to create a vector, which is the average of the words in the search. And then we're going to search for the closest neighbor. If you're familiar with nearest neighbor search in Postgres, this is exactly how it works. So I'm going to give you an example. I have a set of text here. The king is a tall man. That's my first sentence. Queen's a beautiful woman. They sit together in the throne room of the castle. I take my first sentence, average 6 vectors. I create an average of that. I store it in a database, second. Same thing for the third. And now I'm going to issue the search. So I've stored 3 vectors, and I said, who is the king? That's all I said. And the result I get back is the king is a tall man. And the reason I get that back is because when I take who is a king, I get the pre-trained or vectors for the 4 words. I average them together, and I say which sentence is closest to that result. It turns out the king is a tall man is the closest. How does this actually work? I don't have time to really go into detail, but I'll show you just a little real world example. I install PG Vector. I create a document table. I create an embedding table. I load my sentences into these tables. I then run a Python tool, which will look up the OpenAI embeddings for my text. And I basically store those embeddings in the database. And as you can see here, the king is a tall man has an embedding in red. The queen is a beautiful woman, the same thing. And they're all basically stored in the database. Now to do a search, I basically take the text somebody gives me. I again look up the OpenAI embeddings for those words. I average them. And then you may recognize the nearest neighbor operator here, the less than dash greater than. And I effectively do a search. What's the closest one? And I get the answer. So for example, who is the king? The closest example is the king is a tall man. Who is tall? Again, the sentence is the king is a tall man. That's pretty straightforward even for a full text search. But if I ask who is short, I get the king's a tall man, which might surprise you, but short and tall are related. So it thinks that those are the best matches. Who is pretty? The queen is a beautiful woman. It knows that because it's using the OpenAI trained embeddings, it knows that pretty and beautiful are related to each other. Who is in the palace? Again, it knows palace is typically in a castle. So it gives me that sentence. And find where is the chair? It knows that that sit is related to chair, and probably also that throne is related to chair. So it gives me that answer. That's all I wanted to talk about in terms of semantic search. I'm going to talk real briefly about how generative AI works. Again, I recommend you go to my website if you want to watch a video of me giving this talk in a larger format. So there's something called transformers. Transformers effectively create these blocks, which can use a pre-trained algorithm to create new text. Of course, GPUs are very useful for this. So they create something called attention blocks, which I'm not going to cover, but effectively what happens is the way the generative AI works, we have a text like, what is the capital of France? And effectively we look up the vectors for that. And then we run through a process. I'm sorry, I'm going to have to go so quickly. We run through a process where we adjust the vectors for each of the words based on other words in the question. So for example, capital in France, those get moved closer together. And as we run through these attention blocks, you can see there's a lot of computation going on. We're slowly moving the vectors closer to each other. And then finally, at the end, we get the last vector represents the first result word that we should return to the user. Then we run the process again. We get the second word and so forth, and effectively becomes a machine that generates text. It sounds crazy, but it actually works. So generative AI, let me give you an example of this. For example, what is the capital of France? It knows that the capital of France is Paris because capital and France are close. It moves France close to capital. And once you do that, the resulting vector is actually very close to the Paris vector. Very similar to how king and queen moved around. Capital France is, it knows what that is. I'm showing you here some adjustments. There is another Paris in Texas. So if you say Columbus is in Ohio, where is Paris? It doesn't, it does mention Texas there. If I say I live in Texas, where's Paris? It actually talks about Paris, Texas, because the word Texas moved the Paris word closer to Texas and farther away from France. It's kind of interesting. Let's talk about how databases can be used here. There's a very common, popular retrieval augmented generation capability for AI, which uses databases. So I can actually say where is Paris, and what happens is that we can create a JSON document which effectively looks exactly like this, and you pass this to the AI system, perhaps with some other information. That's what RAG typically does. It adds information, and we get some results. So if in RAG, what you do is you have some pre-training information that precedes the query the user types. And typically this information comes from a database. That's why RAG is used. Retrieval augmented generation means we're augmenting our retrieval with some database information. So here I'm retrieving it in red here. Here's a better example. I actually can augment my information with some JSON data that I retrieved from an order entry application. And now I can ask questions like, when were the orders made? And the output is actually using that JSON information to give me information related to those invoices. What's the earliest invoice? It knows that. It can read the JSON. What's the total of all invoices? It can do calculations for me. Kind of crazy. What is the average invoice amount? Again, it's using that data I retrieved from the database, and it's actually giving me an average of those invoices. I can even ask for payment information. I say today is April 15th. What's with 30-day payment inspection, with which invoices are overdue? It actually walks through this. Incredible how that works. You can even ask, what is the total invoices that are not pencils? And it can do that for me. Again, it's reading the JSON document that I prefixed to the query. And you can imagine how an application programmer would use this as well. Today, what is the next expected order date? And it actually looks at the days between orders trying to predict. Okay. You can even ask it to generate an SQL query for you. Here's an example where I actually do the RAG call, but I specifically pull the JSON document from Postgres and then append it to the query. Okay. So this is the talk I wanted to kind of finish with, and I think is most valuable for you. And that is, how do databases make sense for an AI workload? First off, obviously you can do generative AI in a whole bunch of different ways, cloud, self-managed, and so forth. But this slide, I think, is really helpful. On the right and left-hand side, it talks to the various AI features. The middle, it talks about details. But at the right, it explains if this is good for AI or good for databases or not. So semantic and vector search, I already showed how that can be done very easily with AI. Text embedding, vector training, probably not good with a database. There's just too much computation. Database strength really doesn't benefit there. Doing transformers, probably not a good place for a database. Retrieval augmented generation, I've already showed you how that can be used really well. Language queries on retrieved data. I think there's a huge potential here of allowing non-SQL language people to query a database and get a reasonable answer. Data analysis and regressions, I think it's very good. And again, even generating SQL queries, I think, on the fly is something that's going to be interesting. I have a URL here at the bottom about that. There are a lot of Postgres AI solutions. I've already talked about PG Vector. Tembo has one, EDB has one, Timescale has one, PostgreSML has one. All the cloud vendors seem to have them. There's something called Lantern Cloud. There's WorkKit, PopSQL, a bunch of different ones. And again, DBTune for server tuning. So this is in its infancy. I expect a lot more AI solutions to come along. Now, in conclusion, I just want to give you sort of a sense of where the landscape is for AI. Again, AI has been around for, well, back in, I don't know, hundreds of years, where they were thinking about what AI, what a computer, what a machine would look like. How do machines change man's relationship to the world? That's the pre-computer understanding of AI. We had the Turing test in the 50s, expert systems in the 80s. AI winter was really a sort of a down area for AI. There wasn't a whole lot of thing going on. 2010s were robotics, but really, surprisingly, 2013, this is really where it took off, at least academically, with something called Word2Vec by Google. And then the concept of attention blocks in 2017 really laid at least the academic groundwork for what happened in 2022 with ChatGPT and DALL-E. And again, we all know what has happened since then. How did Google miss the boat? They basically were so focused on their core business, they didn't understand that generating new content and bringing content from multiple websites together to sort of amalgamate and aggregate and summarize information was actually going to be useful to users. Again, they have Gemini, they're trying to catch up. But again, this is one of the reasons I think they weren't the first in this industry, even though they had done a lot of research before them. And I'm going to just close with these two quotes. And again, you have to think about what they mean. But what this gentleman is basically saying, that if you told me this is in 2013, if you told me a year ago we'd be able to do all these things with AI, I would have told you it wouldn't happen probably in my lifetime. And now, within 1 year later, it has happened. And he's basically shocked. And I totally understand that. But the second quote is also important. And this is a cautionary tale about what we expect from AI. Basically saying that we used to think the idea that people could express themselves or manipulate language was smart, but that's not true. And I think I've shown you this already. You can manipulate language and not be smart. And that's basically what these large language models are demonstrating, because that's exactly what I've shown you when I showed you the transformers, how basically it's using vectors to generate data. It doesn't understand what it's saying. It merely is able to generate it. So I hope this has been helpful. Again, my main focus was to explain what generative AI is, what it does, and then try and merge that with the database needs to try and explain, okay, here's what it is, here's where databases can help, and here's where databases maybe don't make sense. And hopefully that will help you to have a better understanding of where you can take AI with your current database needs and requirements. I think this opens a whole new chapter for what databases are going to be possible for, and it's going to be a very exciting time going forward. Thank you for listening to me today.
Bruce is such a good explainer.
Yeah, I mean, it was very nice presented, and with some points towards other stuff that we can start investigating, so that we are not just with this information. So thank you very much, Bruce.
Thank you very much. If you have feedback about Bruce's talk and you want to use the survey now rather than wait till later in this live stream, I'm dropping the QR codes and the short URLs on the screen right now. And then once you do that survey, just grab the code and you can go and give your address. So please, feedback is a good thing. And if you joined late, what do you need to know?
Well, just join the Discord channel, where this is our hallway track, where we can interact between all the participants of this live stream, which is the speakers. We are there, to be clear, and we are also with all the people who are watching this live streaming, and we can ask questions and then interact a little bit more, and maybe establish some connections for the future, and then collaborations between the members of the community.
And the connections for the future, that's kind of how it all works within an open source project like this. So yes. I first met you, Boris, at a Postgres conference. So
yes, I remember.
New friendships, new partnerships. Okay. So yeah, and the speakers are generally there, unless it's a weird time zone problem during the live stream of their talks, because everything's pre-recorded. So please join us on Discord. And you can also get swag. Even if you haven't done your survey yet, you can submit to get stickers and go to aka.ms/posette-swag. And with that, I think we should introduce our next speaker.
Yeah, and I was talking about future collaborations, but I would like to bring a story from my past career. So when I was working at Second Quadrant in the first year, I think it was really new to the whole thing, the community, and I was having some questions about the table partitioning. And somebody said like, oh, you need to send a question to David. He's an expert. And I sent the question, and I was super surprised that somebody with such a big knowledge took a lot of time to explain me my question and then gave me the answer to my question, and then give me a very detailed steps about how it was implemented and where should I look forward for other information. So now that you are watching this, David, I still remember this. I think it was like 6 years ago. Thank you very much for spending time explaining me that question that I had about table partitioning.
Well, and David has been involved in Postgres first as a user since about 8.2, and then he's been working full-time as a contributor to Postgres since 9.4 timeframe. He lives in New Zealand. He's on the Discord now if you have questions or compliments, and he's a bit of a performance fiend, and I think that started as a kid. I know as a teenager, he used to like tune motorbikes to try to get them to go faster, and it seems like in every release of Postgres, he is doing something to make the database go faster. I had the honor of having David as a guest on the Talking Postgres podcast, as was Bruce Momjian. I just dropped the link to the Bruce episode in the Discord. But David shared his story about how he got started as a developer and in Postgres, and there was cheese involved. I'm just going to say that. There was also some forklifts involved and some traveling across Australia. And this talk it's called What's New in the Postgres 18 Query Planner and Optimizer. And I haven't seen it yet, so I'm really looking forward to it because he wrote a blog a couple of years ago, very similar title, but it was about Postgres 16. And he did some great like before and after comparisons of the explain output to show how things were different. So I'm hoping he doesn't just tell us and that he shows us again. We'll see. We'll see what we get. Let's roll the tape.
Yep.
Hi everyone, my name's David Rowley and I'm a Postgres committer at Microsoft. And today I'm here to talk to you about what's new in the Postgres 18 Query Planner. And this talk's going to be useful for anyone who's thinking of upgrading to Postgres 18 when it's released later this year, or anyone who's thinking of migrating to Postgres and wants to check in on the latest features. Okay, so let's get started. So just a little bit about me before we start. So I've been working on Postgres for about 12 years now, full time. And for 6 of those years, I've been a Postgres committer. And so I mostly work on performance-related features. Quite often that's inside the query planner itself, and sometimes more general performance improvements, and quite often maybe execution performance improvements. So if we get started, but first a little caveat. So the Postgres feature freeze for 18, that started on the 8th of April, which for me, this is pre-recorded. That was 3 weeks ago. And what the feature freeze means is this is a point in time where we stop accepting new features into Postgres and we start to try and stabilize the release. And because that is not so long ago, it's possible that something changes between when I've recorded this and when the actual release is made, which is around September, October this year. So yeah, with that caveat, it has happened before. And one of the features that I'm going to talk about today previously was in Postgres 17, I think, and did get reverted. So let's hope that doesn't happen, but it is possible that it does. So I'm going to break this down into 2 parts. And part 1 is just about what's changed, what smarts have been added to the query planner in Postgres 18. And then part 2 is more sort of general planner performance improvements, thing that it's not necessarily like a new smart that's been added to get the planner to produce some kind of plan that it didn't before. These are more sort of performance related things. So if we get started on part 1, and just about the format that I'm going to use here, in each feature that I'm going to talk about, I have pasted details about the actual commit. So if you want to go ahead and get more details about this, then you could look up that commit number. And these commit messages are often quite long for these features. So I've had to truncate them off in pretty much all cases here because it doesn't fit on the slide. So there is more detail if you look these up. And also the author, as it appears in the commit message, that is the committer. And quite often that differs from the actual author of the patch. And to highlight the actual authors, I've just put a little speech bubble on the left. So look out for that. If one is missing, then you can assume the person who committed it is the author. So for this particular feature, effectively, if you have a where clause and you have a condition like where column equals some value or the same column equals some other value, and you have an index on that column, that is now effectively converted into an in clause. And what this sort of fixes is quite often previous versions of Postgres would implement this OR clause by doing bitmap heap scans with a bitmap OR to join. And there'd be one of those effectively per value that you're looking up, per OR clause and branch effectively. And that could cause problems. If here I've only got 2 in this example on the top, but in theory you could have dozens or hundreds of these, and that would make the plan much bigger than it needs to be, and that would slow things down in terms of like executor startup and shutdown. And so this effectively helps resolve that problem. So if we go into a quick example here, and I'm creating a table called parts. This table is going to feature quite a bit through the talk. I've tried to be consistent and stick to this table so it's just easier to parse. And the things to note here are that there's a unique constraint on the part code. And the query that I'm going to run at the bottom here, if you look at the select star from parts where part code equals ABC123 or part code equals 123 ABC. And if we step forward and just look at how here I've got the explain output, so I'm hoping you're comfortable with looking at that, but I'll try and just describe what is happening here. So in the top box, and this is the output of explain for Postgres 17. And you can see that at the bottom, we've effectively got 2 bitmap index scans. Effectively, it's scanning the same index twice. And if you're looking at the index condition, you can see our values that we're looking up, the ABC123 and the 123 ABC on the lower one. And then if you follow up, you can see the bitmap OR. So that's effectively, it's generating a bitmap of the matching physical addresses of the tuple that it found during the index scan. Then it creates a union of those from each side. And then it does a bitmap heap scan on the actual part tables to find the actual tuples that exist in the heap. And that is suboptimal. So if you look at the bottom box in Postgres 18, it just does an index scan. And you can see that it's using equals to any, and then there's an array of values to search for. And that's going to be more efficient to execute. And it's going to be cheaper to start up that plan and shut down that plan, which is something that has to happen every time a plan is executed. So onto the next change, self-join elimination. So like, what is self-join elimination? Well, Postgres for quite a while now has had the ability to remove unused left joins from the query. And effectively, the place where that benefits probably the most, where it applies the most, is probably when views are being used. And you might have defined a view that joins a bunch of tables to get additional information, but maybe sometimes you use a subset of the columns from that view when you actually use it. It could well be that you don't necessarily always need to join those additional tables in all cases. And for a while now, Postgres has allowed this to happen for left joins. So this commit for Postgres 18 effectively allows this for self joins. And this can apply when applies when there is an equality condition joining the two tables. And that equality condition effectively has the same column on either side of the condition. And there's also some kind of unique index to ensure that duplicate rows to ensure the join doesn't cause duplicate rows. So let's move on to a quick example. The parts table has returned. And here you can see, if you look at the query at the bottom, I'm joining the parts table to itself on the part ID. And so if we look at how that is executed by Postgres 17 and Postgres 18, on the left, I've got Postgres 17's output. And you can see, you don't have to look in detail, but you can see there's a join happening there, hash join in this case. And for Postgres 18, no joins, just a sequential scan. Effectively, the P1 has been completely removed from the plan. Just a little bit more about that. Like I have actually, it seems like who would write that query and who would do that? Like, why would you end up with a query with where the same table is joined multiple times? And I have seen it in the past where in a previous job, we had an application that was over 10 years old and there was a bunch of views defined. So you get somebody maybe embedding quite complicated logic inside a view, and then years later, maybe another developer would come along and they would need to create another view, but they would find some logic they could reuse from the original view, but there was some column missing. So then you hit a dilemma. Do you modify the original view and add the column that you need and risk maybe breaking things that do select star from that view? Or do you just join a table again in your view and call it done? But the problem with the second part, like the latter one, would be you're joining the same table twice, and effectively that's a waste of effort. So this commit helps with that. So the next change I want to talk about, effectively this improves set operations in Postgres 18. And set operations are like unions, accepts, and intersects. Union is the most common set operation, I would say. Accept and intersect are less common, but they do exist. And this particular change affects only accept and intersect. So let's look at an example of what's actually changed here. So I've deviated from the parts table slightly, and I have a table A and a table B, which I'm going to insert 1 million records into each of those. I'm going to run analyze to gather some statistics so that the planner can make some informed decisions about how to execute this. And then I'm going to run select star from A, except select star from B. So basically, give me all the records in A, subtracting all the records, matching records from B. And let's look at how that has been executed. And so on the top box with Postgres 17, I think the biggest thing to pay attention to is probably the execution time here. And for Postgres 17, that's 354 milliseconds. And for Postgres 18, it was about twice as fast. And there's a few details here that are quite interesting with Postgres 17. You can see that it sequentially scans both tables at the bottom of the Postgres 17 box. And then there's a subquery scan. And that subquery scan doesn't exist in the 18 version. And the reason that that doesn't exist is this worked quite strangely until this changed. Postgres 17 would add a little flag, a 0 or a 1 to either side of the accept, so that it could later identify where it came from. And to do that effectively requires a projection step. And that's why the subquery scan exists in 17. And the planner is effectively able to eliminate that in Postgres 18 because the target lists are effectively the same. There's no effectively junk columns that need to be removed before it's actually output to the client. And one thing to note about the Postgres 17 is effectively, if you look further up at the append, that's effectively concatenating both sets of results. So mixing them all together effectively, and then it's sorting it. And it sorts it by the entire select list plus that flag at the end. That flag becomes the 0 or 1, effectively becomes a tiebreaker. And then that's fed into the set operation, and that looks at that flag to figure out which side it came from. And this feels like very old design in Postgres, because we have means to identify where the row came from by other means, because we have things like joins that have an outer and inner side. So Tom has modified this to effectively use that modern infrastructure. And what that allows us to do is it allows us to use pre-sorted input. In this case, I've got an index to allow the records to be obtained already in sorted order, and just feed those directly into the set operation. And for this particular scenario, that's double the performance of this query. So the next change I want to talk about, I committed this one. I wasn't the primary author. But basically, Postgres has had the ability to remove redundant group by columns using primary key indexes for quite a long time. And what that allows, why that can happen is effectively if you have a group by clause that contains a primary key and then some additional columns from the same table, because the primary key is guaranteed to be unique, having those additional columns in the group by clause doesn't make it any more unique. So effectively, we can just silently get rid of those and return the same results. So this change effectively expands on that to allow the same to work for unique indexes. And there is a couple of things that need to be met before that can be allowed. So there has to be a not null constraint on the column that is in the unique index. Expression indexes won't work because we can't have a not null constraint on an expression index. If there's no not null constraint, then the index needs to be defined as nulls, not distinct. And that means there can only be a single null value rather than multiple. So ordinarily, the uniqueness is not enforced for nulls, but nulls not distinct changes that to allow that to be distinct. And if we just look at an example, parts table is back, and I've got a unique constraint on the part code. And I've introduced a sales table just so we can actually do something a bit more meaningful with this query. Sales table just has a part ID, the same as the parts table. So that's going to be our join condition. And the query I'm going to run is just an aggregate query. I want to know say this is run at the end of the month. We want to look at the total sales for some period of time. We want to group by the part code, and we want to take the sum of the quantities sold. So you can see here that because you can't memorize, or I can't memorize all the part codes, we need some meaningful description. I have added the part description to the select list. And because I did that, I had to also add it to the group by clause. Otherwise, Postgres would complain that I'm missing a column from the group by clause. And if we look at the actual explain output from both, you can see that on the left, Postgres 17 has got both those columns in the group by clause, whereas in Postgres 18, it's eliminated the additional column, that part description, from the group by. So I think that's probably, it's going to be quite useful there. This is a hash aggregate, so effectively it's going to be much cheaper to obtain that hash value when the executor is building that hash table. And also, you can imagine that the part description is much longer than the part code, so it's going to be quite a lot cheaper to actually only group by that single column. So now I want to move on to part 2, and this is general query planner performance improvements that have happened in Postgres 18. So let's have a look at what's happened here. So Tomas has made a change here, and the top line of the commit message is increased number of fast path locking slots. So what does that mean? So whenever we do anything in Postgres, we have to obtain a lock on the object that we're going to use. So if you're running a select query on a table, we must obtain a lock on that table. And that prevents things like other concurrent sessions from doing a drop table or some other operation that conflicts effectively with what we're doing. So that ordinary locks have to be coordinated between all backends, but for certain sort of lower strength locks, like the strength of lock you would take to do a select, they're eligible to be fast path locks. And what that means is we don't have to go to this shared location that coordinates between all backends. It can go to a local location and check that we can lock that. And what that actually allows is, well, basically that gives you, up until now, there's been 16 slots for those fast path locking slots. And with partitioning workloads, you could quickly run out. 16 partitions isn't a huge number. So if you had, 24 partitions, then you would quickly fill up. You consume all those 16 locking slots, and subsequent locks will need to spill out into that shared lock table. So if we look at the performance of this here, what I've measured is I've created 2 partition tables, one with 16 partitions and one with 32 partitions. And I'm just doing these tables are empty. So what I want to measure here is just the overheads of obtaining these locks at executor startup. So you can see that Postgres 17, and by the way, if you're struggling with the colors, the bars in the graph are in the same order as they are in the legend at the top of the graph. So you can see on the left, we've got Postgres 17 with 16 partitions. And up until, once you hit 32 concurrent running sessions running this particular query, you can see that Postgres 17 starts to slow down. And by the time I get to 64 concurrent sessions, it's really starting to slow down. And if you look at the next bar to the right, and that's the 32 partition case, it's much worse. And the thing, even with the 16 partition test, we obtain locks on 16 partitions, but there's also the partition table itself. And we have to obtain the lock on that partition table as well. So there's actually 17 locks there. So in the 16 partition test, there's actually 17 locks, and that's causing even that one lock that spills over into that shared lock table is starting to cause sort of contention at that common point that all these sessions are touching. If you look at Postgres 18, this is the blue bars, and things are much better. And the scalability is much more linear as we increase the connections. So this change that Amit committed, this effectively changes the order of operations for runtime partition pruning. So when the query planner is unable to do partition pruning, it's possible that if the value being compared to the partition key is maybe a parameter that comes through a prepared statement, or if it's a result of a stable function, then the planner doesn't have access to see what that value is at plan time, but the executor will. So we can defer that partition pruning until execution. But the problem with that is the planner still has to generate a plan with every possible partition that could match. And then it's up to the executor to prune the ones away that don't match the value being looked at. But the problem was the order of operations. So always when we start up during execution startup, we have to obtain locks on every table that we're going to look at during execution of that query. But the problem was we're taking those locks before we did that runtime partition pruning. So if you had, for example, 1,000 partitions in a plan, and you pruned all but one of those during execution, we'd still take 1,000 locks. That's now changed. We now do the runtime partition pruning before obtaining the locks on the partition. And that improves things fairly massively. And we can see here, along the bottom, I started at 1 partition, and I'm just doubling that each time until I get to 8,000 partitions. And you can quickly see that the Postgres 17 doesn't scale well. And just keep in mind the unit of measure here is in microseconds. So this isn't a large amount of time. Even for the 8,000 partition case, Postgres 17 took 1.8 milliseconds. So it wasn't slow. So this really only affected things if the query you were running was very fast to execute. If the query had taken several minutes to execute because it was looking at lots of data, you wouldn't really have noticed this. It's really only for fast to execute queries. But the more partitions you have, the more you're probably going to benefit from this change. If we look at the scalability for the Postgres 18, then it's fairly linear. There's sort of a very small slowdown as we get to higher partition counts. And I've actually identified what that is, and I do have an actual patch pending, which I might submit to Postgres 19, which maybe we can fix that. But it's sort of diminishing returns now because the bulk of the problem has been solved by this change. So another planner improvement that has been done in Postgres 18, and Yuya Watari has been working on this for quite a number of years now, and that patch went through multiple evolutions and design, and it's finally landed for Postgres 18. And this improves internally in the planner. We have these things called equivalence classes, and those define that basically for any given row they record where two columns are equal to each other. What that allows is things like if you have a query that's, say, select star from table where column A equals column B, then you have an order by clause to say order by column A. Then the query planner knows that that is equivalent to order by column B, and that allows a bit more flexibility. So you have an index on column B, then it can use that index to provide pre-sorted input for that order by clause. So this change effectively, the problem was that with partitioned workloads, the number of members, i.e. the number of columns that are defined as equivalent within those equivalence classes, when you have partitions, it would always add another member for every partition. And that caused problems. If you have thousands of partitions, and we could end up with thousands of these equivalence members. And the problem was the actual internally within the planner, when searching for those, it was a linear search. So that search would become slower and slower the more partitions that were added. But also the more partitions that were added, the more number of searches that we had to do. So effectively that caused a quadratic slowdown. And this commit fixes that problem. And if we look at the performance, again, I've started at one partition here. I'm doubling that each time. I didn't go to the full 8,000. I only went to 1,024. And the reason for that was because the performance difference was very large with, it was 9 times faster with 8,000 partitions, sorry. So with 1,024, it was twice as fast to plan this. So this is only query planning time to plan this query with that number of partitions. So this is fairly significant. It's been a known problem for quite a while in Postgres, and hopefully this is going to solve that. So certainly those changes are not the only changes to the Postgres query planner. I just had to pick some, and there is other changes here, like for example, Windows users work mem used to be limited to 2 gigabytes, and that restriction has been lifted. 2 gigabytes is not a very significant amount of memory these days. And there's other stuff. There's select distinct queries are now able to sort of internally reorder the columns in the distinct list. There's no visible change in the output, but that allows indexes to be used that previously weren't considered. So now is probably a good time if you have a test environment and you're thinking of upgrading to Postgres 18, then try these out. Like there should be beta 1 or beta 2 should be out by the time you watch this. And there's a link there if you want to get in and test. You know, the earlier we can identify problems with these features, the better. The less chance we've got of finding something late on before we release and possibly having to delay the release. So I'd encourage you all to get testing and give us some feedback, good or bad. You know, it's all welcome. So now I should be lurking, future me should be in the chat somewhere, and I'm happy to answer any questions anybody has.
I love that he talked about future me. Well, present David is present on the Discord, on the virtual hallway track, and he's been answering questions.
Yeah, absolutely. And also discussing about his podcast with you, which I also recommend that people go and listen. I listen to nearly all of your podcasts, Claire, and David is one of the nice ones over there in the story. And
Well,
from
you-
this talk, I really like the way that he explained the self-join removals, because it feels like, okay, who needs that actually? But then he come up with a real case scenario where it was actually needed, and at least little improvements that come in Postgres in every release is super nice, and getting the information from people like David is fantastic. So thank you.
David has a concept of what is a good Postgres release for him. And I talked to him once and he was like, oh yeah, this was a really good release for me. And another year it's like, yeah, this wasn't my best Postgres release. And I guess it's because he puts all this work in, but then, the results are in the details and in the benchmarks and in how much of a performance improvement did he really deliver. So we have to ask him in the Discord, like, was Postgres 18 a good Postgres release for him?
Yeah, no, and I actually also like to see things like from Thomas Vondra improving log performance and stuff like that. He also he shouldn't even need to complete the survey to get swag, because the swag is fantastic. But I think still in that case, people should provide feedback. Yeah,
Speakers should provide feedback on other people's talks, maybe, or on the event as a whole. And yeah, that's the only way to get socks. So do fill out the surveys hopefully before you forget all the details, so you can give useful feedback to make things better for next year. And I put the QR codes on the screen. So because David was a guest on Talking Postgres, I just put that thumbnail up there so that people will recognize the show, hopefully subscribe to it. We've had an all-star roster of guests. In fact, our guest next week for episode 28 is going to be Peter Cooper from Postgres Weekly, who's going to talk about 12 years of running Postgres Weekly. So it should be interesting. But let's keep going with our plan and our next introduction. Boris?
Yes, this is a person that I have the pleasure to co-host last year, Posette. Really fun, but not just fun. The knowledge that he has when he starts talking about stuff is super interesting. So we have met in conferences and meetups, and I always try to follow his presentations. Now, talking about music, I really like heavy metal. Heavy metal is known for really fast notes and fast riffs. And people sometimes just want faster. It's not always better, faster, but in this case, he's going to be talking about how to get faster queries for analytics from Postgres using an extension that is going to go to MotherDoc, which is based on DuckDB. And actually what I like that Jelte is doing is that he's bringing also the community from Postgres and DuckDB together. So let's see what Jelte Fennema-Nio has to say in this presentation. So let's see his talk. Yes.
Let's roll.
Hi, I'm Jelte, and I work at MotherDoc, and I'll talk about how PGDuckDB can make your analytics queries in Postgres faster and easier to write. So yeah, now we'll go talk about PGDuckDB and how it makes ducking awesome analytics in Postgres possible. So yeah, we'll start straight off with what is PGDuckDB. And well, PGDuckDB is a Postgres extension that embeds DuckDB inside Postgres. But probably that's not immediately clear to you what that means. So first, we'll take us a bit of a step back. Postgres, as you all know, is a pretty amazing database. It's open source, there's many contributors, it's very stable, and there's many other good things about it. One of those also being that it has so much functionality. Every release gets extra functionality. And if the functionality not in there, then it's very extensible. So there can be extensions that add that functionality. And it's also great at transactional workloads, which means it can very easily find a specific user in the database, or update your shopping basket, or show like your current shopping basket. Get the data that is needed to display all that from the database and put in that very fast, very efficiently. However, it's not great at analytics, or sometimes called OLAP. What that means is if you need to actually read all the data to answer a query, instead of sort of finding the right data, like finding a specific user or finding item in a shopping basket. But if you actually need to process, for instance, all orders to find out what the most sold product was, or the top 10 most sold products from the last month, or from the last N months, and sort of display those in a nice, like, because you want to display those in a nice graph in some dashboard. That Postgres is usually not great at that. And it sort of gets, like this elephant under the box. It gets pressed down, is like it doesn't like it. So why is it not great at OLAP? The main reason is usually because there's no columnar storage in Postgres. Postgres stores rows of data on the actual disk. So every row is one specific item. And that is great for if you want to just show all the data for that row, like if you want to show a user profile. But if you want to scan lots of data, that means that maybe you have to scan all the data in all the different columns because you want to see all the rows. And even though you maybe only care about like 3 rows, and you only care about 3 columns, but for all the rows, you need to scan maybe 50 columns because that's how many columns the table has. And that makes it much slower than it actually needs to be, because you're reading lots of data that you don't care about, that you're basically throwing away right when you read it. The other reason is that Postgres has very limited parallel processing. If you want to process this, like large amounts of data, these days computers have lots of cores, so doing stuff in parallel is very important for making it go fast. And Postgres is not really designed with that in mind. It does have parallel processing these days, but it's sort of bolted on a bit. It's not sort of designed from the ground up with parallel processing in mind. So not all the, like many of the sort of Postgres internals, they don't work in like a parallel way. They're very sequential. Only specific things are made parallel Postgres. So that's sort of where DuckDB can come to the rescue. That DuckDB can save Postgres from its stack of books that is underneath, and that is because DuckDB is a lightweight in-process SQL analytics engine. It does have this columnar storage. It's built with multi-threading in mind. It's like there's one of its core design principles. Like lots of things need to be parallel, and it tries to make stuff go fast in parallel. But what else does that lightweight in-process stuff mean? So let's take a look at 2 databases. Like we have Postgres and SQLite. Postgres, as you all know, it's a transactional database, like I explained before, and it's using a client-server model, which means that a client will connect to the Postgres server, usually over the network, and that makes it very nice, because then for certain applications, because you can have multiple web servers all connected to the same database. But SQLite is a different database. It's also transactional, but instead it is something that you load inside a process. So, for instance, it's used inside your web browser to store some things that the web browser needs to store, and then you can use that without going over the network. You can store stuff in a format that is well suited for transactional workloads, but you can still use it inside a single process without having a dedicated server. So it's sort of 2 different use cases. And DuckDB is another type of database. It's similar to SQLite, that is in process, and it's also a shared library, so you can load it in Python. It will just run inside your Python, or it runs inside your browser in Wasm. You can just download sort of the DuckDB binary and sort of execute it inside your browser. But instead of being a transactional database, like I said, it's an analytical database. and it's very fast at it. So just a small recap. Now we have these two databases, Postgres and DuckDB, good at different things. Postgres being good at transactional workloads, DuckDB being good at analytical workloads. And that's sort of where that's sort of the idea we're trying to make them one. Because DuckDB is in process, it means we can maybe put it inside the Postgres process, because Postgres is a process, so we can put DuckDB in there. And then we just load the shared library and everything will be faster. And we will have a client-server database that is both transactional and analytical. And that's sort of what PGDuckDB tries to be. So what does that look like? How does that, how do you put DuckDB inside Postgres, and what does that mean? Well, I kind of want it to be like this. You kind of want like two databases on a bench next to the sunset, drinking a nice cold beer, enjoying each other's company, and just being general friends and happy together. Sadly, that's not entirely what it always looks like. Especially at the start, it looked a lot more like this sort of monster picture that's like this Frankenstein-y mess of things. And now, after a lot of work, it's a lot better, but it's still, this is sort of how it started for sure. And the reason is that Postgres and DuckDB, they're very different. It's not just like ducks and elephants, basically. It's not just that one and the one is good at transactional workloads and the other is good at analytical workloads. But there's so many differences in how they're actually designed to accommodate those different workloads. And also, because Postgres is much older than DuckDB, Postgres is from the previous millennium, and DuckDB is from a few years ago. So there's lots of differences in sort of how it's designed based on sort of the time when it got started. You still see some of the old design decisions in Postgres stemming from like those early days. And one of those things is, well, sort of first important difference is that Postgres is written in C and DuckDB is written in C++. And so there's a lot of sort of mismatch in sort of how things are done, because C++ added a lot of sort of nice features to make sort of development a bit easier, but those don't always interact well with the Postgres code. So you have to make some, make some translations here and there, but that's, it's doable. It's not C++ is still called C in the C++ because it tries to work relatively well with plain C. It's at least that's what it's born out of, so it's at least sort of similar. But one of the main problems is the way exceptions work. So exceptions just exist in C++. It's a built-in thing. You can throw an exception, and DuckDB sometimes does that for cases where an unexpected error happens. For instance, like a divide by zero, something like this. It will throw an exception saying like, oh, there's an error. And Postgres actually had a similar need, but C didn't provide any sort of way of doing that by default. So Postgres has implemented effectively its own exceptions with its own try and catch, because C++ is try and catch, but Postgres is PG try, PG catch. So basically the same, but also very different. Because one of the problems is that the different try catch blocks, they don't understand each other's exceptions. So if C++ throws an exception and you have a PG try, PG catch block around that, it means that those handlers will not get executed, and that cleanup that might happen in the catch handler, the PG catch handler is not executed. So you might leak some memory. And the same is true the other way around. If Postgres throws an exception, then DuckDB, then C++ will not be able to handle that with its normal try-catch handler. So there's, and also a lot of the memory cleanup in C++ relies on even locking cleanup, and memory cleanup sort of relies on C++ understanding when an exception handles, exception is thrown, that it has to clean up a lot of these things and release a lock, stuff like that. So this is quite complicated to make work, but we managed. It is a very hard problem to sort of make work well. And the other is that Postgres uses processes and DuckDB uses threads. And DuckDB uses a ton of threads, and Postgres doesn't use any of them, basically. And Postgres functions and the code, it's also not thread safe, because Postgres thinks, oh, there's only one thread in this process. That's like the main thread. That's the one that's doing everything. So I can change global variables. I can do anything that I want. And so yeah, that's sort of problematic from a C++ perspective, because there's all these threads that maybe want to call some Postgres function, but that Postgres function cannot be called in a thread safe way. So there's also a lot of work around how to handle that. And similarly, sort of the other way around, DuckDB cannot open the same DuckDB file, for instance, from multiple processes. If it needs to open it from only one process. So Postgres having multiple processes makes that problematic, because now you have two DuckDB instances and two processes that maybe want to open the same file. So we did a ton of work to sort of make stuff work sort of as best as we could. And that paid off. It got a lot, it's very much closer to like the nice beer view in the sunset that you saw in the picture before. So how does it work? That's sort of an important question. Now that we know it works now, how does it actually work? Well, first we need to talk a bit about how Postgres works. So when Postgres gets the SQL query from like a client over the network, the first thing it will do, it will give it to the parser, which looks at this text of the string of characters and will sort of transform it into a AST. It's called the abstract syntax tree of sort of what this query actually means. Like, oh, there's this select in there, and it selects these columns and from this table. So there's sort of a meta representation of like objects and structures that is easier to work with than with a plain string. And then once it has that, it will give that to the planner, and the planner will then figure out the most efficient way of executing this. And then the planner will give that plan that is created to the executor, and that will actually do the work. So it will read the data from the disk, it will do the computations, it will do the group by, stuff like that. And that's how it works in Postgres. So how does it work in PGDuckDB? So with PGDuckDB, does is it basically steals the query, and it doesn't do this always. There's sort of some mechanisms to figure out like, oh, is this a query that PGDuckDB should care about? And if it does, then it will just take over. After the parser, Postgres has created this sort of meta query structure. It will not let the Postgres planner do anything. It will just take the query tree and give it to the DuckDB planner, and that will make a plan, and then the DuckDB executor will execute that. And then one important detail is that it can still read Postgres data. So PGDuckDB, even though it's running the DuckDB executor, it can still read the data that's in Postgres. So that's sort of a small but important detail. And then how can you actually use it? What can this thing do? So there's basically 3 different ways of using PGDuckDB. And I'll go over them quickly here and go in a little bit more detail after. So the first is you can use the DuckDB engine on Postgres tables. And that's sort of it. Like, you don't have to change where your data lives. You can just use the PGDuckDB on the data that you already have. The second is you can use it to read and write to data in blob storage. So DuckDB has lots of support for like Azure blob storage and S3 and lots of other different ones, and different file formats like JSON, Parquet, Iceberg, lots of different ones. And it can read and write those things to blob storage. And the last one is you can offload analytics to Mother. So let's go start with the first one. So the first is you have a DuckDB engine running on Postgres tables. So how does that work? Well, it's extremely simple. You just set one setting to true, DuckDB will force execution, set it to true, and it will now use the DuckDB executor and the DuckDB plan. But I mean, you'd only do that if it was a bit faster. So is it fast? And well, as always, it depends. Like, it depends on your query, it depends on your data, it depends on your indexes, it depends on a lot of things. But sometimes, yes, it's much faster. For example, there's this ClickBench benchmark. That's a public benchmark created by ClickHouse. And it basically does analytics queries on like a single table. So there's no joins, mainly aggregation. It's very aggregation heavy. And there, like for some of the queries, it will be like 2 times faster if you just set one setting, if you set this new set to true. And so that's pretty impressive. It doesn't happen for everything. Some queries also get slower, so it's not like a silver bullet, but it is sort of worth trying out. And I even had some extreme example of trying some benchmarks. Is like there's a TPCDS benchmark, which is also a very common benchmark. I created that with 10 gigs of data and no indexes. So normally you create some indexes, but here I wanted to see how it will work without. And that's for analytics, that's fairly normal because you usually don't have the right indexes for your analytics queries because the indexes you have in your database are usually for your transactional workloads. So the first query in TPCDS, when I ran it, I had to wait for 10 minutes and it just gave up. And then I set this setting to true and I run it again. And now it's done in 450 milliseconds. So like I press the button and pretty much it's finished. So yeah, that was kind of one of the easiest query optimizations I ever did. Like it would change one setting and suddenly everything is much better. As I said, this is like an extreme example. This is not something you can normally expect, but it is sort of worth trying out changing this setting because maybe you get like 2, maybe you get 5, maybe you get 10% performance increase from like doing just changing a single setting. And then we get to the second use case, which is using blob storage. So one thing we can do is we can just read from blob storage. We can just do select star from and then read Parquet and then give it a path to a Parquet file and it will just return the results, like return the first 5 rows in this case. So that's very nice for sort of getting data into Postgres because you can just do like, you can use create table as select star from, and then you get a table full of the Parquet data. And you can even filter and group by and order by on this Parquet data. And the benefit of that is that Parquet is actually stored in columnar format. And so DuckDB knows that, and it won't fetch all the data in this Parquet file to your Postgres server. It will just fetch the columns that you need. So in this case, you just need title, days in top 10, and type. And it will only fetch the data for those 3 columns and leave although maybe like 100 different columns. It will leave that all in S3 and not touch it. So your bandwidth the bandwidth used will be less. One thing to note is that it uses a bit of a strange syntax, like R square bracket stuff that you see. That's because read Parquet actually needs to return sort of arbitrary columns because you don't know what columns it's going to be based on, like it only knows it based on what's actually in the file. And Postgres doesn't really support having this sort of dynamic column stuff. So instead, what read Parquet does, it returns sort of an object that you can index, just like you could index like a JSON column. And then now you can index it on the columns of this row, basically. And then now we have to talk a bit, before we go to the last thing, we have to talk a bit about resources. So this is sort of how your Postgres server normally looks like. It's like a Postgres server with some transactional queries, like a bunch of small transactional queries that take up a few resources. But if you use Postgres with like the analytics stuff, like pgDuckDB, like the two examples I gave sort of before of using it, then it means that it's going to use a lot more resources because it's going to use more RAM, it's going to use more CPU to make it all go very fast, but it will use a lot more resources of the machine. So you cannot run as many queries concurrently as you could previously. So that's where MotherDuck comes in. So with MotherDuck, you can, this is the company I work for, you can offload this computation and sort of the memory usage to the MotherDuck cloud and only sort of get the results on the Postgres server. So here your analytics queries on Postgres are much smaller. So you can either use like a much smaller Postgres instance, or you can still combine it with some of the transactional queries that you might have. And all the actual computation is happening in the MotherDuck cloud. So that makes it and sort of that makes it much easier to scale, stuff like that. So to give a quick example, what that looks like, you copy data into MotherDuck. The way to do that is simply by using create table and then using DuckDB. And that's the sort of the key part. You say that it uses DuckDB, and you can select some data from like a Postgres table, and then you have the data in MotherDuck. So now you have a MotherDuck table with the same data as in the Hacker News table that was originally on Postgres. And then you can just query that like normal. You can group by, you can use all the columns, you can do whatever you want with this MotherDuck table, and it will just sort of work transparently without you knowing without you noticing that it's any different, except that it's a lot faster suddenly. And you can even combine that with some data inside Postgres. So you can do, like, let's say the last month, you still want to store in Postgres because you update that. But the archive from before, that's still in MotherDuck. So you can union those together and sort of get a shared result with like the latest and greatest detail coming from Postgres and all the highly computational old data coming from MotherDuck. And then the question is, but is that actually fast? And well, yes, for analytics, it is really fast. So it basically beats a bunch of the queries in the ClickBench benchmark. And if you run it with MotherDuck and pgDuckDB compared to just regular Postgres, even with Postgres with indexes in this case. So yeah, that's it. Please try it out. It's MIT licensed. It's just like, it's open source. You can just download it and compile it and or like install a Docker image. Feedback is very welcome. And yeah, looking forward to hearing from any of you that try it out.
Yeah, that Frankenstein moment was so typical from Jelte's style, and very interesting stuff about combining all these kind of different technologies and getting faster queries for analytics. So very interesting talk, Jelte. Thank you very much.
Thank you, Jelte. And obviously, if you are just joining and you haven't seen the survey links yet, I've got QR codes and short URLs on the screen. Speakers love feedback. It's how they get better, and it's how they teach us even more and more effectively in the future. And the event organizers want feedback too. So there you go. And I think we should move on. We're running a tiny bit behind, which is fine. As far as I'm concerned, the schedule is a guideline, Boris. It's not like we're not strict. It's not like the train's going to leave without us. I want to introduce our next speaker, Heikki Linnakangas, who is a longtime Postgres major contributor and committer. He is a co-founder of Neon, which, a couple of weeks ago, I would have said Neon is a great new Postgres startup that's been around for a couple of years, doing interesting things with serverless Postgres. But now, big news, Neon was just acquired a few weeks ago by Databricks. Yep. So probably if you go see Heikki on LinkedIn, I'm guessing he already has it updated. I personally love his origin story about how he got started in Postgres. And he told the story on the Talking Postgres podcast. I feel like I'm plugging that a lot, but I've been blessed that I've had some of these committers on the show to tell their origin stories. And his is fascinating. I'm not going to give it away. I'm also fascinated by a quote he put in the abstract for this talk, which is that creating the serverless illusion is not trivial. So I'm really curious as to what he means by that, and I'm looking forward to watching the talk. I'm hoping he makes it all clear for me. So with that, let's roll the tape on how Neon made Postgres serverless.
Hello, my name is Heikki Linnakangas. I am going to talk about how we made Postgres serverless at Neon. stay tuned if you want to hear how do cloud providers run services in behind the scenes. So let's talk about serverless Postgres. Before we go into that, I'm gonna say a little bit about what is Neon. It's a startup that we founded in 2021. And the core idea of the company is that we provide Postgres as a cloud service. And the idea was that we will build a service offering from the ground up in a cloud native fashion, make it really nice to be to run that in the cloud. And some of the features we have, it's very developer friendly, branching. People love it because it's easy to get started with. But really the topic of today's talk is the fact that we made Postgres serverless. And it's the only serverless Postgres offering out there. So what does it mean really for a service to be serverless? I mean, it can mean many different things for many different people, but kind of the common thing is that you have your application, which you maybe develop locally on your laptop, or maybe you already develop it on a cloud provider in the cloud. But when it's time to deploy it, you just deploy it to the cloud out there, not to any particular server or any particular instance that's running, but just to the cloud in general. And the idea is that the cloud provider takes care of running the service when it's running, and you don't need to worry about is it up and running or not, or you don't need to administer it. The cloud provider takes care of all of that. So in a sense, the fact that it's serverless, it's more of a contract between you and the cloud provider. Normally, if you're just renting server hardware or instances or whatnot, you have to manage you still need to manage the instance and install the software and so forth. But when you are running a serverless service, the idea is that the cloud provider takes care of all of that for you, and you just deploy to the cloud, and the cloud provider is responsible for making sure that it's up and running, not you. So in a way, the serverless service, it's always kind of a lie, like all software runs on servers or you locally on a laptop. But anyway, like there's no such thing as a serverless service. There's always a server behind it. The point is that as a user of the service, you don't need to think about that. So from your point of view, you don't think about the servers behind it. You might not even know where are the servers physically running, or you can't access the servers necessarily. You just know that it's running out there somewhere. But for a cloud provider, there's definitely a lot of servers behind the scenes. And when you're trying to make a serverless service, you definitely need to have a fleet of servers to run them on. But the point is that it's up to you as a cloud provider to manage. Like you need to manage those servers. The end user doesn't need to care. So for a user, the difference between a service and the service is that a server is that you are thinking about the service. And it kind of feels like it's always out there. It's always running, even if the server is physically not running or you don't know where it is. But the service is kind of always there, and you can always access it whenever you feel like it. Maybe you have an endpoint address to connect to, or a public URL or something. It's always there when you need it, but behind the scenes, the cloud provider might not have anything particularly running at the time. But when you connect to it, something will spin up and run your code in a serverless fashion. Some characteristics: if a service is serverless, there's probably no stop or start operations. Like you don't need to worry about those things. There might be like an enable or disable, or you might have some different terms for that idea that it's running or not. But there is no such thing as shutting down or restarting or stopping the server or the service. There's also, ideally in a serverless application, there's no concept of having to choose a size. Like capacity planning isn't really a thing. You don't need to tune it. Like when you deploy, it's just always there. And the cloud provider's responsibility is to make sure that there's enough servers running the service depending on the load. If the load increases, you have more. If the load decreases, then it can be scaled down. Another aspect, of course, if the service is infinitely scalable, you still have to pay for it. So one important aspect of serverless services is that you are only paying for what you use. So some kind of consumption-based pricing, whether it's compute hours that you consumed, or number of requests, or number of IOs, or whatever. But the point is that you only pay for the capacity, you only pay for the usage, not for the capacity that you could be using. So there's another concept besides serverless, which is stateless. When you're developing your application in a serverless fashion, it probably also means that you can't really have a local state in your application, because there's no server to keep that state in. The cloud provider can always shut down the components and scale them up or down, or move them around as they want. So an important part of making your application serverless is that you try to remove state as much as possible. Because if a component, like whether it's a web backend or function as a service or something, if it doesn't have any local state, then it's very easy to scale out. Like you can just have many instances of that running, as many as you need, and you can easily, like the cloud provider can easily shut them down and restart them as you need, based on the load. And often the database is kind of the last component on your application stack that has the state. Like all of these other components, if they need to store something, they will typically store it in the database or directly in cloud storage or something. But often the database is kind of the last piece of your application that needs to have a state, and it's kind of by design. Like a database, like by definition, has a lot of state. Like that's where all the data lives, and that's kind of the other thing where everything else pushes down their state, because they don't. If you want your application to otherwise be stateless, you would typically use the database to keep all the state. But that means that the database itself can't really be stateless. And that kind of brings us to Postgres. So what we are trying to do is to run Postgres in a serverless fashion, which means we kind of don't want Postgres to have that local state, just like any other stateless application, or we try to minimize that. And all of these other things that I mentioned, like the cloud provider, us, we need to be able to shut down instances. We need to be able to restart and move them around and scale them up and down, depending on the load. But that's a bit tricky with the database, and Postgres in particular. It's an old robust database. It's been around for a long time, but it was never really built that way, with serverless applications in mind. So Postgres has a very traditional architecture. It operates on its own local disk, like it has access to a local file system. Well, local, it could be a network volume somewhere else, but still Postgres kind of manages that volume and assumes that it's the only thing reading and writing from that volume, which means that you can't easily just shut down a Postgres database and start it up again. Like you need to have that state somewhere. You need to keep the disk around. You can't easily scale out and have multiple Postgres nodes. There's those projects that try to do multi-master and such, but it's a bit tricky. If you want to have read replicas, it means you need to duplicate the data and set up replication, which again is a bit of a hassle. It's not like you can just easily spin up new instances as you need to. Also, Postgres relies on the write-read log for crash safety, point and recovery, which is very much state. Like that's something that's data. That's where all the important data lives. You need to keep that somewhere. Also, Postgres kind of assumes that it has full control of the single server machine. Now, what does that mean if that server machine can be resized up and down, or scaled up and down, or maybe if you want to scale out the reads, how do you kind of make that work? Then there are some Postgres specific limitations with the caches that can be easily resized, and number of connection handling, and I'm going to talk more about those. But these are kind of the problems that we have to deal with in order to make Postgres serverless. How do you create that illusion of serverless in a service like Postgres? So the key to that is the architecture of Neon. There are a few pieces to that. So first of all, there's the proxy, which intercepts all the connections that come in. Like you don't connect directly to Postgres in Neon. You always go through the proxy. There's a control plane. We run a Kubernetes cluster and storage. I'm going to get into more details of all of these pieces. But let's first look at what happens when you connect to a database in Neon. Like let's walk through that process. So when you connect, what the user gets, or what you get as a user of Neon, is just a connection URL, like a Postgres URL that you can connect to with pSQL or your application. But when you do that, what you actually opened, what actually intercepts the connection first is the proxy. So when you connect with pSQL or something, you actually connect to the proxy first. And the proxy looks at, like, performs the initial handshake. It then performs authentication based on the credentials that we store in the control plane. And notice that there's no Postgres involved yet. So this is all still happening within these multi-tenant services, the proxy and the control plane, but your database is not even running yet. The next step is, if Postgres wasn't already running, if your Postgres instance wasn't already running, then the control plane launches Postgres, and it attaches to your database that you actually want to connect to. And then finally, here we are. After that part, the Postgres instance is running. It's connected to the storage. At this point, the proxy forwards the connection to real Postgres, and after that, it just passes through the bytes between the original connection and Postgres. But it handles that initial handshake, and this is the kind of the capability. This is why we can shut down Postgres completely, but you still have the illusion that when you connect to that URL, the proxy will wake up Postgres again, and your end application doesn't know that Postgres wasn't actually running when you try to connect to that. I didn't talk much about the storage part yet, but this is actually a very key and important part of what makes this whole thing possible, the storage system. So the important thing, the thing that really makes all this work, is that we separated compute and storage in Neon. I mentioned that the database is often the last piece in an application stack that has the state, and kind of data has a lot of gravity. Like if you have a terabyte of data, you don't just easily shut it down and move it somewhere else. It has gravity. You can't easily move it around. So the way we made Postgres serverless is by kind of splitting Postgres into two parts, or actually, like, the storage part is we plug in at a pretty low level in Postgres. But the idea is that we kind of push the state and all of that data down to the separate storage service. And by doing that, Postgres becomes serverless and stateless. So now that we've pushed down the state and the actual data to a separate storage layer, we can launch Postgres nodes independently, and we can easily shut them down and start them up again, and very quickly, because the data doesn't need to move. Like, the data lives in the storage layer then, and that doesn't need to move around. So a few words about the storage system. So it's a multi-tenant service. The same storage nodes handle the data for multiple customers. I mean, they're highly isolated. You can't access other people's data, but it's a multi-tenant service, and that makes it very efficient. Like, we don't reserve a certain amount of resources or a certain amount of servers per database. It's all handled by the same processes, the same servers. It's open source. If you want to play with it yourself, go ahead. It's written in Rust. This was an important criteria when we started, because it is a multi-tenant service, and we really don't want to have like memory issues or bugs that would expose the data between different tenants. So the security and isolation is important. That was a big reason for that. Ultimately, our storage system is also not the final place where all the data lives. So we actually rely on cloud storage like Amazon S3 or Azure Cloud Storage or Blob Storage for the final durable store. So in a way, our storage system is also just a cache of what we store in the cloud storage system. It kind of works as the glue layer between Postgres and the cloud storage, object storage, to make it possible for Postgres to be serverless. So the storage system also replaces your traditional like WAL archive and backups. It's the thing that allows us to do copy and write branching. And an important feature or interesting feature is that the same storage layer, same storage system can serve multiple read-only replicas of the same Postgres database. So if you want to scale out your reads, you can have multiple Postgres nodes running, and they all speak to the same storage, and they all share the same data without having to create multiple copies of your data. It's also the thing that if Postgres crashes or we shut it down, it's also the thing that allows it to spin up real quick again, because Postgres doesn't need to do while replay. The storage system does that for you. But from a Postgres' point of view, we plug in at a very low level. So where Postgres would normally read and write the local disk, that's where we plug in. And instead of reading from the local disk, you send the network request to the storage system, and the storage system gives you back an 8 kilobyte page. And this is what makes it possible for us to start and stop Postgres instances. So that's the storage part, and that's what allows us to make the rest of the system serverless. But there's some other complications. For us, I said that we are separating compute and storage. Just to be clear, the compute in our case is Postgres, and the storage is the storage system. But we run Postgres nodes in a Kubernetes cluster, and there's some complications in doing that as well. So the part of auto-scaling compute, there's really two problems we're trying to solve. One is stopping and starting the instances. I kind of talked about that already. But also, we would like Postgres to be able to scale up when there's a lot of demand, when there's high load on it, but also scale down when there isn't. And that gives you a lot of flexibility, and that kind of gives you that serverless illusion where you don't need to choose the size of your server beforehand. It will just scale up as needed and scale back down again when it's not needed. So a few words about the stopping and starting part. I mentioned we launch Postgres on demand when you connect to it. And we shut down after 5 minutes of inactivity. So if you don't run any queries for 5 minutes, we shut down again. But it's all transparent to the user, because when you connect to it again, we launch it up again. And when we started, we had roughly 5 seconds of cold start latency. So if it wasn't running, it took roughly 5 seconds to spin up a new Kubernetes pod with Postgres in it, connect it to all the right services, and finally connect the original client connection to that instance. Back then we got a lot of feedback like, man, Neon is awesome, but the cold start latency, that's so bad. Like that, you really got to fix that. And we had customers asking for, I want to pay you so that you don't shut down your database because I don't want to have that 5-second delay. So we were able to get that down to under 1 second, mainly by keeping a pool of like pre-warmed VMs with Postgres already installed and ready to go. And that kind of solved the problem. Like we don't hear that complaint anymore about the cold start latencies. That 1 second or I think it's around 700 or 800 milliseconds, that's good enough. People seem to be happy with that now. But the big part of what we do is maintain this pool of Postgres instances and keeping at the right size. I have a graph here about the workload on one particular region, and you can kind of see it going up and down based on the time of the day. But you can also see these interesting spikes. There's apparently a lot of people who have some workloads that run once per hour at the hour, and you can see those spikes here, which is really interesting, I think. So if you're developing an application out there and you have something that needs to run once per hour, please don't make it run at the hour. Make it run 5 minutes or 7 minutes or some random delay afterwards, so you don't hit that same spike as everything else. The other important thing about resizing or auto-scaling the computes is being able to resize the VM instance based on the load. So we have a custom Kubernetes scheduler that allows us to do that. Like we wrote that, and there's a lot of complexity in allowing us to do that. But we can basically hot plug CPUs and memory into the running VM on the fly based on the load. There are some interesting challenges with this, and this is not something that we have fully solved, to be honest. So if there's someone, looking for the topic for a PhD or something, I think this would be a great one. The question is, when would you like to add more memory to your server? And there's kind of a few different answers to that. First of all, if the server is otherwise going to run out of memory, then maybe you should add more memory. That's option A here, and we do that. But it's also not very satisfying. What if you have a runaway query that is going to consume all of your memory anyway? Does it still make sense to kind of expand all the way up and then run out of memory anyway? Maybe not. But the more interesting problem is that there are a lot of queries that could potentially run faster if you had more memory because of cache. So what if you have 10 gigabytes of cache available and you're doing a lot of I/O? But if you have 20 gigabytes of cache available, maybe your database or the working set would fit completely in cache, and it would just go a lot faster. You don't really get an out of memory error in that case, but clearly more memory would be beneficial. The kind of case C here is that it also affects the planner. Like if the planner knows that you have a lot of memory available to do hash joins or something, it might choose a different plan to begin with, knowing that you have the memory available. And would you like to use that memory then to make your queries go faster? But it means you're maybe paying more for that. I don't know. Like that depends on your application. It's kind of tricky. One challenge is that Postgres doesn't easily scale up and down like that. You can't easily change the size of the buffer cache. So we implemented a second level cache that we can resize. There are interesting patches on Hackers at the moment to actually do this. So hopefully we'll get this in a future release. But for now, we are relying on the second level of cache for that. Another interesting question is, what is the right size for the cache? What is the working set of an application and over what period of time? We had one interesting customer who had a large database, and they had like our auto-scaling algorithm looks at the one hour interval. Like how many pages have you accessed during the last hour? And then it kind of tries to choose the memory size based on that, so that 1 hour working set would fit in RAM. But this particular customer had an application that was doing a lot of random I/O during normal, like an OLTP application, and it wouldn't benefit from a lot of cache because it didn't fit in cache anyway. But once per hour, they had a batch job that actually accessed a lot of databases, like it scanned through some big tables. And we have this interesting pattern where our auto-scaling would scale up when the batch job starts, and it would populate the cache, but it wouldn't actually reuse much of that cache, so it didn't give you much benefit while the batch job was running. But then, because it was set at the same 1 hour interval and they ran that batch job roughly once per hour, just before the batch job ran again and would actually use those pages that were cached, we shrunk the VM again. So we shrank it just before it would have been useful because of that. So we have to do some manual tuning for that particular customer. But this is kind of an interesting case. Like, how would you like the cache to be tuned? Would you like to account for these kind of batch jobs that run once per hour to make sure that they're cached? Or would you rather actually shrink more aggressively and save on resources and money, but then pay the penalty once per hour? I don't know what the right answer is. We're kind of still trying to figure out this, like what is the most general solution to this. Another topic is connection management. So Postgres doesn't do as well as some other databases with connections, to be honest. Like by default, we set max connections to 100 in Postgres, which is not a lot. Like if you have an application with lots of servers, and you can easily hit that 100 connection limit. You can raise that. You can raise it up to a few thousand, but then you start to get other problems if you actually try to use all of those connections at the same time. So everyone who has administered a Postgres database kind of knows that you need to have a connection pooler to solve this problem. We also run PG Bouncer because of that. But this is something we ran into early on and kind of had to solve. So the solution is to run a connection pooler. But from a serverless point of view, the connection state is a bit annoying actually, because a connection has a lot of state, so it's not exactly stateless. But it works out fine in practice. Like PG Bouncer supports these caches and prepared statements nowadays. Like this was something we ran into early on when we were starting, but that's being fixed in PG Bouncer. But these other things that have state in a connection, like cursors or per connection settings, the serverless application doesn't actually use these features. Like no one running a serverless application wants to use cursors or like long-running queries. They just want to run one small query and get the result back and kind of treat each query separately. In fact, a lot of our customers were asking, like, I don't want to deal with these connections. Can't you just provide us an HTTP endpoint, like a REST endpoint to run queries? So we got this request a lot, and we actually we implemented that. So we implemented a simple HTTP API in the proxy that you can connect to directly from your JavaScript application and just run individual queries, and the proxy will do the connection management for you in that case. So in summary, this is how we did it. The core of the whole system is the separation of compute and storage. Like, the storage system is crucial. It's what allows us to do all of these other things. But then there's all kind of heuristics and magic for resizing the VMs, doing live migration, and extra caching, pooling, like a laundry list of other small things. The HTTP API that kind of allow us to make Postgres into a serverless service. Thank you. If you want to play with it, go to neon.tech and play with it. Or if you have pSQL available, you can use pSQL to connect to Neon directly. Thanks.
Heikki is such a wonderful human being. It's fun seeing him teach and explain.
Yes, I do remember actually when he was presenting two-phase commit back in 2010 in FOSDEM. And that was the first time that I saw a presentation from him. So remarkable, as you can say, because I still remember. Yeah, I really like the fact that he said that serverless is actually an illusion. He said explicitly it's a lie. So it's actually like magic, because magic is also based on illusion. Things don't really disappear and stuff like that. They're just being hidden. So I like that concept. And then how he explained everything was very natural in that sense.
Well, I found myself thinking that he also said that illusion is non-trivial. Well, obviously, if it were trivial, probably wouldn't have been acquired by Databricks. Like, clearly there was some hard work and some hard problems that they had to solve. So yeah, congrats to the whole team and Neon.
Yeah, like, I mean, these kind of solutions are fantastic, and the fact that they can be done with Postgres as well is a super nice thing. Something also that is super, super nice on Postgres is extensibility. I mean, the design for Postgres in terms of extensibility is such a good thing. And it's actually a design that comes from a long time ago, from the beginning of the 80s, actually even before the album Rust in Peace by Megadeth from 1990. And actually, since Neon was implemented with Rust, Claire, do you know any Rust programmers actually?
I do, and that's because my friends who program in Rust tell me that they program in Rust. So yes, I do.
They are eagerly telling everybody, hey, I'm a Rust programmer. So it must be good because they're proud of it. Now, if you want to be also proud of participating in a conference, something you can do is to provide feedback to the speakers, because speakers are also going to be super happy with this kind of information. Actually, I've been already filling in some feedback, and actually by doing that, I got some ideas about some potential talks that I could give in the future. So maybe you want to do that as well.
And the CFP is open for several conferences, and you and I will talk about those when we get after the talks and we do the wrap up at the end of the day. Like, I know the CFP for PGConf EU just opened yesterday, and it'll be open till June 30th. But we'll talk about that more later.
Yes, because today we are going to continue with this second live stream of Posette with great talks, especially the next one. I'm really looking forward to that one, and you can discuss in the Discord channel. In the Discord channel, you can talk about it, because we're going to have somebody especially talking about extensibility and the Rust programming language. And if you want to know what is Shinya Kato favorite extension, you can also read his interview, because he provides also a lot of information. And actually, he has a plan for his life. He wants to visit all the countries in the world. I wonder whether he is going to be visiting Chile, for instance, or Italy, where I am right now, or Belgium, where I am living. So if you go there and then send me a message, and I will show you around. Okay. So, but he's not going to be talking about traveling around the world. He's going to be talking about extensions and actually how to do that with Rust, so that you don't rust in peace when you're attempting doing this. So let's go with this talk.
All right, let's do it.
Hello, everyone. Thank you for joining my session today. My name is Shinya Kato, and I'm a database engineer at NTT Data Japan Corporation. Today, I will talk about Postgres extensions. The title of my talk is Can we use Rust to develop extensions for Postgres? If you're someone who's passionate about Postgres extensions development or curious about how Rust fits into the picture, this presentation is for you. Let's dive into it. Here we go. Let me introduce myself a little bit. As I said, I'm a database engineer at NTT Data Japan Corporation, which is the largest IT company in Japan. I've been here with our company for about 5 years. I specialize in Postgres, offering technical support, conducting R&D, contributing to the Postgres project, and maintain 2 key extensions, PG Bulkroad and PG Arman. To begin, can we use Rust to develop extensions for Postgres? Yes, we can. Instead of legacy C language, it's possible to develop Postgres extensions using modern Rust and frameworks. However, getting started with Postgres extension development in Rust can be a little bit challenging due to limited information. This talk aims to provide assistance for developing Postgres extensions using Rust. Furthermore, drawing from my own experience implementing Postgres extensions in Rust, I will share practical insights covering both the pros and cons. While Rust, currently system security is compromised by numerous vulnerabilities caused by memory corruption issues. Google's security team Project Zero reports that about 68% of zero-day vulnerabilities are caused by memory-related problems. These critical memory safety risks are commonly found in C and C++ applications. On the other hand, Rust's strong memory safety features make these issues much less likely to occur. Furthermore, Rust's ownership system guarantees memory safety without sacrificing performance. This is why a partial migration from C and C++ to Rust is underway. For example, we can point to projects like Rust for Linux, which enables implementing Linux kernel modules and device drivers in Rust. Another significant development is Chrome's ongoing migration of its font handling library from C's free type to Rust Scripper to ensure safer font processing. Additionally, in the Postgres ecosystem, Neon is notable for implementing Postgres storage engine in Rust. So how can we implement Postgres extensions in Rust? You can easily develop them using PGRX, which is a framework specially designed for developing Postgres extensions in Rust. Let me explain the key features of PGRX. First, PGRX provides an integrated development environment. Using this environment, you can easily implement Postgres extension features. Second, it safely exposes the Postgres C API to Rust. This allows you to securely call Postgres functions from your Rust implementation. Third, it automatically handles the mapping between Rust types and Postgres types. For example, if a Rust function returns an i32 type, PGRX converts it to the integer type. If it returns an i64 type, it converts it to big int. And if it returns a string type, it converts it to text. There are many popular Postgres extensions written in Rust using PGRX. ParallelDB is a modern Elasticsearch alternative built on Postgres. ZomboDB integrates Postgres and Elasticsearch. PostgreSML is a powerful Postgres extension that seamlessly combines data storage and machine learning inference within a database. PL Rust is a Rust procedural language handler for Postgres. Various other extensions are also being developed, so please refer to GitHub for more details. Okay, let's move to the next part demo. First, let's install PGRX using Cargo. For those unfamiliar with Rust, Cargo is its build system and package manager. Once PGRX is installed, you can set up a development environment for PGRX Manage Postgres extensions using the cargo PGRX init command. This might take a little while because it compiles for all Postgres versions currently supported by PGRX. Currently, PGRX supports Postgres versions 13 through 17. Support for version 12 was recently dropped. If you didn't specify a path during cargo PGRX init, you'll find the Postgres source code and data directories located in the .pgrx directory within your home directory. Information about the Postgres installation is stored in config.toml within the .pgrx directory. Okay, let's start developing an extension with PGRX. You can create an extension template using cargo PGRX new extension name. For this demo, we'll create an extension named example. Running this command creates an example directory. You'll see various files have been created. This is actually already a runner Postgres extension. Now, let's run the extension using the cargo PGRX run command. You can specify the Postgres version as a subcommand. We'll use Postgres 17 for this example. Compilation will start. Once it's finished, Postgres will launch and you'll be connected via PSQL. Now, let's use the example extension within Postgres. First, let's enable the example extension in the database using the create extension command. The extension is created successfully. Next, let's check the extension details using \dx. As you can see, the example extension is listed and its description says created by PGRX. We can also use \dx plus to see what's included in the example extension. It seems to contain a function called hello example. Let's try executing the hello example function. Now, let's run select hello example, and it displays hello example. So how is this implemented? Let's take a look. Let's open src/lib.rs. Here we see the definition of the hello example function. It takes no arguments, returns a string, and specifically returns hello example. The pgextern attributes attached to this function is what makes it callable from Postgres. There's also a unit test already implemented named test hello example. Let's run this test. Executing the cargo PGRX test command runs the unit test against all Postgres versions supported by PGRX. And as you can see, the output, like test result, okay, one passed. The unit test passes. All right, that's it for the demo. Based on the explanation so far, I hope you now have a general idea of how to use PGRX. From this point, I'd like to discuss the pros and cons of PGRX based on my own experience developing extension with it. The first point I'd like to introduce is about setting up the development environment. As you saw in the demo earlier, you can set up the development environment very easily. With the command cargo pgrx init, you can set up development environments for all Postgres versions supported by PGRX from 13 to 17. You can also create an environment for only a specific version for example, using a flag like --pg17. I believe this feature is very user-friendly, especially for beginners in Postgres extension development. However, you can only specify major Postgres versions. Minor versions cannot be specified. While you do not often need to worry about minor versions, the ability to specify them would be convenient. For instance, when you want to check the impact of a bug fixed in a specific minor release. Furthermore, you cannot specify the Postgres master branch, which is currently under development. Developing a Postgres extension isn't a one-time task. It needs to keep pace with Postgres version upgrades. When a new major version of Postgres is released, PGRX will likely add support for it eventually. However, waiting for PGRX to support new major versions after their official release slows down the delivery of updated extensions. If it were possible to develop extensions against the master branch, I believe PGRX would become an even more practical framework for extension development. The second point I'd like to introduce is automatic SQL generation. With PGRX, SQL statements like create function can be generated automatically. But first, let's review how user-defined functions and other components are typically implemented using the traditional C language approach. When implementing a user-defined function called func and providing it as part of an extension using C, you need both a C source file and an SQL file. On the left, I'm showing the C source file, and on the right is the SQL file. After implementing the function logic in C, you then define the SQL function using a create function statement that calls the C function. Furthermore, if your extension provides more complex features like custom types or index support, you also need corresponding SQL definition such as create operator class, or create operator family. As you can see, this means you need to implement and maintain both the C source file and all these SQL definition files. Using PGRX, the SQL file is automatically generated based on the Rust functions, attributes, argument types, and return value types. In the pgextern attribute, you specify parameters equivalent to those used in create function, such as immutable, strict, stable, or volatile. Additionally, the Rust function's argument and return value types are mapped directly to the argument type and return type. In the generated create function statement, in this way, automatically generating the SQL reduces the cost of implementing and maintaining SQL files. Similar to functions, PGRX can also generate the necessary create function and create operator statements for operators. Just like before, in the PG operator attribute, you specify parameters for create function, such as stable or strict. In the OP name attribute, you specify the desired operator name. In the restrict and join attributes, you specify operator-specific parameters. Automatic SQL generation is also available for operator classes, similar to functions and operators. However, this capability is currently restricted to B-tree and hash indexes only. Support for other index types like string, gist, and spgist is currently lacking, which is an important limitation to consider. For instance, an extension I developed required gene indexes, so this auto-generation feature wasn't applicable, and I needed to write the necessary SQL definitions directly. The third point I'd like to introduce is memory management. Memory management in the C language requires explicit memory allocation and deallocation using malloc and free. Postgres implementation uses a region-based system for memory management, utilizing memory contexts. This involves creating these memory contexts and allocating memory associated with a specific context. To free memory, you simply delete the memory context, which releases all memory associated with it at once. In this way, Postgres provides an implementation for efficient and relatively easy memory management. However, even with this system, developers still need to be careful about issues like memory leaks, double frees, and dangling pointers. Next, I will very briefly explain Rust memory management. Rust manages memory using a concept called the ownership system, which has three main rules. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. As shown in this diagram, when S1 is declared, S1 becomes the owner of the halo. Similarly, S2 becomes the owner of world. Next, S2 goes out of scope and then is dropped, freeing its memory. Likewise, S1 goes out of scope and it's dropped, freeing its memory. PGRX memory management system is designed to bridge the gap between Postgres memory context and Rust ownership. Specifically, the allocation of pointers received from the C API is handled by Postgres. Conversely, objects created in Rust are deallocated by Rust itself based on its ownership rule. To help safely manage pointers allocated by C from within Rust, PGRX provides the PGBox type. It's already difficult to understand C and Postgres memory management and Rust memory management individually. Then you also need to learn PGRX memory management. This makes it much harder. Let me give some difficult examples. One is handling memory created in C from your Rust code. Another is passing Rust memory to C and telling Rust not to free it, which goes against Rust's ownership system. The fourth point I'd like to introduce is toolchain. When developing with PGRX, you directly benefit from the rich Rust ecosystem, particularly its excellent toolchain. This familiarity offers great convenience. For instance, you have Carl Clippy for linting to help write more robust and idiomatic Rust. Code style consistency is easily maintained using Cargo FMT for automatic formatting. And crucially for extensions, Cargo PGRX test provides a streamlined way to handle integration testing directly against Postgres. This ability to use standard Rust tooling really makes the development workflow much smoother. Now, let's look at the point marked here as a challenge, which relates to toolchain integration. While the Rust side is well supported, there's currently weaker integration with some traditional Postgres tools. Specifically, as noted here, there isn't direct integration with PGRegress, the standard framework for running SQL-level regression tests in the Postgres ecosystem. While PGRX provides its own testing mechanism, it doesn't replace the PGRegress workflow. This is a recognized limitation as shown by the GitHub issues listed on the slide. For now, this means that setting up PGRegress style tests might require separate configuration. The fifth point I'd like to introduce is documentation. While learning PGRX involves navigating different memory models, as we discussed, there are several excellent resources available to help you. Let me highlight the key ones shown on the slide. First, for the specific details of the PGRX creates functions, types, and macros, your primary reference is docs.rs, which is the API documentation. Next, the PGRX book serves as the official guide and documentation. This is the best place to understand core concepts, learn how to set up your environment, and follow tutorials. Finally, if you want to see practical examples and common patterns, the PGRX examples is invaluable. It contains various code examples that you can learn from the adapt. I highly recommend utilizing these resources as you explore PGRX development. While resources are growing, it's true that there is currently less information available for PGRX development compared to the vast resources accumulated over many years for traditional C extensions. So, because there isn't enough documentation or examples yet, development can still be quite hard sometimes. This is especially true for complex problems or unusual situations. I hope this presentation was helpful for you. Finally, let's discuss the future of Postgres and Rust. There have been multiple proposals in the past suggesting the use of Rust for implementing Postgres core. However, due to various reasons, the adoption of Rust for the core has been deferred. So the chance of this happening is quite low. For example, there is the huge existing C code base, Postgres Unique Memory Management System, and its specific error handling mechanisms, like pgtry. Additionally, Postgres needs to support a wide range of platforms, which presents portability challenges. But as mentioned in this talk, Rust-based Postgres extensions are expected to grow substantially in the future. Okay, let's quickly summarize the main points of this presentation. First, I explained how you can implement Postgres extensions using Rust with the help of PGRX. We also took some time to discuss the pros and cons of using the PGRX framework. PGRX offers a powerful way to build extensions. So let's try it out. Thank you.
That's a nice message, I think, at the end. Let's try it out. And I think that the fact that he showed a demo how to get into the extensions and then get it there, it gave us a very good start about doing more stuff with Rust, which is getting a lot of traction in many development communities, not just people doing like serverless stuff or doing this extension. And in terms of performance, seems to be very, very fast. And we were discussing on the Discord channel that there are still some things to mature on the framework and extension. So let's keep the discussions over there, and then let's see how this goes further. Now, about keeping discussion, keeping something, I would like to take some measurements here because I've been getting some information. Well, is it updated information? So yesterday we have 85 feedback surveys submitted, and today we get 12. Well, it's still in Italy, it's still 11:45. It's early in the morning, but come on, feedback is the way to get a much better community by providing this information and exchanging stuff. When the speakers feed you with knowledge, you feed them back with your feedback. That's why the word comes from, and it's a circle of life, because the circle of life is full of feedback loops. Yeah. What do you think about that, Claire?
I like the feedback loop. And also, people may not realize, you might be thinking, oh, I'll do the survey at the end of the live stream. But that talk survey, the one on the left-hand side of the slide there, you do that separately each time for every talk. Now, you can wait till later and do all 11 at once, but some people are doing it instead of listening to us in the in-betweens, in the interstitials, which, you know, and it's fairly easy. It's fairly lightweight. It's not like you need to go write an essay or answer 15 questions. So definitely get those survey responses in, both for the talks as well as for the event. And you can get one pair of socks per live stream per person until we run out of supplies.
So before.
It could be 4. It could be 4. All right. Let's go ahead and introduce our next speaker. I want to welcome Johannes Schuetzner of Mercedes-Benz Research and Development. Now, Johannes works on back-end applications for all of the connected Mercedes cars. And this is a bit of a customer story because he runs those applications on Azure Database for Postgres, the managed service. And the talk is specifically focused on security and making sure that your data cannot be tampered with. He talks about network security, and he also talks about access management. So I think it's time to roll the tape, and I know it's not a tape. I know no one says that anymore. I'm the only one. I'm dating myself. But let's roll the tape on fortifying Azure Database for Postgres, stopping intrusions in their tracks. Let's go.
Are we getting there?
Hi there. I'm Johannes from Mercedes-Benz R&D in Sindelfingen, Germany. In my session about Azure PostgreSQL, I'll dive into details how you can make your database more secure, and I will focus about network security and access management. I'll cover all the basics and explain how it works together, so no prior knowledge is required. I want you to be ready to build your own solution in this space. See you in my session. Okay. Let's stop intrusions in their tracks. If you look at security for Azure Postgres, there are different areas, like data protection, where you encrypt your data in transit and data at rest. Then you can do row-level security, where you ensure that certain rows of a table can only be accessed by certain users. Then there's Microsoft Defender for Cloud as an overall security management and threat protection solution. But two key aspects where you can make a lot of difference is network security and access management. And I would like to focus on these two areas now in this session, because this is really where I can have a big impact by your configurations. Okay, network security is the first topic. Basically, there are two fundamental ways to set up your network for Azure Postgres: private access and public access. With private access, your Postgres server is integrated in a virtual network. With public access, it is accessible from everybody on the public internet. In either way, you have authentication that the application needs to perform when connecting to the database. Then the network traffic is always encrypted using TLS. The Postgres server has a domain name, and there are authorization rules that control like who can access which tables and which databases. But let's start with looking at public access. So with that, as the name suggests, there's a public endpoint, so it is publicly resolvable via DNS. But still, it doesn't mean that everybody can connect to the database. Usually you set up some firewall rules that control then the range of IP addresses that are allowed to access the server. The Postgres server is not part of any VNet, and this then means that the traffic goes over the public internet pathways, so that's not secure. Here on this page in the Azure portal, you see kind of how you can configure firewall rules, where you can, for example, specify IP ranges from the egress of your Kubernetes cluster if you run the application in Kubernetes. So this fits quite well. In the middle of the screen, there's this checkbox where you can allow public access from any Azure resource, but usually you wouldn't set this because any unrelated Azure service could then connect to your databases, but you would not like typically. You don't have to configure these rules manually. You can use tools like Terraform or other infrastructure as code platforms to configure your firewall rules like this. But overall, it's not that safe because the Postgres server is vulnerable to external attacks, and the traffic travels over public internet, so it can be sniffed. The other way is private access, and so the Postgres server is injected into an Azure VNet, as shown on the right-hand side here in this diagram. One big benefit is that the network traffic travels over the Azure backbone, so not the public internet. You should be aware of that the VNet needs to be in the same Azure region, and you need a delegated subnet for all your Postgres servers in this VNet, but this is okay. It can be that the application is in a different VNet or in a different region, and then you would use like VNet peering to connect these virtual networks so that the application can reach the database. As the Postgres server is not accessible from public internet, you need a private DNS server like Azure Private DNS for the domain name resolution. Here you can see a page from the Azure portal about like the network setup, and at the top you see kind of network connectivity, these two base methods, public and private. And you need to be aware of that you can configure this only during the initial provisioning of your Postgres server. So that means when you have selected either or the other one, then that's it. You cannot change it anymore. And also the VNet that is then specified here for the private access case cannot be changed. So if you set this up initially, then that's it for the lifetime of this Postgres server. You can automate all of these steps, like here again with Terraform as an example, where you configure and provision your VNet, specifying the address space that should be used. Then you delegate a subnet for the Postgres server. Then you have your private DNS zone that is needed. And finally, you connect the private DNS zone with the virtual network using a virtual network link. So that's it. It can all be automated. But looking at this, I mean, there's some big benefits, of course, because it's like better secured, better restricted. But a VNet is restricted to one Azure region, and you can create your network architecture with multiple VNets, but this can become complex. And also with VNet peering, you need really to trust the resources in the other VNets, because the network security group rules that you can configure, they work quite low level at like IP or port level, and so it's hard to set up data exfiltration rules that really work well. Also, as I indicated, the Postgres server cannot be reassigned to another VNet. Okay, so now the latest addition here in this space is then private endpoint, and this is basically a variation of the public access connectivity method that I described earlier. It is a recent enhancement. It was introduced in February 2024, and it is supported for all Azure Postgres servers that were created after this time. So not for the older ones, but for all the Postgres servers that were initially deployed after February 2024, you can use it. What does it do? It adds a network interface to the resource, and this provides then the resources in the VNet or private IP address for the Postgres server to connect. The network traffic travels securely over the Azure backbone, and one consideration is also that there are some additional costs that are then charged for the private endpoint. Here in the Azure portal, you can see, like at the top, that's the basic connectivity method. It's public, but here you can at the same time dynamically enable and disable this public access. So, and this is quite useful. For example, in migration scenarios where you used to have public access enabled for your server, but you would like to introduce private endpoint, then you can still allow public access for some time and then add your private endpoint until you're set up, and then later you can disable the public access. At the bottom, you see the private endpoints. You can have multiple private endpoints. So for each VNet that should connect to your Postgres server, you can have one. And the VNets can also be in other regions, so there's no restriction there. So that's quite, attractive, I think. You can provision the private endpoint also using like infrastructure as code with Terraform. You provide a name, you specify kind of the VNet and the subnet that it is connected to. And for that, it is important they are deployed in the same Azure region as the VNet. And then you specify as a resource your Postgres server, and here this one parameter is manual, is approval needed. And yeah, and this is what you can configure, and this can be useful if you configure a private endpoint like for another resource. Okay, so now if you have set up all of this, there's some operational aspects. So if you used to connect to your Postgres server using public access and you have disabled this, then okay, you can also don't access your Postgres server from your local machine anymore, which may be useful like for troubleshooting purposes or for similar tasks. But there are alternatives. You can use pgadmin or some other tool within the VNet. There's some documentation how you can set this up. An alternative way that I personally like is like Azure Bastion, where you dynamically kind of enable a virtual connection using shell or remote desktop. And I think this works quite well if you only want to run a few queries for like select statements for troubleshooting. This works quite well. And also the costs are then not an issue because you would run this only sporadically when needed and then tear it down again. If you want to check out, okay, I have my Postgres server, does it really have a private endpoint active? Then you can use tools like or commands like nslookup or dig, where you then find under canonical name whether private link is part of that name, and if so, then a private endpoint has been enabled. Now, it can happen that for some reason a private endpoint does not work anymore, which is not good. But then it can be sometimes tricky to find out what's the matter with it and how can you analyze the situation. And one thing to remember is that as long as the private endpoint exists, the connections from within a VNet for the private endpoint, they try to use it. And so even though, for example, you have enabled public access, and the public access from outside of the VNet works perfectly fine, it still may not work from your private endpoint because it's in this VNet. And so also testing from outside of the VNet does not help really because it's not realistic. So to analyze, you would have to get into the VNet, like using Azure Bastion or some other way, and then you can try out whether it still works, or you can do some analysis. If you have enabled public access, for example, or as a last remedy, you can also then drop the private endpoint and recreate it. So that's really kind of maybe also some good benefit. I mean, it's really flexible, and if for some reason it does not work anymore, you can recreate it, and then it should be fine again. So to summarize, so there are some considerations for private endpoints. So they look at the granularity of individual Postgres server instances. So not at the service level itself, but really for each instance you can enable the private endpoint. You have explicit control also at the resource level. You can allow or disallow a VNet for a specific, a private endpoint for a specific VNet. So that's also good. Traffic travels over the Azure backbone. That's a benefit. Also, like maybe compared to private access, the data exfiltration protection is inbuilt. So that's, I think, also quite attractive. You are better here with that regard. You can flexibly provision or deprovision the private endpoints. It's not like with private access, you have the VNet and that's it. So it's really more dynamic, and maybe it's a downside, there are additional costs. And also, if an existing Azure Postgres server uses private access today, then you cannot enable private endpoint in addition. You would first have to migrate the data to a new Postgres server with public access, and then you can enable private endpoints and benefit from that. Okay, so that was about network security. Let's move on to access management. And this typically consists of two parts, authentication and authorization. With authentication, you verify the identity of your application or your user, and authorization checks are performed to check the permission of or for an intended action. So does the application really have the permission to do some action in the database? Okay, so for authentication, like the traditional Postgres way using user and password works fine. I mean, they are stored in Postgres. It's up to you, though, to manage these users and passwords. So if you would like to rotate a password, for example, then this is your task, and it's not so easy because there's only a single password for a user. So this is like manual overhead, administrative overhead that you need to take care of. The other way is Entra authentication. So the standard, like Microsoft Azure way, or Active Directory is the formal name. And here you have, as a benefit, the uniform management of users. So you can use these users not just for Azure Postgres, but also for all the other Azure resources and resource types that are available. You can rely on Entra group so that you treat all the users from a group the same way. And you can combine this with password so that you provide a password, or which is more appealing, is passwordless. So really, you don't have to worry about passwords anymore. This is all handled by Azure. And I will talk about this in a little moment. Maybe just first have a quick look at Azure Portal again, how it looks like there. Here on the authentication page, you can configure whether your Azure Postgres server is supposed to support Postgres authentication, Entra authentication, or both. And the last option is probably attractive also as earlier for migration scenarios where you used to have a Postgres user but would like to introduce Entra authentication, and then you can enable both of it for some time. At the bottom, you see the Entra administrators that have been created for the server. And this is also maybe a little different compared to the Postgres way because for the Postgres authentication, it's only one admin user, and here for the Entra way, you can have multiple of them. Okay, so let's take a closer look at the passwordless connection. And here you can see at a high level how it works. So the application does not provide a password anymore when connecting to the database, but rather the application is associated with an entity in Azure Entra, so the managed identity that we'll talk about. And then when the application connects, it provides a token internally, and then Postgres can check with Entra, okay, does this token belong to the application, and is it valid? And if so, then the connection and the access is granted. How can you enable this? And there are a number of steps to enable this, but it's not a big deal. It's just a number of steps because different areas are involved, and that's why it takes, these steps to get to the full solution. But you can automate all of them using Terraform or some other way. And now in this example, I will talk about AKS cluster, so Azure Kubernetes service with an application using Spring Boot, but that's maybe an attractive combination. But there are also other app platforms like Azure Functions or Azure App Service, and they are also supported. But now let's take a look at this combination here with AKS cluster and the Spring Boot application. So the first step is to provision a managed identity. You basically provide a name, and this is then a user-assigned identity. Create that so the identity exists. As a second step, you enable managed identity, and here it is called workload identity at the Kubernetes cluster level. You also need to enable that it can serve as an OIDC issuer, but it's basically it. Then the more interesting part is the third step, where you create a federated identity credential. And here you basically correlate the managed identity with some workload in the cluster. So here under parent ID, that's the ID of the managed identity that you created earlier. Then issuer is the OIDC issue from Kubernetes cluster. And then under subject, there are two portions of this parameter. One is the namespace, so that's the namespace name in the Kubernetes cluster, and the other piece is a service account. And the service account represents your service in the AKS namespace. So it's really specific. It doesn't mean that you enable kind of the whole Kubernetes cluster with your managed identity, and then any application running in the cluster could connect to your Postgres database claiming the managed identity. So that's not the case, which is good. So it's really specific, and you can say, okay, for this one microservice or application, I enable the managed identity, and then only this microservice is allowed to connect using the managed identity. Then in Postgres, you also need to enable this. What we saw earlier in the Azure portal, you can also configure this. And don't be confused by the naming. It's just the older name of Entra, which is Active Directory. So you enable this here, and also then you can provision the Active Directory administrator, so the Entra administrator, in new naming. Then we need to enable the managed identity or workload identity also for your specific service account and pod. So there's a parameter called workload or Azure workload identity use, and here for service account and the pod spec, you would have to set it. And what is also key, there's one annotation where you specify your client ID of the managed identity, and so it's really then kind of this combination is then fixed. For the combination for the managed identity with your service. And then last but not least, for your Spring Boot application, there are two steps. It's more like configuration steps. You don't have to change kind of the coding. One is to add a dependency to the Spring Cloud Azure Starter JDBC PostgreSQL library. It's a long name. So you add this dependency, okay. And then in the application properties of your application, you first specify the Entra name, so the name of the managed identity under username, and the other setting is then Azure passwordless enabled, and so that means, okay, no password is provided by the application. It's just passwordless, and the rest is taken care of by Azure and the Azure lib. Okay, now if you have set this up, does it work? Okay, so usually you find out quite soon if it does not work, because then your application cannot connect to the database anymore. I mean, that's usually what you then see and feel immediately. And if it works, then okay, in the deployment log, there are messages like this saying, okay, the Azure AKS token exchange has happened, and that's it, and then it works fine. So okay, so that's it. Now we have authenticated successfully to the database without password, which is good. You don't have to manage your password anymore. But now, which permissions exist in the database for my application? Now let's talk about authorization. And what is quite well known is this principle of least privilege. So I would like my application to have as few permissions in Postgres as possible, because then the chances are better that no harm can be done by whatever reason. And so I would like really the application only to do these steps that are absolutely necessary, but nothing else. One way to accomplish this is to set up my pipeline that creates or that deploys my service. And here there are two examples where I define a service connection, like in Azure DevOps, but also like you can also use other tools, other CI/CD pipelines, where correlate a managed identity with appropriate permissions in Azure Postgres with this service connection. On the right-hand side, you see a way to set up a VM scale set in Azure and correlate your managed identity with this VM scale set, and then you can use this VM scale set as a runner or as a self-hosted agent in Azure DevOps. So that means here for this connection for your CI/CD pipeline, you have a managed identity, and then if the pipeline is executed, then you can do stuff as I show it here on this slide. So in this example, it's a flywheel script that takes care about managing the database objects, about like creating tables, updating table layout, adding columns, and similar tasks. And here, to use the managed identity that was associated with this pipeline, you just say like AZ login identity and then provide the ID of the managed identity. And that's it. I mean, no password needs to be specified, but kind of this connection to the managed identity is baked in using the pipeline definition as I showed earlier. Then you don't have a password, but tools like Flywheel delete a password. And so what can you do? You can generate a token, and here with the AZ account get access token command for the OSS RDBMS resource, so the database resource, you can generate an appropriate access token, pass it in for your password, and then run the Flywheel script. So that's it. Then that means all your objects have been created. And now kind of one key part, I would like to have a new role that is only allowed to access these tables, like to insert data, to read data, but not to do anything else, not to create additional tables or stuff like that. And so I can then create a new role in Postgres that is correlated with a new managed identity. So now we have a second managed identity. Like here, you see that's a function in Azure provided specifically for this task called create principal with OID. And here you would specify kind of the name of the role, which can be kind of this new Entra service name, the object ID of the managed identity as it exists in Entra, and some additional parameters where you can say, okay, should this be a regular user or an admin user? But then basically you have in Postgres a role that correlates to your Entra user. Okay, and now since you have this role in Postgres, then you can grant the permissions that you would like it to have, like grant usage on a schema on schema public, or grant like all the DML statements like select, insert, update. So that's needed. So that's fine if we pass these, or if we grant these permissions, but no DDL operations should be allowed. And so we will only grant then the DML statements. Okay. An alternative way, if you already have a role in Azure Postgres, is to assign a security label, and that's also a similar idea. You correlate that then kind of this existing role with your Entra service ID. Okay, or with the managed identity, which is here represented by the object ID. Okay, now a few operational aspects. So one is okay, I would like to connect using Entra ID in my DBA tool like pgadmin or dbeaver. And as I showed earlier, also for this case, you can generate an access token and then log into your DBA tool. But here it's only important that as a user ID, you have to enter the Entra name exactly as given or as shown here in Azure Portal, and then the token as a password, and then that's fine. Then it should work. And then maybe just a minor thing, but it can be confusing if you execute a grant statement that grants permissions to a certain user. This typically always succeeds, so no error. Even though, for example, if you try to grant a permission that you don't have actually, so then you're not able to grant this permission to another user or to a managed identity, but still the grant statement will succeed and looks like everything is fine. But here, I mean, if you are in doubt, you can check here under information schema, role table grants, and then you find out everything that is provided and has been made available with regards to permissions for this user. Okay, to summarize, we talked about private endpoints, which provide a new network opportunity for Azure Postgres. There are additional costs, but it's more flexible, more dynamic. And then the other big topic is passwordless connection. And once you have set it up, then Azure takes good care of all the details. You don't have to manage your passwords anymore. Also, they cannot be leaked anymore accidentally because you don't have a password. So everything is done by Azure for you. So it's basically the ultimate solution for password management. Okay, so that's it. So with that, I would like to thank you and conclude my session.
That was interesting in terms that security is not a game. It's something that you really need to be paying attention to, of all the possible attacks that you can have. Like, where is the password going to be leaked? Passwordless is not as obvious to just say, like, okay, well, let me just a few clicks. So definitely Johannes gave us a good amount of information about where we should be looking at and where to set up stuff. So definitely a presentation to watch again and look at the details, and then pause maybe in some of the explanations, and then get all the small things that makes it really a fortified connection to the database. Yeah.
And if anybody's going to give feedback, which is important, people need to know how they did with their talks and in their delivery. Please go to these survey links that are showing on the screen. And then once you get there, you can go ahead and take that code that you get in the last question and drop it into another website as well to get your socks. It's just like you said, people need to eat. Speakers need feedback to know how they did and to get better. So it's like nutrition for your Postgres speakers, nutrition for the open source project.
I like that concept. I like that concept, nutrition for the open source project. Yeah.
The other thing is, not all the Posette speakers did this, but some of them did submit speaker interviews, which I think is really fun to just get to know the people behind these talks and what they work on. And of course, he didn't tell us in that speaker interview if he gets to drive a Mercedes because he works at Mercedes, but he did talk about this new game that he started playing, which sounds like it's a variant of pickleball. I don't even know how to pronounce it. Do you?
Padel.
Padel. And I think you were explaining to me offline that it's like similar to beach tennis and that it's got a low barrier to entry, which is not to say that, Johannes might be very, very skilled at it. And I'm not diminishing his skills, but I do think having low barriers to entry is good in sports. It's also good in databases. And that's one of the things people like about Postgres is it is easy to get started. Although there's a lot of complexity to be learned along the way.
Yeah.
All right.
That's important. Yeah. Yeah. And we have more speakers. We have more interviews. So from the two speakers that are coming in the next presentation, one of them is also a big fan of PG.db, which was presented in a previous talk. So we see the fundamental interconnectedness of all things. So you can go and check out the interviews and tell us on the Discord which one of the two speakers is the one that likes PG.db. Now, I'm very happy that I can present this one because I love collaboration in general, and having the two speakers in one talk is also, I know the effort that you need to do in order to collaborate and then have a smooth transition and connection between the speakers. So I'm very curious about how this is going to work. Now, usually I'm very happy and excited about this. However, I must say that although Claire and myself, we are how to say, the visual part of this live streaming, there is a lot of people helping us on the back, and they tell me that I cannot be serious. So that's why I need to put myself now in a very serious face and explain you that this topic is about corruption. We don't like corruption. Corruption is a bad thing. And especially if it is in your database, you don't want to have corruption in your database. However, sometimes it happens. And now I'm coming with a happy face again, because we are going to talk about how to identify them, how to go through the troubleshooting of corruption. And Palak, Chaturvedi, and Nitin, Jadhav are going to tell us everything about how to deal with corruption in the database. So do you have anything else to add, Claire? Otherwise, we can just roll it up and then see this nice presentation.
Let's watch it. Let's go.
Some corruption on the streaming. It's coming. So we're going to.
I'm confident that it's going to play.
Absolutely, yes. Yeah.
And one of us is going to get interrupted mid-word when it finally does.
Hello everyone, myself Palak Chaturvedi. I am a software engineer at Microsoft.
Hi everyone, myself Nitin Jadhav. I'm a senior software engineer at Microsoft. Today, myself and Palak are going to talk about debugging data corruptions in PostgreSQL, a systematic approach. We will explain our experience on handling corruption problems first, and then we will summarize with the approaches to handling corruption cases, including best practices. The attendees can apply these techniques to avoid corruptions at first place, and also learn how to detect and recover from the corruptions if it happens. Palak, can you switch to next slide? Hi everyone, I'm Nitin Jadhav. I work for Azure Database for PostgreSQL team. I have hands-on experience in onboarding major and minor versions of PostgreSQL, as well as integrating new extensions into managed database environments. I have actively contributed to resolving customer incidents, including analysis and resolution of various data corruption issues. My association with PostgreSQL spans around 5 years, during which I have worked for PostgreSQL-based products and also contributed to the community as needed.
Hello everyone, this is me. I am a software engineer at Microsoft, member of the Azure Database for PostgreSQL team. I have experience in onboarding new extensions to FSPG, handling core downs and corruption issues, also making code changes to FSPG. I have been with Microsoft since June 2024. I interned in the same team. I have been contributing to PG community as well. So let's now start our talk. So this is the agenda for today that we have. We'll learn about what is data corruption, what are the causes that we have, and we'll have some analysis of few corruption cases. Also, Nitin will tell us how about the general approaches to handle corruption cases. So let's start. So before debugging data corruption, first we should know what is data corruption. So let's start with that question. So data corruption is like amnesia for data. It's like the Postgres forgets whatever it remembered, like it had some previous data, but it is something gibberish. It's like if you have a spreadsheet, you have very important data in it, but suddenly something goes wrong, and instead of that numbers, you have random characters that makes no sense to us. We can also say that these are unintended changes to the database. With respect to PostgreSQL, we can say these are the heap file table changes, index changes, or the wall file changes, or any important files that we have in our Postgres. Now let's learn about what are the causes of these corruptions. Like we can blame anyone for this corruption, but let's get to the real cause, which could be these three that we have figured out. First one is bad hardware. Like we can have a bad disk or bad memory or some faulty RAM that might flip our bits, or during the database is working and suddenly you lose the power, so that can also cause corruption. Second is bad software. Like there might be possible that there are bugs present in PostgreSQL, which is very rare, but maybe there are some bugs. Also, the bugs in kernel and OS. Also, the antivirus tool that we are running or the backup tool that we have. All these can cause corruption. And the last problem that can be is you yourself. Like if you think a file is not needed and you delete it, like sometimes pgwall folders reaches to up to 100 GB, but and thinking that it is taking space in your system and you just delete it, it can cause corruptions. So now when we want to learn about debugging data corruption, first we should know, like where can this data corruption occur. So we'll start by learning about the logical layout of our database cluster. PostgreSQL runs on a single host. It has one database cluster. Database cluster is a collection of databases. As you can see, database 1, database 2, and up to n databases. And inside each database, we have tables, indexes, and other objects such as views, function, and sequence. So this is the logical layout. Uh, to identify each database, we have OIDs, and for each table also we have OIDs. You can look at them in the system catalogs that are present at a PG class and PG database. You just need to run a SQL query where it is shows select star from PG class was select star from PG databases, and you'll know what tables do you have and what the databases that are present in your system. Now let's look at the physical layout. Physical layout is more important because this is where actually the corruption occurs. So when you run a initdb command, that is, you run initdb a test. If you name our test is the name where we want to start our Postgres. So if you run that initdb command, you'll see some a data a data directory is started, where the base directory is the test data that we have. Inside that we have multiple files and folders. Like in those files we have postgresql.conf file, that is the configuration file that we have for Postgres, where we can add like values for a few parameters. We have pghba that gives us about the connection that we can make, or the like the auth connections, and other folders such as pg wall folder and the pg like base folder and global. So let's look at the base folder. Base folder, when I do ls for base folder, we see multiple numbers like 1451642716498. These are the OIDs of the databases that we have present in our PostgreSQL that is running. So inside each of these folders, we have multiple tables, indexes, free space maps and visibility maps. Each table has its own free space map and visibility map, except for the indexes. Indexes do not have visibility map. What do I mean by free space map is that when the free space map is a table that tells us the about the pages, how much free space is present in each page. You'll learn more in the next slide. Similarly, visibility map tells us if we can view, if a transaction can view a block for like, so the visibility map bits are set true or false for those. And now we have the global folder. Global folder is common to an entire cluster. It contains some control files, file load map, and internal files, also some system catalogs that we have. So the corruption can occur at any of these places, at any of these files that we have present in our base folder. But now we'll look how the internal layout of a heap type table file can look, because any part of this can also be corrupted, because these are just hex random bits, so anything can be corrupted. So what is a table file? When we create a table, we get a file, in our data directory that has the OID of database and slash our table OID. So that consists of n number of blocks. Each block is of size 8 KB, and as the data increases, our Postgres keeps on adding new blocks to it, and the size of the file increases. uh, the maximum size of the file that we can have is 1 GB. After 1 GB, like the new file is added with .1, .2, .3 extensions. So that is the maximum file size we can have. Now we'll look, as you can see from the figure, the page size is explained, like what is inside the page. So inside the page we have page header, that contains PD LSN, PD checksum, PD flags, PD lower upper, these kind of things. Like LSN tells us the last LSN that updated that file. Checksum contains the data about those, the checksum that we have calculated for that page. And there is lower that points to the end of the line pointer, and PD upper that points to the starting of the tuple. So line pointers are the pointers that point to each of the tuple that we have, and tuple are the actual table data that we have. And between these line pointers and tuples, we have free space that the free space map data contains. Like this is the free space that we have where more data can be added. Next, like now we have learned what where the corruption occurs. So like the this page header consists of 24 bits. Any of those 24 bits can be corrupted, or the line pointers can be corrupted, or we can insert random values in free space that can cause corruption. So now we'll have an analysis of the few corruption cases that we have. We'll cover two corruption cases in our study. So let's start with that. First, we have the could not read block error. So this error occurs like, uh, this does not cause Postgres to go in a loop. It just is there, and whenever you try to look for that table, it throws the error that we cannot read the block, and like read zero of some bytes. So that occurs. Now this occurs when PostgreSQL tries to read a specific block from table or index file, but fails to do it. So that can happen during query execution or vacuuming. Like you are running a select statement and you have that corrupted file, then you will see that error. What are the causes? The causes are like the disk corruptions, like the this might have corrupted some of the files, or the file system issues, or accidentally you have truncated or removed the file, or while backing up the partial file is backed up. So all that can cause the could not read block error. We'll look at the simple corruption that we have first, like that is the corrupted index. So what you can see the indexes that you have in your uh, database using the pgstat user indexes, and each index will give you a pg relation file path that looks like base slash 16498.16546. This the 16498 is the database OID and 16546 is the index OID. So like the pg bench branches primary key is stored in this relations file. So now we'll try to corrupt our one index. So what we use is we run a dd command that enters random data in our index that we have. So what we do is when we run a command like select count star from pg bench branches, it throws errors such as invalid page in block 0 of relation, the relation that we get. And when we once see what is the relation, we get something like the pg bench branches p key is corrupted. So that's easy. Like when the index is corrupted, you can just use the command reindex and it would reindex the like create a new index, drop the previous one, create a new index, and everything would be corrected. So once we have that index is done, we can easily access pg bench branches and our corruption is over. Now we'll look take a look at a more deeper level of corruption that we have, which is very difficult to recover from. So what we can see all the tables using pgstat user tables, and we can similarly get the relation file path using the pg relation file path function that we have. So in my database, we have these four uh, relations that we have, and I would like start corrupting one of these. We here I have used three methods. First one is dd, that is a low level code that corrupts a single file. Like right now I want to corrupt the 16498.16543 file, so it can be easily corrupted using the dd command. When I corrupt some bytes, like in this case I have corrupted a checksum. I like entered a wrong checksum instead of the earlier that we have. So when the checksum is not matched, it throws error like page verification failed, calculated checksum 9478, but expected something, and we get an error that we cannot read that page further. So like checksums are not usually on for all the databases. We need to turn that on for each database, like using set checksum equals to one something. And then once it's done, it runs a sanity check for our database so that uh, the files are not corrupted, and we get to know when the file is corrupted or not. But the checksum is not turned on by default, is that because it's causes like since it runs checksum for all the blocks and pages, it is like heavy on a Postgres and the memory usage is very high. So we sometimes we for large database it is usually avoided, but you can do that for small databases that you have. Second method is truncating a file. Like you have a file and you remove some part of it. So when you do that, like you are reading a file and you run a truncate statement on your other command prompt, then it would throw some error like could not read block 1 of base something. And like since the block you have already removed that block and made the file size of 8192 kb, so it cannot read that block one. So this that could cause the error. Third method is like when Postgres starts reading our file, what it does is it gets the pg relation file size and then divides it's with the block size. So it then we get the number of blocks, and the md read function reads for those number of blocks. What if the pg relation file size is corrupted, or like whenever when you were going to run it was different, and suddenly the file size has decreased, or the block is not present, or there are partial writes, then also we can see the error as could not read block. And that we have. Now I'll hand over to Nitin for the second case that we have.
Yeah, thanks, Palak, for the explanation. I'll continue from here. We have seen many cases of this type of corruption. So first we need to understand when this can occur. So this occurs when the server is unable to read the checkpoint record during recovery upon start. So actually what happens is if the server is not properly shut down and then during the next start, it gets the checkpoint details from the PG control data file. So based on that, it tries to read the checkpoint record. So if it is unable to read it, either because of PG control data is corrupted or the wall data is corrupted, so then this issue can occur. Next is what can cause this to occur. We have seen some cases this issue was happened due to hardware issues and some cases due to software bug. So I'll explain each of these in detail in the upcoming slides. So we have now understood when this issue can happen. Before understanding what can cause this issue, so we have to understand how to verify the data is corrupted or not. One indication is the log message. So here the log message could not locate a valid checkpoint record. It indicates the corruption. But we need to verify a few other things before coming to a conclusion. For that, we can validate few data from the PG control data file. So we need to retrieve the content of PG control data file. From this file, we can get the latest checkpoints redo wall file and the latest checkpoints redo location. And there's a tool called PG wall dump, which is used to read the content of the wall file. So this tool outputs the wall content in human readable format. So in the example mentioned here, the wall file name is ending with 54 and the wall location is ending with 28. I'll pass this information to the PG wall dump and try to read the content of this wall file. If the PG wall dump tool is able to read the data, so then there is no corruption. If it is unable to read the data, so then that indicates it's a data corruption. Next, let's understand what kind of hardware failures can cause this. So we have seen cases where the VM running PostgreSQL went down abruptly. So the reason for VM going down can be many, but such cases are common in managed database. And we have also seen some disk failures that cause this kind of error. Next, let's understand how a software issue can also cause this. So recently we have seen some cases where multiple hard links were pointing to the same wall file. So this issue led to wall being overwritten and resulting in corruption. So the fix for this bug was initially implemented in version 16 and later versions, but it was not applied to the earlier versions. After many such reports, it is now backported to versions 15.11, 14.16, and 13.19. For more details about the problem and fix, and also there is some active discussion going on in the community. So for that, please refer to the link provided in this slide. So next, let's see about how we can recover from the corruption in this case. So if the problem is only with the standby, then rebuild the standby. So if the problem is with master, so then consider restoring it from the backup. So if the restore doesn't work, then we can use PG reset wall tool to reset the data and successfully recover from the corruption. But in case of PG reset wall, there's a possibility of some data loss. So we need to use this as the last option. So we have seen two types of corruption so far. Based on these data, let's understand some general approaches to handling the corruption cases. We will see what are the best practices, how to detect corruption, and then corruption recovery techniques. We will begin by exploring how certain configuration settings, when misapplied, can lead to data corruption. Next, we will look at how administrative or management errors can contribute to corruption scenarios. Finally, we will examine how mistakes during backup and restore processes can also result in severe and sometimes irrecoverable corruption issues. So in configuration settings, the first thing is don't set fsync to off. The fsync ensures data durability by forcing PostgreSQL to flush data to disk after each transaction. So setting this to off disables this safeguard, meaning data may remain in memory and never reach the disk. A crash, which could be due to power failures or OS crash, can result in data corruption. Even if PostgreSQL appears to work fine, the underlying data files may be in inconsistent state. It is allowed to turn off only in testing or benchmarking scenarios where the performance is prioritized over the data safety. It is not recommended for real workloads or environments where the integrity matters. The next one is don't set full page writes to off. This disables writing full pages to wall during first change after a checkpoint. So if a crash occurs mid-write, PostgreSQL may not be able to recover the page correctly. So this can lead to silent data corruption, which is even more dangerous because it may go unnoticed. So don't set full page writes to off. So next is run with checksum enabled. So checksums in PostgreSQL are used to detect corruptions at the storage level. As Palak explained, they're not enabled by default. So it must be explicitly turned on during cluster initialization using initdb, and we cannot enable these checksums midway. However, PostgreSQL provides a utility called PG checksums, which allows us to verify checksums on an existing cluster, but server must be stopped before using it. So let's understand how administrative or management errors can also cause corruption. So don't manually modify the data files in any way. So what happens is PostgreSQL data files are binary and highly constructed, managed internally by the database engine. So if we do any manual changes, so that can lead to data corruption, inconsistent indexes, startup failures. So we should not modify it manually. So the next thing is don't remove postmaster.pid. So this file is created when the PostgreSQL starts the server. So it contains some important information like the PID of the running PostgreSQL process. So the data directory path, port number, start time, and some other information. So this file prevents multiple instances of PostgreSQL from starting on the same data directory, which could cause data corruption. If you delete it while the server is running, PostgreSQL may fail to shut down properly, and also it loses track of its own state. And the third thing is don't remove wall files manually. So let me explain this with an incident that led to a significant issue. So we had a server where the disk usage had reached 100% and the server was shut down. So to make some room for the server to start again, so we had written a script to remove old unnecessary wall files to free up the space and allowing PostgreSQL to start. The idea was once the server was up, the customer could either delete unwanted data or increase the disk size. Unfortunately, the script had a bug. It mistakenly removed some wall segments that were still required. Uh, Specifically, the checkpoint record and the redo pointer were located in a different wall segments. And the script deleted a segment containing the redo record. As a result, the PostgreSQL crashed on the next startup. So this is a very rare edge case and is currently not handled by PostgreSQL. I recently shared a patch in the community to address this scenario, and I have included the link here. So if anyone is interested, I would appreciate your review and feedback on this. And also, it is very, very important to regularly monitor PostgreSQL and OS logs for unusual errors. So it's advisable to set up some monitoring tools that can track these logs and trigger alerts when anomalies are detected. Next, let's see on the backup and restore aspects. So it is very important to take the backups regularly. So if we have the backups and if the data gets corrupted, so then we always have the option of restoring from the backup. It is also important to understand that we should able to restore from the backups available. For example, suppose if the backup is older than the retention period, so then we might not have the valid wall chain to restore from the data. It is very, very important to maintain the valid wall chain in such cases. Otherwise, we cannot recover from the corruption if it occurs. Next, let's understand how to detect corruption. So one is to monitor the logs, keep an eye on the logs for unusual errors. Sometimes corruption can lead to crashes, incorrect results, or infinite loops. While analyzing these issues, we may end up identifying a corruption. So there are some messages like could not read block, could not locate a valid checkpoint, and there are some other messages also that indicates the corruption. Also, if the error code is XX001 and XX002, that also indicates the corruption. And there's a PG-AM check utility provided by PostgreSQL, which is used to check the corruption. So we can check the logical consistency of the tables and indexes. Palak provided an overview of PostgreSQL data page layout, where it was indicated that the checksums are stored in the page header. So actually, these checksums are used to detect the corruption in database pages. When the data page is written to disk, PostgreSQL calculates a small integer checksum based on the page's content, and that stores in the page header. So later, when the page is read back into memory, it calculates the checksum and verifies it. So in case of corruption recovery, so let's explore how to recover a corrupted PostgreSQL database by understanding some general recovery strategies like handling tgdump failures and finally using tgreset tool when necessary. So if the issue is only with the standby, rebuild the standby. So if the issue is with master, so then consider restoring from the backup or failing over to an unaffected standby. Evaluate whether you can reconstruct the data from another source. Only if these options are not feasible, so then try to attempt to recover the data from the corrupted database. Next, if you need to attempt data recovery from corrupted database, make sure to take the backup first. What if the recovery attempt makes things worse? So it is better to take the backup. And your goal should be to use pgdump to back up the database contents and then restore them to a new database, and then trying to fix on that database would be the best option. If you simply try to fix the existing corrupted database, so then there's a high risk of encountering future issues. So if pgdump fails due to an issue with a specific object, so consider dropping that object, especially if it's an index or temporary table. So as these can often recreated later without data loss. So if the pgdump is failing due to an issue with a specific index, you're unable to drop it. So in that case, consider doing the reindex, so which can potentially resolve the issue. So if the full database dump is failing, so then try to dump individual tables and schemas. So next, let's see how to use pgresetwall. Pgresetwall is a PostgreSQL utility used to reset the wall of the database cluster. With this, we can recover a corrupted database. So it is recommended to use pgresetwall when the database won't start due to lost or corrupted wall files, so which cannot be recovered. So in that case, we can use pgresetwall to recover it from the corruption. and this should be considered as a last resort as it can result in some data loss. Yeah, that's all we wanted to share. Thank you.
Good
yes,
stuff.
very, very interesting. And the good thing about this corruption in data that is always super scary, and there are some of those that you cannot do anything about it, like we were discussing with solar flares. Well, there might be some things that you can do. But I mean, in this case, they gave also very good tips about the things that you should be doing to prevent that this happens. So the first one, definitely, don't turn off fsync, please. So it will go faster, but as I said before, faster is not always better, because in this case, you need to go a little bit slower to make sure that your data is there. Anything you would like to comment on, Claire, from what we just observed?
No comments. No comments. Just that it's the kind of talk that's going to be great when it's up on YouTube, because people will be able to pause and replay and think about it. And I really appreciate them sharing their debugging practices. It's you know how video gamers like show how they play. I want people to do that more with Postgres. I want, the cameras to show how you're performance tuning, how you're debugging, and I don't know. It's kind of almost as fun as video gaming, maybe even as fun. All right, let's keep going. Surveys, really important. Apparently, everybody, those of us who were here in Livestream 2 are not submitting as many surveys so far as those in Livestream 1. We need to catch up. We need to do our part. We need to help the speakers get better. So please do submit the surveys. Remember, each talk gets its own survey, and it's just for Livestream 2. And now it's time to introduce our next speaker. And I get the honor of doing this. So I want to welcome Ashutosh Bapat. Ashutosh is a Postgres major contributor. He's employed at Microsoft. He's contributed to partitioning and foreign data wrappers and query optimization and logical replication, which is what this talk is about. I first met Ashutosh in person at PGConf India. I'm pretty sure that's the first time we met, which was an amazing conference. I went there for the first time earlier this year and just loved all the energy and the buzz. And Ashutosh is not only smart, but he is a delight to work with, really fun to collaborate with. And so unless you have anything to add, I think we should dive into this talk about logical replication theory and concepts.
Just want to agree with everything you said. I also have met Ashutosh, collaborating online, and it's always been very, very instructive. So I'm really looking forward to look at this presentation. Yeah.
All right, let's go.
Hello, I'm Ashutosh Bapat, major contributor to PostgreSQL. I'm part of PostgreSQL contributors team at Microsoft. Today, I will talk about logical replication, which is a relatively new PostgreSQL feature, and it receives a lot of improvements in every release. So let's get started. Okay, let's talk about logical replication. Logical replication in PostgreSQL inherited some of the structure from physical replication. So we'll talk about physical replication first, and then talk about logical replication, its components, what val sender does, what logical receiver does, what role replication slots play, and what to watch for. And then we'll conclude this presentation. Physical replication is an old feature in PostgreSQL. It is meant to replicate the physical view of the database, that is what is on the disk. So here in the picture, we see that there is an origin or upstream, which is a normal PostgreSQL server, where there are backends running, clients connecting, and they are making changes to the database. On the left bottom, you will see the disk view. and the backends make changes to that disk view or the physical view of the database. While that change is made, each change is recorded as what is called as write-ahead log. This write-ahead log basically tells which bytes at what offset in what page and in which file have been changed. This wall record is written first, and then the physical view is changed. In order to replicate the data, what needs to be done is we take snapshot of the disk at a given point of time along with the wall and copy it over to the target or replica. Now this physical view is exactly same at that point. Along with the wall, we start applying those walls. And when we have exhausted the copied over walls, we start streaming the walls as they are generated and apply to the physical view, thus bringing the physical view on the target at the same level as the origin, and thus maintaining the replica or the consistency between these two views. Now, eventually, the physical view on the target will be same as the origin. And since the physical view is same, the logical view of the database, that is what the results the query is written, will also be same automatically. And now that's how you have a replica set up with the physical streaming, usually for standby. Now, what happens here is since we want to maintain the physical view in sync on the between the target and the origin, we cannot modify the physical view on the target. If we modify, then that will lead to the corruption or the logical view being inconsistent between these two systems. And so the target is really only a read-only replica, and it cannot be modified. It cannot be active. With logical replication, we add more intelligence to this system. As you will notice that there is still origin, there is still target, but the disk view on origin and target, which you can see as the disk symbols at the bottom, is different. And the reason it is different is because we do not send the physical view of the database and also the physical wall. Instead, some intelligence is built at the origin to read the wall and convert it into a logical change. So instead of that change saying these bytes on at this offset on this page in this file have changed, it says that this table, this row, this column has changed, or in this table we have inserted this row, or we have deleted this row from this table. So the physical change is now converted to logical change and sent downstream to the target, where on the logical receiver on the target receives this change and applies it on the physical view of the target, producing a different series of wall at the target system. In a way, this logical receiver is like another backend, another PostgreSQL backend, making changes to the database and generating wall. As you will notice that now the target is almost acting like the primary or the origin, in the sense that it is active. It can accept connections, it can have its own backends, it can have its own tables, which may be separate from the origin, or there may be some common tables. But the crux is that the target system is as active as the origin system. And this is the first benefit of logical replication, that both the systems are active. We don't need to wait for promotion for the target to come up in case origin goes down. Let's dive deeper into the mechanism of the logical replication. Let's talk about the upstream first and the wall sender there. So on the upstream, we still read the wall, but instead of just sending it down, we convert it into a logical change. We should also notice that the logical view of the database consists of only the committed transactions. Any transaction which has made changes to the disk but has aborted does not contribute anything to the logical view of that database. We take advantage of this fact, and the upstream only sends the committed transactions to the target. With streaming logical replication, that changes slightly a bit, the underlying mechanism, but the principle remains same, that only committed changes appear on the replica. The second change that we will notice is when we are interpreting the physical change, we have to interpret it in the context of the transaction. And so we have to know under what transaction a particular physical change was made, so that that physical change can be converted into a logical change using the view of the database at the time of recording that change. For this to work, we reserve an area in memory called reorder buffer, where we segregate the walls by transaction. As we can see that there are 3 transactions here, orange, blue, and yellow. And in reorder buffer, their walls are segregated. If this memory area fills up, one or more transactions are chosen as victim, and their changes are flushed to disk to make way for newer transactions. When a transaction gets committed, if it's already there in the reorder buffer, it is passed to logical decoder. If it's on the disk, it is pulled from the disk and passed to logical decoder. Now, logical decoder is the one which converts this physical record into logical record and sends it downstream using the snapshot at that point in time. When on the target system, the logical receiver receives these logical changes, it has to know where to apply these logical changes. The tables on upstream and downstream may have the same name, but they have different physical locations and OIDs than the upstream. And so the logical interpreter has to know where on the physical view of the target should this change be applied. And then it applies that change. And while it does that, it maintains transaction state so that the change that is being made does not become visible. Again, this acts very similar to any other client backend, and other backends can continue to run while the logical receiver is working. So in order to, whether it's physical replication or logical replication, the upstream has to know how far we are in the wall stream in order to replicate it. How far a particular target has received wall from the upstream. The wall which has been already received and acknowledged can be released, making the disk free. But for doing that, it has to know the progress of this replication. And that is done through replication slot, which maintains this progress. And when it maintains this progress, it it also holds back the resources like wall, as we saw. Those are the ones that are interpreted and sent downstream. Then catalog tuples, because in order to interpret the wall, we need to know how to interpret it. Under what context, under what snapshot, we need to interpret that log record. What is the schema of the table being changed when that wall was written? And all that information is there in the catalog tuples that were generated, that were present at that time. And since we need to preserve those catalog tuples in MVCC, we have to also keep track of what is the oldest transaction that created these tuples, and thus it holds back the main transaction ID as well. And we will revisit this holding back resources a bit. Let's dive more into the actual mechanism of how the replication slot how the replication slot holds the LSN, holds the wall back, and what is its impact. So in this diagram, you will see that on the left side, we are maintaining snapshot of the transactions that are currently going. In the middle, you will see the wall stream. And for each wall, you will see the snapshot at that time on the left. And on the right, we see the progress of replication slot, how it is moving LSN forward. So let's assume that it starts with the first orange record, which is the first wall record of orange transaction. And let's assume that this is the first wall record in the wall stream. So it sends it downstream. It sends the next record as well. It sends the third record, which is the start of blue transaction. And it knows that a new transaction has started. It records it in the snapshot. It sends it downstream. The fourth record is sent downstream. If anywhere in between, while these 4 records are being sent, if the downstream tells that, okay, I have received 4th record, it will note it down as confirm flush LSN, but it won't change a lot, because let's say at this point, if the wall sender stops or crashes, or wall receiver stops or crashes, the wall sender has to start from the beginning of the orange transaction, because we have not sent the commit record yet for the orange transaction, and only the committed transactions really matter. So it has to go back, start from the orange transaction, and then proceed ahead. So it will still keep its restart LSN, which is the LSN from where a wall sender starts reading again, pointing to the first wall record of the orange transaction. Okay, let's move ahead. The next record is the start of yellow transaction. It noted it down. The next is second record from wall transaction, still noted down, nothing changes. Now we see the first commit record, which corresponds to the commit of blue transaction. And let's assume that the downstream sent a confirmation that it has received and applied the commit record of blue transaction. So one transaction was committed and it need not be sent again. But still, if you note, orange is still the transaction which has the oldest LSN. And so if wall sender restarts at this point, it has to go back all the way to the start of orange transaction and start sending the changes. And so restarts LSN does not move even if the confirm flush LSN has moved ahead. Now, what happens to the blue transaction? Even if we restart at this point, the blue transaction is not sensed, because we know that the last LSN of blue transaction has been confirmed. Okay, so let's proceed. Something interesting is going to happen here. The orange transaction has committed now. And we send the commit record for orange transaction to downstream. Downstream acknowledges it. Now we know that at this point, orange has been committed, blue has been committed, and it's only the yellow transaction which is active. And so we can move the restart LSN to the start of yellow transaction. As you will see that the restart LSN 3 is now pointing to the yellow transaction. So that's how the LSN can be moved. And any wall records which are before the first wall record of yellow transaction can be released. They are not needed anymore, and they can be removed from the disk. Sorry. Now, let's proceed a bit, and we come to the first transaction of the green record. We record it in the snapshot. Now there are 2 active transactions. Then we see commit of yellow. So now there is only 1 active transaction. Restart LSN can be moved even further to the first record of the green transaction. When the green transaction commits, there are no transactions active. And when the next transaction pops up, which is the blue transaction, the restart LSN points to the first record of the blue transaction. This is how the LSNs in the replication slot move. And by tracking this movement, the upstream can decide which of the wall records can be freed, which of the catalog tuples are not needed anymore, and does also move the transaction ID, minimum transaction ID. Okay, that's what we saw was the regular replication, what happens at runtime. But what about creating the initial snapshot of the database, or creating the initial logical view in order to set up replica? For that, we need to create replication slot. And when we create that, we will look at the arrow with label create replication slot. That's the wall record when the replication slot has started getting created. And at that point, there were 2 transactions active, yellow, orange, and blue. So the replication slot creation waits for these 2 transactions to finish. So till the 8th record, it has to wait. At that point, it again looks at what were the active transaction at that point, and you will see that the yellow transaction is only active. So it records the starting LSN of the yellow transaction. That becomes the first restart LSN of the replication slot that is getting created. And then the end of the orange transaction or the start of the green transaction becomes the confirm flash LSN and gives the first snapshot for that replication slot. If we run copy command at this point in the database, in the origin database, then we get the data that will help us set up the replica. That's exactly the data that we want for replica to be set up, and then start receiving the logical changes from upstream and start applying on the replica to move it forward. Okay. Now, logical replication is, as you might have noticed, it's a very versatile feature. It's very useful feature, and we will touch upon its use cases. How versatile is that at the end? But it's a risky feature as well, because it requires to hold back so many resources. And thus it needs monitoring. We need to take care of not breaking replication and fixing the replication as soon as we notice that it has broken. There are 2 ways in which replication can break, logical replication can break. The first is that the wall receiver gets into an error. It encounters a situation from which it cannot proceed. For example, it received a logical change which says that table 1 was changed, but there is no table 1 on replica. Then wall receiver does not know how to proceed further, and it will quit. The launcher will notice it, and it will restart the wall receiver. While this is happening, wall sender will also notice that wall receiver has gone away, and it will quit itself. Once the wall receiver comes up, connects to the origin, wall sender will start as well. That's how, if you follow the arrows in this diagram on the left, then you will notice the flow that I just described. Now, while launcher is waiting for retry interval to pass, if DBA or somebody notices why wall receiver quit, which it logs in the server error log, and they go and fix that problem, for example, here creating the table that was missing, then the next time wall receiver will come up, it can proceed ahead. It will pass that point where the error occurred. If not, then it will again encounter the same error, quit, letting launcher know, wall sender will notice, and the whole system will restart again. And this error loop will continue as long as the error is not fixed. If it's a temporary error like a network glitch, the system will recover from it. But if it's something that requires human intervention, then somebody needs to go and fix the problem. What might happen, and we do that, we find out what the actual problem is by looking at the server error logs, or if we have set some querying around server error log as it is available in Azure, there can be automated tools which can be used to detect this error and then fix it. However, sometimes what happens is wall sender takes longer to notice that the wall receiver has gone. In which case, if wall receiver comes up in before the earlier wall sender has quit, we may encounter busy replication slot error. And it can repeat again and again, thus shrouding the server error log and misleading us into thinking that the actual error is the busy replication slot. But in this case, what we have to do is we have to continue to look back in the error log and find out the original error. Sometimes busy replication slot is the real error if multiple replicas are trying to use the same replication slot. Usually there will be one replication slot per replica. In case multiple replicas are using same replication slot, then they can encounter this error, and in such situation, you may want to create separate replication slots for this replica. The origin side loop looks slightly different, where the wall sender encounters error, quits itself, wall receiver senses it, quits itself, wall launcher then senses it, waits for the interval, and then restarts wall receiver, which in turn connects to the origin, which starts the wall sender, and the replication resumes. If the problem which wall sender encountered was temporary, then it will recover from it. If not, then human intervention will be required. Okay, with that, I would like to conclude with some concluding remarks about logical replication. I want to emphasize that it's a very versatile feature. It can be used to replicate data across PostgreSQL versions, across multiple platforms where PostgreSQL is running. We can do selective replication in the sense that we can just choose to replicate only few tables, even within those tables, only few rows or few columns. So there is a lot of selection possible in what data we replicate. Not only that, this mechanism can be used for heterogeneous replication. We can use it to pull data from PostgreSQL into data lake, for example, or to some other DBMSs. And that continues to work by just using the origin and the wall sender there, but building our own wall receiver and apply mechanism depending upon the target. However, there are some limitations to the logical replication. One is there is no built-in bidirectional replication in logical replication. There is no DDL replication, but both of these features are being worked on actively on hackers, and hopefully in few releases we will see these limitations also been removed. When using logical replication, we have to be careful. We have to monitor the progress of logical replication, monitor the replication slots, watch for broken replication, watch if the wall is building up because of long running transaction, if the disk space is getting full because of wall buildup, because of the catalog tuples that are retained. Because the minimum transaction ID is also retained, there is smaller but positive chance that transaction wraparound will be reached, which is a very risky and very serious condition in PostgreSQL. All of these together can stop the origin from working. They can bring down the origin. So we have to watch for that. And with that word of caution, I will conclude my presentation here, and we'll open up for question and answer. Thank you.
Wow.
Yeah, I particularly like the how they say the diagrams where he explains the messages getting back and acknowledging. That's always something that I have problems trying to explain about why do you get so many points when you have your replication slots and stuff like that. So I really like that particular diagram, and I also mentioned that on Discord because that's also a place where you can provide communication to the speakers and then have a nice chat, and then we continue talking about how to find out the errors in the Postgres log servers. And a very nice talk by Ashutosh, as usual.
Yeah. And he is on Discord, so if you have more questions about logical replication or other forms of replication, he is there to answer your questions. Feedback, welcome. Survey links on the screen. Do a talk survey for each and every talk in this live stream, and you should probably know the drill by now, but we want to keep reminding people because speakers need to eat, apparently. And I think it's okay that we're running a little bit behind. I don't think anybody's too stressed about it, but we do want to keep the train moving, and this should be good. Talk to me.
Yeah, because Polina Bungina is really an expert on Patroni. She also has knowledge of things like distributed systems with Greenplum before, and joining Zalando. And in Zalando, as we know, is an e-commerce website with a lot of stressful situation, trying to have many servers working fine. And what is interesting is that usually you see presentations about how to use Patroni and which kind of command you should be using and how you should be creating your failover mechanism. However, this talk is going to go into the internals, because when you understand the internals of a system, then you kind of get like, this is why this command behaves like this, or, oh, wow, this is why I should be paying attention to this other information that comes in the monitoring. So understanding the internals is something that is crucial to get new questions, new opportunities, new architecture designs, and definitely Polina is going to be doing that with all her skills, her knowledge, because she knows a lot about this kind of stuff. I was lucky to be able to host her also in the previous year of Posette, and then I'm happy to be in this live session too. As I said, this is the best live session of the whole
You're
four.
so biased. You're so incredibly biased. And you're hurting people's feelings too, because people in those other live streams are like, oh,
well, I'm biased. I'm biased, but that's life. That's life, and because I'm a human, and humans are experiencing life with all these brilliant points and painful points. And this is how also Polina discusses that her talk is going to be, because there are some things internal that are brilliant and painful. But Claire, you're absolutely right. all the talks are actually super great. I'm just trying to cheer for the speakers that I'm hosting, and I really like Polina when she gives the presentation. So
All right,
let's go and check it out.
let's roll.
Yes.
Hello, my name is Bungina. I work as a senior software engineer at Zalando, a European e-commerce platform. But I'm also a co-maintainer of Patroni project, and today I want to share with you some insights about how it works, which might be helpful for everyone who is building or operating high availability for PostgreSQL. Okay, let's find this out. And the agenda for today is to look into what actually Patroni is in terms of functionality, what are the main functionality blocks, what it can do for you, and then look into the, of course, most important part, automatic failover. What are the common mistakes, what people usually do wrong in this sense, which will allow us to understand why Patroni looks like it looks like today. And then we will go deeper into Patroni itself. We'll look into the architecture, how it works, and quickly talk about the notable feature it has. So what is Patroni? This is important to say that it's originated from a Governor project by Compose company back in 2015. And since then, the main functions of Patroni were, of course, automatic failover, but also creation of cluster for you at its initial setup, cluster management. For example, you can centrally configure your Postgres instances. You can do some maintenance work as restarts, something scheduled as a, again, restart or switch over. And also to some extent, you can get some important monitoring information for Postgres, for your instance. Of course, it's not the actual monitoring system, but some useful information can definitely can be gathered from the Patroni API. And now to the automatic failover itself. What are the common mistakes done when implementing such solution? The very naive way of doing this, and the first thing that will come to your mind is, of course, to run 2 Postgres instances or any kind of number of Postgres instances, and just to ping primary from standbys with so-called health checks to see if it's still there. And if health check fails, for example, after some times, we will decide that primary is off, primary is down, and we probably need to promote the current standby and make it new primary. But there is an obvious problem here. If there's something with network, not the primary itself, we cannot differentiate this. And in this situation, we will just decide without actually knowing if we still have primary running or not. We will decide to promote our standby, which is of course not good. We will have the very worst situation for any DBA. We will have a split brain here when 2 primaries are running simultaneously. And this is obvious that we need some kind of backup way of making sure primary is remoted, or in other words, isolated from any writing load, any writing actions before promoting the standby to a new primary. But this means that we need a secondary network, any kind of backup network, to perform this so-called stone it, shoot the other node in the head operation to make sure primary is not running again, not accepting write connections and changes. But I would say it's quite difficult to do, almost impossible to get it right. And this way we can come up with the next solution, which is actually quite common nowadays, to have a witness node or arbiter, whatever you call it, but it's actually a node that pings or checks the current health status of primary and standby, or all of your Postgres nodes. And there is an obvious downside here, of course, that this is a single point of failure. And whenever you have your witness node down, You basically have your all HA down, high availability. But this is not only about this. Actually, there can be a so-called network partition where your primary is not accessible from the witness node, and another standby is basically isolated. And here we come to the very same problem. Witness cannot reach primary, cannot make sure that it's not running as primary, not accepting writes anymore, and just promotes standby on this information. And this is again a split brain. So to sum up, what we should consider when we are building auto failover solution. At least always think about network partition. This is the very important part. It can happen in many different ways actually, but you really need to consider this happening. Another thing is to think of the scenarios of split brain and how you prevent this. In other words, how you do fencing. The Stoney that I mentioned before, you can implement it in very many different ways. Actually, you can just shut the electricity down. You can reconfigure the proxy running in front of the Postgres that is redirecting the user queries to the current primary. So you just now start to point to another Postgres instance. And what is very important, kill the old connections. And this is how you isolate the old primary. But there is one very big downside here, that you still can have some local connections which you are not influencing with this reconfiguration of proxy. This way, it seems that the best and the easiest way is to have something running locally and performing so-called self-fencing. And the third thing I have not mentioned yet, but also very important, your HA component itself, so your agent or your monitor, can have some problems. For example, there are bugs, there is some resource starvation. And in this situation, there should be an additional component that checks the health status of this your HA component. And once it notices something is wrong, it restarts the whole system to allow it to return to the healthy state. And this approach is called watchdog. So now we decided that the best way is to have local agents and some arbiter that decides who is the primary, while agents are deciding and making sure the old primary is demoted, isolated from the writing activity. But there's still one problem here. Let's think of a more sophisticated deployment scheme. For example, we have multiple data centers in cloud providers. You would think of availability zones. But in this setup, you always will end up in a situation where you have your witness node and arbiter running in the same data center with primary. And after this happens, there is also a possibility that this availability zone data center becomes isolated. It's not reachable from the outside, not reachable by the standbys. But inside, everything seems fine. Witness node can reach primary. It just cannot connect to standbys, but that's fine. We still have primary running from its perspective. But in fact, all the outside connections are not able, they have errors, they are not able to connect. And our system does not perform switchover, even though we still have two healthy Postgres instances running. So how to solve this problem? Seems that we need to perform a collective decision. We need to make a collective decision. In other words, we need some kind of distributed consensus algorithm. And you can implement this algorithm inside your agents and witness node, but of course, there's always a good reason. There is always a good idea that you can use something from the outside, so something already implemented. And most likely you already have such a system in your infrastructure. It can be etcd, console, Zookeeper, but they all implement this distributed consensus algorithm. And your agent can just make use of it. And now I think it starts to remind you something which is actually true. This is how Patroni works. Now to the actual topic, how Patroni works. And let's start with the general idea. The general idea, as I said, is to have something external that implements the distributed consensus. It can be either Raft, SAP, whatever. But what are the systems that Patroni supports? It is etcd, Zookeeper, Console, Kubernetes control plane. They all fit this requirement, but other requirements are it should be a key value store for all the systems. I mean, the requirements are to be a key value store. They should perform and implement automatic compare and swap operations, atomic compare and swap operations, and implement some kind of expiration for the data, be it lease, session, TTL, as well as watches for this expiration, so that other members of the cluster can be notified that the data is expired. Let's look a bit deeper into how it works with this graph. So we have two Postgres instances running, and alongside we have Patronis. So the Patroni on primary, its job is to periodically update leader key and also write some other important information to the distributed configuration store DCS. Other members also write something. They write some important information about them to the DCS also periodically, and also they subscribe to the changes of the leader key when it expires. But update of the leader key means not just refreshing the value. It's a bit more sophisticated. As I said, it should be a compare and swap operation. So we only need to update the value if the previous value is the expected one. So we have our own name written there already. We also refresh the time to leave, TTL, to make sure the key is not expired. This way, as long as leader Patroni instance can update leader key, its Postgres instance keeps running as primary. But in any kind of situation where it fails to do so, it means that it is not able to be running as primary anymore. Let's look into the situation when, for example, the worst happened. We have a split of network. Our primary is isolated from other standbys and from the majority of the etcd nodes. For example, it can only access one etcd node, which, because it cannot form the quorum, becomes read-only. This way, primary can only read information from DCS, but not write into it. After some retries, it understands that it's not possible anymore, and what it should do, it should demote its local Postgres. Patroni demotes local Postgres once it understands that it cannot update leader key. At this point of time, TTL is still valid. Our key is still A, the name of the primary node, but the primary is already demoted. After some time, the key will expire. And as I said, standby instance of Patroni will be notified that leader key expired. As you see, it happened also already after the old primary is expired. So we are not getting the split brain situation. After leader key expired and standby node is notified about that, it attempts to create leader key with its own name, and if it succeeds, it promotes the local Postgres instance. When I say create, it's not just like simple create. It's actually, again, a compare and swap operation, because we can have a situation where there is not only one but multiple standby nodes, and they all will attempt to do those situations of creation if they're eligible to do so. And the compare and swap is about checking if the current leader is not present anymore, and we can create key with our name, like make us primary. And the one who leads will become the actual primary because the writes are serializable in etcd or in other systems that we use, and one of them will succeed, but all others will of course fail because the condition previously existing is not right anymore. We already have one created. In this case, node B became leader. Its Patroni promoted the primary. Others failed and continued to write as standbys. Now let's look a bit into what is actually written to the DCS. As I said, leader doesn't only write to the leader key. It stores quite some information about cluster. So we have configuration stored there. This is a global configuration that is applied to all the instances in Patroni cluster. We also have a unique identifier of the cluster stored there. The most important, as I said, leader key, and so-called members key, subdirectory that contains all the keys for members, which can serve as a service discovery because it contains information about the members important for connecting, for example. I will show this a bit later. And other keys that are not in bold here, they are stored in different times, but this is the ultimate list of everything that can be written to the PCS. If you are a user of Patroni, you definitely saw this table and used Patroni CTL utility. And this table represents the current state of Patroni cluster. And actually, this information is retrieved from DCS. Let's look a bit deeper into what is retrieved from where. Again, leader key is the name of the node of the member running as a leader. Initialize key is the unique identifier of the cluster. We also have information about any member in the cluster. And as I said, it can serve as a service discovery because it contains connection URL, API URL, current wall position of this member, etc. And another very important key is status. It's written by leader as well. It stores there its current wall flush LSN, information about the positions of all the so-called permanent slots Patroni maintains, physical and also logical ones, and our latest feature implemented in Patroni, retained slots list. It's the list of the member slots which Patroni creates that Patroni must maintain for a specified period of time after member disappears from the cluster. So the slot stays and it keeps walls for some time, allowing the member to return to the cluster and keep streaming from the primary. This might come in handy for those who are not using continuous archiving, or it also helps to maintain your logical slots in a valid state. And this is the very short version of how Patroni works. Now let's also look into what are the cool features, the bigger features we have. What really makes it so cool. I would name 5 of them. Of course, we have much more, but those are the bigger ones implemented in the past years. We have a standby cluster feature, which allows you to run cascading replication in a remote data center or region. We at Zalando use this feature a bit differently. We set up cascading replication for running heavy and long-run analytical queries without disturbing the original cluster, because we are restoring it from archive only. We also provide synchronous mode, which makes Patroni operate synchronous standby names, depending on the currently available healthy standbys and their positions. One step forward is a quorum-based failover feature. It allows to make use of the quorum commit feature in Postgres. Another, and probably my favorite one, is the DCS failsafe mode, which allows you to keep running the whole cluster in write mode. So do not demote primary if DCS is out for some time. This is, as I said, when the primary Patroni cannot update leader key, it of course means that it will demote the primary Postgres to the standby, but this is probably not what we want, and this feature allows you in certain situations to avoid this. Especially it's very useful in Kubernetes, where we know that Kubernetes API can blink or go away for a couple of minutes, for example. And last but not least, Patroni supports CyTOS extension and allows you to build highly available Postgres clusters. So, yeah, the last slide will probably be about the links I consider the most useful for all our users. These are the talks and tutorials about, even podcasts about Patroni, how it works, may give you more information because they're a bit longer. And the three last ones probably are must visit. Documentation, please read the documentation. A lot of questions go away if you carefully read one. Change log, please monitor change log of Patroni to make sure you see new features, but also you are informed whether your bug is fixed before reporting it. And for reporting bugs and asking questions, we have a Slack channel in Postgres Slack. Yeah, this was pretty much it. I really hope it was useful for you, and I will be happy to answer your questions.
To clarify any doubt, it was definitely useful. So
A +1 for me.
Yeah, and we were discussing on the Discord channel that actually for me, it's also, I agree that the DCS, the consensus layer fail-safe mode is definitely one of my favorite new stuff, because that's something that it hurts when it goes wrong. Yeah, so nice one.
Thank you, Polina. Thank you very much. And for those of you watching who have not yet joined the Discord, go to aka.ms/open-source-discord, and then go to the PosetteConf channel. And Polina is there right now and can answer questions. I feel like I'm on public radio or something, and I'm doing a fundraiser, and I keep repeating the same thing over and over again. And speaking of repeating the same thing over and over again, feedback is a gift. It really is. So there are some surveys that you could fill out for SOCs, but more so that speakers can get better. And now it's time to introduce our next speaker, Silvano Coriani. Silvano has been working on databases for over 2 decades now, with a lot of focus on troubleshooting and performance tuning. He has worked at Microsoft for many, many years, and currently works on Postgres within the Azure part of Microsoft. And I hope Silvano feels like he's in his best job now that he works with Postgres compared to, other things that he may have done earlier in his career. But of course, I'm totally biased and don't want to dismiss his past work. I just think Postgres is a really fun project. Today's topic should be super interesting for application developers, as well as those of us who work on the database. And it's about exploring .NET and Postgres on Linux as your open source software app dev stack. And with that, let's roll the talk.
Hello, my name is Silvano. I work on Postgres in Microsoft Azure, and I'm here today to talk about .NET and Postgres as the next open source application development stack for your solutions that can run on your on-prem, cloud, mobile, and many other platforms, and interacting maybe with the next-gen AI models that Azure is providing. Okay, so let's dig deeper into this very vast subject. By the way, here you can find my social media handles. Please follow me if you want to know more about this subject, because I'm going to publish a specific series of videos on this particular topic. This is going to be just scratching the surface, but you will see a lot more. I've been working on various roles in databases over the last 30 years, and I have a lot of experience in application development and database design. And this is where, I actually found that I think it was interesting for me to present you about this subject. Because .NET is a great platform. It's a almost 25 years old platform, and over the last 10 years, .NET has been open sourced, fully open sourced. And the support for other platforms, for cross-platform development and runtimes on Linux, on Mac OS, and other operating systems have been introduced. So why .NET? In reality, again, .NET is an application platform you can use to develop applications and solutions of all sorts, from cloud to desktop to mobile apps, IoT apps, and also more recently to interact with large language models directly from your application code using a variety of frameworks. It offers a bunch of tools. Some of them are proprietary, like Visual Studio, running on Windows, but there's a wide variety of open source tools like Visual Studio Code, most of the CLI commandlets, and a bunch of tools in the ecosystem, frameworks like .NET Aspire, and we will see specifically how this can help orchestrating, deploying, running distributed applications. And in terms of operating system support, we're going to focus specifically on Linux, although .NET can run, as we know, on Windows, Mac OS, and actually a bunch of other operating systems as well. So when we are developing our apps, we also need to consider the entire development loop, right? So starting from local development, again, .NET is supported on Windows machines, on Linux machines, and Mac OS machines. And we can actually run directly on the native operating system or containerizing our solution. So if we are on Windows, for example, we do have the Windows subsystem for Linux that is helping us to basically create and develop applications on Linux, although we are running on Windows. On Linux natively, of course, we can use tools like Visual Studio and create containerized versions of our applications, interact with Postgres, and at the end, we can either leverage CI/CD environments like GitHub, where .NET is fully supported across repositories and across the action pipelines, so that we can deploy fully automatically on whatever target, like our own on-prem data center, Azure, or other clouds, using basically the automated capabilities of these CI/CD environments to both provision resources like Postgres instances and our application code and containers. So we've seen that .NET can natively run on Linux. So let's see a quick demo on how we can install .NET on a brand new Linux instance just installed. Let's install .NET on a brand new Debian VM here. We can notice .NET is not here yet. And if we look at the details, we notice that this is an ARM64 processor architecture. So .NET is not available in our default package manager. So we need to use the scripted install and the .NET install tool. Once downloaded, we change the permissions to execute. And now we can install a specific version and a specific processor architecture of .NET in a fully automated manner. Once this is fully downloaded, let's wait a few seconds here. And now, again, we notice that .NET is not yet in our execution path. So what we need to do is to fix a couple of environmental variables here, .NET root and our path, and all of a sudden .NET is available on our machine. So we can just test a new console app here called test.net, and we can see that the application is effectively running once compiled. And now we can actually start installing our tools and every other library that we need. Okay, so it's that easy. Actually, .NET comes installed and prepared in all the official distro package feeds from a variety of Linux distributions. So Ubuntu, Red Hat, Fedora, Alpine, and in this case, .NET packages are basically loaded into the official package feeds. But there's also the Microsoft package feed where you can find .NET packages for pretty much every Linux distro, including Azure Linux 3.0, which is a Microsoft specific distro, fully curated specifically for the cloud. But there are also other ways of deploying .NET on Linux. If you are a Snap user, there are Snap packages there. Or, as we have seen, there are scripted tools that can install .NET on pretty much every processor architecture, not just x86 or ARM, but even PowerPC, RISC, and like S390 on mainframes. Once .NET is installed, again, we can develop our apps pretty much on every desktop operating system. So if we have Linux and we are using the Linux desktop, we can use editors like VS Code or many other open source editors. If we are on Macs, just remember, Mac OS is not Linux, right? So we need, if we want to target Linux environments, we need to either use a VM, like Parallels, for example, in Mac OS, or any OCI compatible container host, and develop our app targeting Linux. And then using VS Code, we can actually leverage tools like the remote development extension to connect to our containers or our virtual machines remotely and develop as we were effectively developing on our own operating system. Okay, it's very much likely that, again, when we are developing our app, we want to package them into containers in order to make sure that we can consistently developing and deploying on every machine without any problems related to specific libraries or environments that we have configured. So let's see in the next demo how we can create .NET containers and run them on Linux, both using Docker tools or other like OCI compatible framework, or directly from the .NET command line. In this second demo, we are going to talk about .NET and containers as a way to consistently build and deploy our .NET apps on Linux. After installing .NET, now we can actually leverage also some of the tools that we have available on this platform. And specifically, we're going to talk about VS Code here. So we're going to launch code in this project. And we have a very small .NET app here with just one single file. And in this app, we're just going to print out some operating system information and some .NET framework informations, right? And what we can do here right now is to go ahead and build our app and to actually run it. And we can see that we are running on Debian 12 on our ARM64 platform and with .NET 9 and the runtime for Linux here, right? So what can we do to actually containerize this app? So we do have the Docker extension installed here. And with that, we have a bunch of tools. Like, for example, if we do Ctrl-Shift-T, we can add a Docker file to this workspace to basically containerize our app. And if we select this, you can pick up the different application types. .NET Console is great. Linux is our target, and we don't want a Docker Compose for now. So right now, basically, the extension has created for us the full Docker file where we are pulling the runtime image here, we are pulling the SDK, building the app, and after that we are just publishing and copying the final bits in our target image, right? And what we can do right now is just to basically invoke the Docker CLI command and build our image, which is going to be called Docker container, tagging as ARM64, and selecting the platform as ARM64, as this is basically our target machine. Once this is built, we can notice that we have the new image created. We can actually run it. And this is just running as expected. As you can notice here, the .NET version is slightly different because this is the latest available in the base image that we've been using to create this. What is interesting is actually using the same platform here. We can also, like for example, build for a different target architecture. Like for example, we can do AMD64 and target our image differently. And we can see now, we now have two images, one for AMD64 and one for ARM. Of course, if we try to run our AMD version here, of course it's giving us a format error because this is targeting a different one. But what about if we don't want to learn Docker and all these different complexities? Well, the .NET CLI now has also integrated into the .NET Publish operation the creation of a container image. Now we are actually doing this and targeting Linux and ARM64, compiling as a release and publishing as a container and tagging this container with a given tag, right? So if we are doing this, we can see that .NET itself is basically taking care of not only building, but also publishing the container. And if we are looking at our images, now we also have, our Docker image here, and we can actually run it as the previous one with the ARM64 tag, and it's working exactly as expected, right? And again, even with .NET, we can actually do cross-platform compiling and image creation. And here we go. And now we're gonna have the different platforms are supported here. But what we're going to do here is we're going to actually run our container, ARM64 container in the cloud. So if we want to run our AMD image in the cloud, first of all, we need to tag it for our remote registry, and then we can actually push the image, local image, to the remote registry. So this is pushing, and once it's created, what we can do here is now to use the Azure CLI commandlet to create a new container instance with a name and a resource group and pointing to the image that we just created on our repository, and sizing the number of CPU V cores and the memory. This is 1 GB and 1 V core. Then this point we just need to basically provide Azure with the credentials to pull from the registry. And once this is done, Azure is pulling the image, and after a few minutes or seconds, it's going to give us the new container which has been created. We can check it with the Azure CLI if the resource has been created. We can see, yeah, this is the name, and we can actually connect to that container and look at like the output, which is in the logs, and we will see that basically the application here we are is basically outputting the same information. So Debian 12 now it's on a AMD64 image, and these are the .NET runtime information. Okay, so what we're seeing here is we can start by Dockerizing our application thanks to the Docker extension in VS Code, or leveraging the .NET Publish capabilities of creating a Docker container, and then we can run the container locally, or we can push it to a container registry and run it everywhere in every cloud that supports a Docker container in their hosting services. And running Postgres in containers together with your applications, .NET applications on Linux, is very, very simple. And in this demo, we will take a look at how we can package all together and run your application development locally or remotely using containers. In this demo, we're going to bring .NET and Postgres together on Linux, and we will see how containers are actually playing a role here. So let's open up VS Code, and I have a very small project here, which is actually an API, ASP.NET API, right? And project is actually very simple. Is creating, first of all, the application builder here, and is doing a setup of the database, and we will see how this is configuring the database for us. And then it's basically exposing one endpoint called customers, where we are leveraging the NPG-SQL library, which is the official .NET ADO provider for Postgres. And we are creating a new connection, and we are creating a new command, which is just retrieving all customers from the schema sales. And then we are executing the query and iterating around all the returned results, all the rows. And for each row, we are creating a customer object, adding to a collection and returning as a JSON result set out of my web API invocation. Right, so the application is actually pretty simple, but I don't have Postgres instance to deploy on my own machine here. So what I was doing, I actually created a Docker Compose file here. And the Docker Compose file is made of two different services. There's an API project here, and there's a DB project. And the DB project is referring to an image called Postgres latest, which is polling from the Docker public repo, is polling the Postgres image and is configuring some environmental variables here for setting up a user password and DB name, is exposing a port, and then is also checking that the deployment and the ramp up of the Postgres progress is okay before returning okay to the API project. And the API project is basically just using the image created here with this Docker file, and which is building, as we see previously, our app into an official Docker image for .NET, in this case for ASP.NET. So what we need to do here to make it run is simply to say Docker compose up, and this is pulling the DB image from the public repo, is also pulling the API, is building actually the API app and the related Docker image. And once this is done, we should see in a few seconds that again, here we have the Postgres log showing up here together with the application log. So application is listening on port 8080. So let's see if here we go. And this is basically the result set coming back from the database and returned as a JSON fragment. We could also have tested here using the .http file created by the .NET template, which is giving me the ability to test it, to test my API directly from my VS Code instance. So if I click send request, we can see the response right here. Right. So let's take a look at our code here for a second and go back to this setup DB code that we have and the perform upgrade. Those are important ones because they are leveraging a library called DBUp. DBUp is an open source library for dealing with change management in my database. So at first, what DBUp is doing is making sure that the database exists. So I'm passing a connection string, which is here in my application settings for the development. And so what the DBUp is doing is checking that this database Postgres effectively exists by connecting with my Postgres instance and running a query on the system views in Postgres. After that, the DBUp, what is doing is deploying changes to this database that we are that we are connected with, and is basically reading scripts from within this app. And the scripts are here in this folder, which is actually pointed out, as we can see here, in the project file, where I'm just saying, hey, scripts are just embedded resources in my app. So let's see what the scripts are doing. First of all, the first script is just creating schema called says, and the second script is creating all database tables and is also inserting some reference data in those tables. So by invoking this deploy changes and the perform upgrades, the DB app library is checking that those changes have not been previously applied by using a system table, which is taking notes of all the executed operations on the database, and then it's just performing all those operations that we are seeing to make sure that my database is ready to go when the application is connecting. So basically, this is a way to prepare our database and make sure that we have a consistent database state to run our application against. And if we connect with my local instance here, here we go. We can see that we do have our sales schema with all our tables. Right? Let's pick up the customers table. And here we are. So we are running Postgres on a local container using Docker Compose together with our app. And our app, when it's starting, is basically checking that the database is fully configured, the tables are there, and all the data are ready for my application to run. So this is just a way we can interact with our local development here using Postgres on containers and using .NET on our app. From your .NET app, how we are going to access .NET is through the NPG-SQL ADO.NET provider. So NPG-SQL is basically the .NET data access library for Postgres. It's 100% managed code, C# code. It's actually maintained by a number of developers from the .NET data team itself, and is supporting PostgreSQL protocol for applications running in .NET using classic paradigms like connection, command, result set, and so on. The other option to access Postgres from .NET code is using Entity Framework. Entity Framework Core is a fully fledged ORM, and means that you can create your data model in code. You can access your database and have all your code operations translated to SQL, and your result sets basically hydrated into your object collections in your code, and you don't need to deal with specific SQL syntax or such on yourself. Entity Framework is also managing all the life cycle of your database using migrations, a pretty well-known concept, where you can basically generate your database objects from Entity Framework, update them, maintain them, and so on. So ADO, plain ADO.NET or Entity Framework are the way we are connecting to Postgres and executing our code. So let's take a look at this demo and see how we can connect to the database. In this demo, we are using now a web app instead of an API app, and we're using Entity Framework Core to connect to the database. So we can see we still have ASP.NET middleware creation here. So we are creating the builder and so on. But this time we are actually using a DB context. DB context is the main class in Entity Framework Core for connecting to the database. And we are using the new seeding capabilities to actually kick off population of the database and the preparation of the database, actually using Entity Framework migrations before that. So let's see what we can do for actually getting Postgres instance first. So I actually created this command here for kicking off a brand new container, right? And so container is now up. We can connect to that instance. me see. Okay, and we have the Postgres database here, but in our demo this time, we're going to use actually a different database called SAIS, right? So we need to initialize the database. We have two ways. One is manually by using the .NET anti-framework tool and invoking basically the migration of the code first classes here into the database, and then the basically insertion of the reference data, or the other way around is to actually let the code the first time is running to do that. So let's go with the entity framework migrations now. So we can see we can use the same .NET CLI here and say EF, which is the entity framework tool, database update. So what this command is going to do is basically taking the schema, creating the schema of the database, and then inserting all rows. Right. So here we go. So now if we connect back to the database and refresh, we have the sales database with various tables, and let's see the customers table. So now we can just test if our app works correctly. And this is the homepage of our web app, which is actually reading data out of the database. And if we go back and take a look at our console here, we can see all the database insertion and preparation operations that we saw previously. And then when the application is starting, we can actually see the logging of our entity framework query, which in this case is a simple select out of the SAIS out of the customer tables in the SAIS schema, and the execution. And this is, again, we haven't actually written any SQL code. We can go and take a look at our code in our main page. So if we go to the index page here and we take a look at the code, we can see that what the entity framework syntax here is doing. I'm just taking the context that we previously declared at the beginning of the creation of our ASP.NET app, and I'm just asking for all the customers within the table, in async manner, and then we are basically using this customer collection. Here we go. We can just use this collection, iterate, and create our HTML, generate our server-side HTML. Right, so this is actually a different way of connecting with the database. We don't write down directly SQL queries, but we are using Entity Framework as a fully fledged ORM to connect to the database, interact with tables, insert, update, delete, and retrieve data. Okay, so .NET Aspire can help us orchestrating our application deployments. In Azure specifically, there are a number of hosting services where we can actually deploy Linux containers depending on the scale and the size of our applications. Starting from Azure Application Services, where typically small web applications and APIs will get deployed, to Azure Kubernetes services, where more complex and distributed applications can actually be deployed, or deploying individual containers using Azure Container Apps and Azure Container Instances, right? And a bunch of other services, right? So Azure is offering us all the native PaaS services where we can deploy our apps, and is also offering us a fully managed database service called Azure Database for Postgres Flexible Server, which is, by the way, running on Linux containers in Azure. So you can see here a quick glimpse of the architecture. Postgres is actually running as a container within a Linux VM in a fully automated manner, is leveraging Azure storage, specifically managed disks, for storing data and the wall log, and is managing high availability, scalability for us, right? So if we think about what we've seen in the demo, we can deploy our .NET code in different hosting services, from VMs to web apps to Kubernetes, and we can target our managed Postgres service which is again running on Linux container. So we are running on Linux end-to-end from our application code to our database backend code. And .NET Aspire is a great tool and a great resource for this, right? It is helping us during the local building and testing, and using the orchestration tools is basically helping us to deploy seamlessly from your desktop to the cloud or to any CI/CD pipeline environment like GitHub Actions or Azure DevOps. So it's also giving us some interesting tools like our developer dashboards, where we can see all the components in our app. We can see how various components are integrated. It's taking care of injecting things like connection strings, environmental variables, and all the other settings, taking care of all this complexity for us. Is also exposing all telemetry data built on top of open telemetry standards, so that we can debug, trace, and understand how our application is running. And it's not just working on Azure, it's actually working on any cloud. So to recap, .NET together with Linux, running in containers, and Postgres are the best environment for developing your applications in Azure, but also on other clouds, and is clearly providing you like an end-to-end environment here where, again, it can simplify your inner loop and your outer loop, and all the release activities in order to publish and run your applications in production. Right, so this end-to-end tool is fully open source, as we've seen, is basically free of charge from a licensing perspective, and can be the next application stack where you're running your applications. If you want a very interesting reference architecture and application, I would recommend you to go to github/.net/eshop, where you have a fully fledged e-commerce-like solution, fully running on containers, .NET, and Postgres. And you can take a look on how you can not only develop simple apps, but also complex distributed apps interacting together using caches like Redis, using queues like RabbitMQ, and also interacting with OpenAI language models in order to provide like assistance, an intelligent chat for your own users. So please take a look at this reference architecture because it's very, very interesting. Okay, so that's all for today. I just wanted to give you this quick introduction about .NET, about Postgres, and how to run this all together using tools like .NET Aspire on Linux and fully open source platform. Thanks again, and please keep an eye on my social handles because I would publish more about this topic soon.
I get the feeling that Silvano likes making demos. You don't create that many demos if it's something that you avoid. It's got to be something where he gets into that flow state and just enjoys putting it together and showing people.
Yeah, I really like that. And I also like a lot the interaction that was going on in the Discord channel during this presentation. So many discussions there that you can check. Then even if you join a little bit later on Discord, you can always see what is going on in this live stream, of course.
Yeah, because it's the same Discord chat for all the live streams. Just scroll back further to find out what was going on. If you just joined, then make sure to fill out a survey. Here are the URLs, here are the QR codes. Follow the instructions, get your socks, get your stickers, and give the speakers feedback. And
yes, and I don't know who made the schedule and the order, but kudos. I think this is probably either you, Claire, or yeah, there you go. So the first talk that we have today, the keynote, was about artificial intelligence and the challenges that the Postgres database or databases in general are facing to integrate these two worlds that are going in a synchronous move path forward in the future of technology. Now we're going to close up the live stream in 2 with another talk about artificial intelligence, but now with a single purpose, to automate the creation of indexes. And we are going to see how our next speaker, Nacho Alonso Portillo, is going to go through this path about automation. We're going to talk a little bit more about automation at the closing words when Claire and I am going to kind of wrap up this. But before that, let's enjoy this talk. So let's give it a go for Nacho.
Hi, everyone. My name is Nacho Alonso Portillo. I'm a Principal Technical Product Manager in the Azure Database for PostgreSQL team. In this session, I'll be introducing a fantastic feature in which we keep investing to extend its scope and evolve its functionality. You're interested in this session if you're a system engineer, a developer, or a database administrator who is struggling with performance issues. Hey, welcome everyone. Welcome to the Dear Azure Database for PostgreSQL, Can You Automate My Index section, which I'm grateful to present today to all of you. So first of all, let's jump into the agenda. Topics we will cover is an introduction to index tuning, the process of index tuning, explaining what it is about. What are the key features of this automatic index tuning capability that Azure Database for PostgreSQL has built in. I'll walk you through a demonstration to configure automatic index tuning and see how recommendations, index recommendations are rendered, how you can access them, and how you can implement them. And then we'll walk through the value proposition of the feature and finally wrap up with the conclusion. So as an introduction to index tuning, indexes significantly enhance the query performance by allowing quick data location and fast access to your data. Indexes reduce, when properly configured, they reduce the need to scan more rows than those strictly needed from a table to satisfy a given query, making data retrieval more efficient. And indexes are also a crucial component of the database management system. And when they are correctly tuned to optimize the performance of your workload, your server requires less resources, and therefore you can keep the costs constrained. What is exactly index tuning? Well, it's an iterative and continuous process which involves observing the workload you're running against your data and analyzing current database indexes to enhance their efficiency and effectiveness for better performance of your current workload. So during the index tuning process, you might need to create new indexes that could significantly improve the performance of certain queries by providing quick access to data in a database. You might also identify unused or duplicate indexes. Removing unused indexes or duplicate indexes helps streamline database management and enhances the overall system performance. And finally, you might need to alter existing indexes, and that might be necessary to adapt to changing data patterns and to optimize query performance. Also in PostgreSQL, while creating or altering indexes using the concurrently clause, the process may fail and leave indexes in invalid state. Those indexes cannot be used by queries to seek for data. Those indexes need to be maintained by data modification language operations. So it's very important to identify those invalid indexes as soon as possible to either delete them if they are duplicate of some other valid index, or rebuild them until the operation completes successfully and they become valid indexes which are usable by the whole system. Now that we have an overview of what index tuning is about, let's put this in context because this feature, this automation feature, is provided inside Azure Database for PostgreSQL, right? Azure Database for PostgreSQL is a managed database service that simplifies the deployment and management of PostgreSQL databases and comes with several features and capabilities which are managed for you and help make your life easier as a developer or as a database administrator. The service provides flexible configuration options. So it allows you to tailor your Postgres databases to specific business needs and to specific workloads. And it brings a lot of built-in features like the one we're discussing today. And the one we're discussing today, which is automatic index recommendations, supports robust index tuning to help you enhance the performance and efficiency of your databases and your workloads. The key features of automatic index tuning are the system automatically analyzes the performance of the queries that your workload is running and identifies potential indexes to optimize the execution times for better efficiency, to reduce latency, basically. It eventually emits index recommendations that aim to enhance the performance of the workload that was previously analyzed. And it simplifies drastically the management of indexes, which is a meticulous and time-consuming work, by automating the whole process of observing your workload, discovering the appropriate indexes to improve that workload, the performance of that workload, and it basically reduces the manual effort and improves the overall database performance. For monitoring and maintaining indexes, it's part of the indexing process. It's not just a one-time process, but it's a continuous thing. So regular maintenance of indexes is crucial for ensuring optimal database performance, and efficiency in data retrieval is there always. Even when when your data grows or your data distribution changes, or when the data patterns change, or when the concurrency of user changes, the performance must be kept optimal at all times. So it is very important to continue monitoring and suggesting new iterations, new improvements. Automatic index tuning, while it's enabled, it keeps observing and analyzing your workload and the usefulness of your existing indexes. And it keeps proposing new recommendations as the circumstances change, whether it's the volume of data, its distribution, or the type of queries you're running. And the system not only continues identifying underperforming queries and unnecessary existing indexes, but it suggests which new indexes can be created, which ones could be dropped to improve the overall database health. So those are the adjustments that that you can do during the iterative process. The feature is accessible and can be operated at scale by means of it's integrated into both the Azure portal and CLI. So we are not just making performance tuning smarter, we are making it accessible and scalable. Whether you prefer a visual dashboard or a command line pipeline, you can now optimize PostgreSQL indexes with confidence, speed, and control. And now we're going to switch over to a demonstration in which I'll show you where and how you can configure index tuning, automatic index tuning, and how it will surface recommendations, and how you can apply those recommendations. So let's switch to the demonstration. So what we have in front of us right now is an instance of Azure Database for PostgreSQL Flexible Server. In the resource menu, down under Intelligent Performance section, there is a menu handler to index tuning. So if you click there, you have index tuning page from where you can enable or disable, or you can configure the tuning settings of index tuning. But to enable index tuning, you can do so from here or from here to configure the different settings that it offers. You can select tuning settings and change any of those multiple settings and even enable it from here as well. So it's as easy as clicking that button and it will be configured with the default parameters. Another way to configure an index tuning is by using the CLI. So you can do you can use the Postgres flexible server index tuning command grip, and then you can do, for example, show point to a particular resource group, a particular server name, and it'll tell you whether index tuning is enabled or not. It's telling us it's enabled because we just enabled it from the portal. We can also disable it from here. And if we go back to the portal experience to see how it looks like, it'll now show as disabled again, giving us the option to enable it one more time. Now we'll move to an instance in which index tuning has been enabled for a while, and it has been monitoring the workload that was running on this server, and it has even produced certain recommendations. So if you visit the index tuning page of an instance with all those conditions, then you have a summarization page here in which it tells you the index tuning is enabled, the tuning frequency currently configured, meaning that every hour it'll wake up and analyze the workload that was captured during the previous hour. If it's configured to 12 hours, for example, it would just live back 12 hours, the workload that was recorded during the previous 12 hours. And it'll focus on the queries, the least performant queries. And it will suggest what indexes can be created, what indexes should be dropped because they are not used or because they are duplicate of some other index, or which indexes need to be rebuilt because they are invalid and there are no duplicates of those. This is the summary view. If you click on this one, you get to this detail page where you can sort, search, or filter by any of these columns. And the two recommendations types are create index or drop index for now that we are seeing here. And for each of them, we have different attributes. For example, for drop index recommendations, we cannot compute the improvement percent. However, we can compute, given the size of the index, we know how much space we might save. For indexes that we're recommending to create, we can also compute an improvement, a hypothetical improvement percentage based on the queries that would be helped or would be optimized by any of these indexes and by how much. So if we, for example, look into this one, this index is being recommended for this reason, because this column appears in a join clause of a query with this ID, or it appears in a join clause of a query with this other ID. These are the two queries. As you can see, the improvement in each of them is is very different, drastically different, but it would benefit both of them. And it's up to you to get this recommendation on a plate. We automatically produce a name for the index. We keep track of the object for which the index is being recommended. The columns contain or referred by the index, and when this recommendation was emitted for the first time, when was emitted for the last time, most recently. For drop index recommendations, we simply give you the reason why we are suggesting to drop this index. And in this case, it's because it's a duplicate index of another one, which already exists. But that one has a shorter length compared to this one. And that's the reason why we suggest to drop this one. Okay. The recommendations can also be queried from using Azure CLI, and there is in the index tuning command group there is another command which is list recommendations, for which you can filter for a given recommendation type, like create index or drop index, and this will retrieve all the recommendations accumulated in this particular server of that given type, and it returns a JSON payload which you can process programmatically, and you can extract from here whatever amount of details, the same details that are surfaced via Portal. So things like the reason why this is being recommended, the script, the query IDs of the queries that would be improved, the estimated impact of this index in those queries, and the estimated impact in size. If the index is created is estimated to occupy this many megabytes, and so on. So this is it about listing recommendations via CLI. Now, if we go back to Portal, and we navigate through the different settings that you can configure for the feature, not only you can decide how often you want the tuning sections to run, but for create index recommendations or for drop unused index recommendations, you can also set configure some settings that control how those two algorithms that decide the creation of new indexes or the removal or the suggestion to remove some existing indexes, how they should behave. So for example, for create index, maximum number of indexes that you want to be recommended in a single session, maximum number of index columns, index key columns that any recommended index should have. What is the maximum total index size compared to the total disk space of the database? Minimum estimated regression, maximum estimated regression, and minimum estimated improvement, so that we only recommend indexes that at minimum improve, hypothetically improve the performance of at least one query by 20%, and never ever regress any existing query by more than 10%. That's what these two settings mean. The maximum number of indexes per table that would be recommended, and how many queries in the worst n queries that the tuning section will focus. By default, it's 25, but this is adjustable also to, you can lower it down to 5 or increase it up to 100. Likewise, for drop unused indexes, you can change some of these settings. So, something more, once you apply those changes, those recommendations, let me pick some of those recommendations, for example, from this one, we can pick some of these indexes and we can bring them to Visual Studio Code with it. Visual Studio Code with the PostgreSQL extension for Visual Studio Code, which is currently in public preview. And you can query queries for views based on which index tuning does the analysis. So index tuning relies on query store. Query store is where we record all the activity, what queries you have run, what is the query text of those queries, if those are parameterized queries, what are the values that you pass for the parameters. If you configured a search path, we keep the search path that was used in the context of the execution of this query so that we can understand when this query was executed, what were the different locations or the different schemas that were used to the binding of the different objects. So with this, you can retrieve the text, for example, of the queries, the query text, which is something that for now you cannot get through an external API or the portal for privacy reasons. This is considered PII information. So in order to get the query text, you must connect to the database to retrieve and have the permissions to connect to the database so that you can retrieve the query text given the query ID. Otherwise, from the portal or from CLI, the only thing you get is the query ID, which to correlate to the query text, you need to be able to connect it with the database. So you can do that for the different query IDs that we retrieved from portal or CLI to identify which queries are those. And there's also a schema in the Azure SIS database, which is called Intelligent Performance and has sections as an object. So this will enumerate all the sessions, all the tuning sessions that have been executed in the context of this instance, when they were executed, and how many recommendations were emitted on each of them, on each of the sessions. And then there is another object, which is recommendations. So for each session, it might produce known or many recommendations. So when recommendations are created, they're surfaced through the recommendations view, from where you can get things like you have for each recommendation, all the statistics about it, and an object called recommendation context, out of which you can pick, is a JSON object out of which you can pick things like the script or the query IDs of the queries that are improved by if you would create this index. And this is basically it. So if you want to create an index, you simply pick the query, the script that we provide, and you can run it. This wouldn't work here because I'm not in the context of I'm not in the context of the database in which I have to create this, but it's just a matter of connecting to that database and run the create index script to get the benefit of the improvement. And then you could come to back to the portal, and under intelligent performance, you have the query performance insight, which if you have properly configured, you could monitor what was the impact. I mean, manually or visually, you can see what is the impact after having created that index, how your workload would improve after having created that index. Okay, and with that, we can come back to the presentation part to talk about the value proposition of automatic index tuning. So the value proposition of this feature is implementing effective index tuning enables databases to accelerate query performance significantly, reducing response times. That directly enhances the user experience, allowing users to access data quickly and efficiently. And higher query performance translates to increased productivity of applications relying on your Postgres databases, improving your overall business workflow. So the other thing, the other benefit in the value proposition is reduced manual effort. So this automated feature simplifies the process of index analysis and tuning, minimizing manual intervention. And with reduced manual effort, database administrators and developers can dedicate more time to strategic initiatives and project planning rather than this manual work. And it also has a component related to optimized resource utilization. So with properly tuned indexes, you can significantly improve the database performance by optimizing how data is accessed and retrieved. Queries that access the data through those optimal indexes typically lead to fewer I/O operations, and it enhances the overall system efficiency and reduces the latency of your workload. And it also directly, by optimizing the resource usage, your business can significantly lower costs associated with resource consumption and operational inefficiencies, like the amount of money that you pay for the compute, for the CPU power, or for the amount of memory that is required, or the power of the disks that are attached to your servers. If you reduce I/O operations significantly, then you can have like NOTs. So good disks. You could live with lower end disks. And as a conclusion, index tuning is crucial for enhancing the performance of databases. And Azure Database for PostgreSQL offers a smart and easy way to tune your indexes automatically. With deep integration into the Azure portal and CLI, you can monitor, analyze, and optimize your indexes based on real workload data. It's like having an automated assistant for performance tuning, one that speaks fluent SQL and works 24/7 to make your database faster and leaner. And by the way, stay tuned because we are soon extending the functionality of index tuning to also provide table-level recommendations. We keep investing in this feature, and we are extending the scope of it and improving the functional aspect of it. So with this, I hope you liked this session and the content shared here today with you was valuable to help you work better and smarter. Thank you.
Thank you, Nacho.
Yeah. I hope that we are also better and smarter, or at least better informed. There will be already progress.
All right. So that was our last talk. Definitely time to put the survey links up here. If this is the only live stream you're participating in, please give the event organizers feedback. That's the URL on the right. Talks, surveys for each talk. That's the URL on the left. Anything else I should say? Have we hit this horse dead?
I mean, everything is continuing here on the discussions on the Discord, and getting the feedback is a way of also thinking about what we have learned and then thinking about new ideas for the future. So I think it's all good. It's all good.
Now, because that talk that we just heard was about Azure Database for Postgres, I just wanted to put in a plug for a new series that's coming up on Microsoft Reactor. I put a short URL and a QR code on the screen. I think there's going to be 4 sessions, and it's all about building AI agents with Postgres. So if that's something that you're interested in when you watch this, you should go check it out. I don't have the start date, but I know it hasn't started yet. So, and yeah, this was fun. What a great, some people say this is the best live stream out of all
Some
4
people.
live streams. I don't know who those people are. Actually, I do know who those people are. That would be you, Boris.
Yes, I'm a big fan of these speakers that are here. Yes.
And what's next? So there's 2 more live streams to go. One starts in just a couple hours. So live stream 3, and then live stream 4 is going to be the same time zone that, or the same times that we just went through.
Yes.
Just one day later. You can join the Discord if you haven't done that yet and be part of the conversation. Submit your feedback, and you can watch the replay of this live stream now. Like, you don't need to wait for all the individual talk videos to be published on Thursday. And speaking of the live stream that's going to happen on Thursday, European time, 8 a.m. CEST, we have a trailer. I want to roll this trailer.
But before you roll the trailer, I want to show you that I'm super happy to be here in Italy, drinking my nice Italian coffee, so I can enjoy this trailer with a nice taste, and then understand that maybe this was not just the best live stream, but maybe all of them are at such a level that we can continue enjoying this great conference. So let's go with the trailer, and cheers.
Let's find out. I hope.
Otherwise, I keep on enjoying my coffee. It's really good.
Dun, dun, dun. Live stream 4 trailer.
Hi everyone, and welcome to the 4th year of Posette and Event for Postgres. My name is Charles Pedersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hello, everyone. I'm Marco Slot. I work at Crunchy Data, and I'm going to talk about a journey we've been on for the past 18 months to build a Postgres data warehouse. So if you're interested in using Postgres for analytics, or you want to know more about what's possible using Postgres extensions, this will be a very interesting talk.
Hi, my name is Derek van Veen. I'm a database specialist at Azure, and I mainly work on a partitioning framework. So, of course, this talk is about partitioning. So if you're managing tables around 100 gigabytes and more, this is definitely the talk you want to see.
Hello, I'm Amit Langote. I work at Microsoft in its Postgres open source team. In this talk, I'm going to talk to you about how Postgres executor interacts with modern CPU and how that impacts its OLAP query performance. I'll talk about a few things we've done to improve that, and then some architectural directions we could take in the future. So if you're interested in OLAP performance, please join me.
Hello there, everyone. I'm Michael John Peña. I'm a Microsoft MVP and MCT, Data and AI Director at Playtime Solutions. I'm here to talk about building enterprise RAG applications with Azure PostgreSQL. And if you're looking for something about embeddings, vector search, all things around LLMs, this is the right place for you.
Hello everyone, my name is Péter Farkas. I'm the CEO and co-founder of FerretDB, which is an open source alternative to MongoDB. And today I'm going to talk about turning MongoDB into an open standard and implement it on Postgres. So if you're a MongoDB user, if you're a Postgres user, if you are both, then you might be interested in this presentation where we combine the power of these two database technologies.
Hi everyone, my name is Adam Volk. I'm a Principal Technical Program Manager for PostgreSQL here at Microsoft. Today I'm going to tell you how to travel using row-level security with PostgreSQL and Citus. So grab a towel and join me if you want to learn how to use row-level security with your application.
Hello, I'm Eileen and I work at marketing at DBTune. My talk is titled Setting Max Connection, Building Postgres User Groups that Bring People Together. I'm really excited to be here at Posette today. I'll be sharing some practical advice on how to create successful Postgres meetups. If you're interested in fostering thriving Postgres communities and creating interactive and fun small and large-scale events, this talk is for you. Now, let's get started.
Hi everyone, welcome to Posette Conference. I'm Rahila Sayed. I work as a Senior Software Engineer in Microsoft. Today I will be talking to you about monitoring in Postgres, and also will be explaining a design of monitoring feature in Postgres. This talk will be useful for developers and administrators who are looking to learn more about monitoring in Postgres.
Hello and good day, this is Jan Karremans. I head up sales in Cybertech, but I still think I have sufficient technical background to take you along on an interesting journey in securing Postgres with streaming replication. It is one of the hidden in plain sight cool features of Postgres that might just help you save the day.
Okay, so I really like these trailers, and unlike some people, I'm not lying.
Well, I might have been wrong with being the best, because this also looks like a very, very high level stream. So I'm definitely going to watch this one, but which is good news because there is more material to continue watching. And yeah, there you go.
Okay, so we're at the wrap-up stage. Those of you who are still with us, we appreciate your dedication to learning more about Postgres and being part of this community and hopefully participating on Discord. I just want to say thank you again to all the speakers who put a lot of work into all these talks. It's pretty incredible.
Making online talks is not the same experience, and it's something that is appreciated, that people do this effort, and you can see the results when they put on the nice graphic and they make it really like a very valid format of doing a conference. So thank you everybody for making that effort. Yeah.
I actually like seeing the close-ups of the faces too, and getting a feel for the person and who they are and what they're bringing to the table. Okay, maybe not that close. Okay, so this was live stream 2. We've got 2 more live streams to go, 3 and 4. Live stream 3 happening starting in just a couple hours. And we have some more trailers that we can roll. So we've seen what we just saw in live stream 2. We just looked at live stream 4, which is happening the next day. We're all over the place. This is live stream 3. This is going to be a trailer for the one that starts in less than 3 hours from now, right?
Oh yeah, exactly.
Okay, let's watch it. Let's go.
Hi, I'm Bruce Momjian, Postgres core team member and EDB employee. Today I'll be talking about databases in the AI trenches. I've always been curious about how AI worked, and I had the opportunity to do a lot of research to understand the internals of exactly how AI is processed. And as part of that, I was able to understand how databases can be most effectively used for AI workloads. I think that might be the most important thing I'm going to be talking about today. We do have a lot of slides, but it should be an interesting presentation.
Hello, so I'm Chris Ellis, the head of technology at Next Team, and I'm going to be talking about fun with UUIDs. So this is a talk about the kind of pitfalls and advantages of using UUIDs as primary keys instead of just standard database sequences. So this kind of talk is really for any kind of application developers who might be working on multi-tenanted, say, SaaS applications, where the advantages of using UUIDs will probably be out benefiting the kind of problems that they cause.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and today I'm presenting Managing Postgres at Scale, Challenges, Tools and Techniques. So I'm going to be talking to you about some of the things that you might encounter as you work with Postgres at scale, whether that's managing huge databases, whether it's managing many databases with large numbers of users or high transaction throughput. And we'll look at some of the things that you can do, some of the tools that you can employ to make that easier. So please stay tuned.
Hello everyone, my name is Alexander Kukushkin and I work as a principal software engineer at Microsoft. I'm a Postgres contributor, and today I'm going to talk about synchronous replication in Postgres and some myths and truths about it. If you are application developer or DBA, this talk might bring very interesting insights about these topics.
My name is Varun Dhawan. I'm a principal product manager here at Azure Database for Postgres team at Microsoft. Me and my team, we work on building Azure Database for Postgres Flexible Server, which is our flagship managed server offering. If you are using Azure Database for Postgres Flexible Server or planning to use it, this will be a great talk, to stick around. So see you there.
Hey everyone, I'm Jimmy Zelensky. Today I'm going to be talking about implementing strict serializability with pgexact. If you're interested in correctness and the internals of Postgres, this is the talk for you.
Hello everybody, I am Krishna Kumar. I work as a group engineering manager at Microsoft, working on PostgreSQL open source as well as the managed service side of things. Today I bring to you a talk called PostgreSQL and Linux kernel interactions. In this you will learn a lot about the internals of how Postgres interacts with the Linux kernel and how to look at this, how to debug this, and a lot more. Welcome and come watch my talk.
Hello everyone, my name is Sarath Balajapalli. I'm a principal engineering manager at Postgres, Azure Postgres team. Today I will be talking about Postgres partitioning challenges. My talk would be useful for database administrators and database developers. So let's get started.
Hi everyone, I'm Neeta Goyal, CEO at Newt Global.
And hi everyone, I'm Sandeep Rajiv. I'm the Sales Director at Newt Global.
Today, we will be talking about migration considerations to go from Oracle to Postgres. If you are considering migration from Oracle to Postgres, this talk is for you.
Hey everyone, my name is Abe, and today I'm going to be talking about building intelligent applications with graph-based RAG on Postgres. If you're someone who's already built a RAG application or want to learn more about making your RAG apps more accurate, this is a great talk for you.
Hi everyone, my name is Toyo Valley. I'm a Microsoft MVP on Data Platform. Today I'll be talking about Azure Database for PostgreSQL, 15 essentials for compliance and security. If you are using Azure Database for PostgreSQL, doesn't matter if you're a veteran or if you're new, you should be listening to this talk.
Okay, so are we passing notes? I wrote you a thank you note, buddies.
Oh, nice. Well, I wasn't sure whether you read that or not. Okay, excellent.
Yeah, this looks a little bit like David Rowley. He had those nice index cards on his talk that he gave earlier today, which if you're interested in the planner and the executor and you missed David's talk, you got to go back and watch it. But yeah, the trailers are good, aren't they? Do you really have a favorite live stream? I mean, come on.
Yeah.
Okay, one more to vote on.
Let's go with that one.
All right, let's watch the trailer for Livestream 1, which is already over, but you can watch the trailer on YouTube still. You can watch the actual live stream on YouTube, and then all the talks are going to get published tomorrow. All right.
Let's go.
Hi everyone, and welcome to the 4th year of Posette and event for Postgres. My name is Charles Pedersen. I'm the Director of Product Management for Postgres at Microsoft, and I'm pleased today to be able to tell you about all the things we're building in Postgres at Microsoft in 2025.
Hi, my name is Robert Haas. I work at Enterprise DB, where my current job title is VP Chief Architect Database Servers. And my talk is about incremental backup, which is a new feature that I developed for PostgreSQL 17. I'm hoping that this feature will be of particular interest to people who have large databases and they're looking for some new backup and restore options.
Hey, hello, my name is Boris Mejias in the role of Monica De Bea.
And I'm Sarah Conway in the role of Evelyn Cates.
And the reason that we are saying in the role of is because this is going to be storytelling. We are going to tell you the story of a developer who comes and seeks help from a DBA who knows a lot about databases, and together combining their knowledge, they are going to be able to provide data integrity through data modeling.
As you can imagine, if you're an application developer or a DBA or anyone in between, even if you're just interested, you can definitely benefit from this talk.
So, hello, my name is Tomas Wondra. I work at Microsoft. I'm a long-term Postgres contributor, developer, and also a committer. And I'm here to talk about performance archaeology, which is an overview of how the performance of Postgres changed over the many years of development. So if you are interested in performance and are a user or a developer, this talk might be interesting for you.
I'm Pamela Fox, and today I'm talking about building modern Python web apps with Postgres.
If you've ever thought about building a Python web app and you're trying to pick the technology stack, then this talk is for you.
Hey everyone, I'm Matt McFarlane and I'm an engineer at Microsoft and a contributor to the new VS Code extension for Postgres that's just been released to public preview. Please join this talk if you're interested in learning about a new tool in VS Code that can help manage and you develop Postgres applications using both standard database management tools and also more advanced Copilot AI capabilities.
I'm Luke Swittle, founder and CEO of PG Analyze. We're going to talk about how to optimize slow queries in Postgres. Specifically, when you have an explain analyze output and you don't know how to interpret it, I'm going to give you a few tips and tricks and a better mental model for working with slow queries in Postgres and how to fix them.
Everyone, I'm Bohan Zhang. I'm a member of technical staff at OpenAI. In this talk, I will discuss how we scale Postgres to the next level at OpenAI. Specifically, we will talk about how we operate Postgres and the lessons we learned and the challenges we face and how we address them at OpenAI. If you are a DBA operating in production Postgres at a very large scale, you might be interested in this talk.
Hi, I'm Vinod. I'm a partner software engineer at Microsoft and one of the committers of Microsoft's DocumentDB. And today, I'll be talking about designing document databases for PostgreSQL, aka how we leverage the awesomeness of Postgres' extensibility model to build Microsoft's DocumentDB.
Hi all, my name is Gayatri Padalla, working with Microsoft as a PostgreSQL performance expert. Boosting the PostgreSQL server's performance using Azure Advisor recommendations is the best way to identify any vulnerabilities your server is going through. You will be informed proactively, and anyone who is moving from Oracle who is not aware about the internals of the PostgreSQL, for them this is the best approach to identify their server's vulnerability and get it fixed.
Hi, my name is Philippe. I'm one of the founders and the CEO of ParadeDB. Today, my talk is titled Elasticsearch Quality Full Text Search in Postgres using Tentivy. We're going to be talking about how you can do full text search in Postgres today, what it's amazing at, what it's perhaps not so good at, and then some of the ways in which the work that we do at Parade with an extension called PG Search is lifting the limitations that full text search in Postgres has to make it competitive with Elasticsearch and other search engines.
Okay, do you still have a favorite?
No,
Come
no.
on. And you and Sarah Conway gave a fabulous talk as part of Livestream 1.
Yeah,
So-
thanks. No, it's a hard choice, definitely. Yeah. I changed my mind. It's
Okay.
wise to change your mind upon evidence.
Yes, I agree. Okay, so after the conference is over, after all 4 live streams are over, you can always go to the posetteconf.com website and get to the videos from the schedule page. So that's option 1. And I'm sure the homepage will be updated to have a link to the YouTube playlist as well. Or you can just go straight to the YouTube playlist, which will have all 42 talks. If you go to that link right now, I think you're going to see last year's playlist, which is still pretty awesome and has some good stuff in it. But immediately after live stream 4, or near immediately, there might be some latency involved. aka.ms/Posette-playlist will get you to the good stuff from this
Why
year.
do we have 42 talks actually?
This year?
Yes, and last year as well.
What do you mean? Why 42? Are you interested in like new numbers? Are you
No,
curious?
it's because it's the ultimate answer to the great question of life, universe, and everything. And talking about ultimate things, we also have the ultimate guide to Posette, isn't it?
We do have the ultimate guide to Posette, and that is the next slide. How did you know
wow.
that?
I don't know. Just the
Okay.
fundamental interconnectedness of all things.
I wrote this blog post to try to be useful to people. It's not like self-promotional or advertising. I wanted to help people pick between the different talks because I don't expect everybody to watch all 42. So I put them into categories, subcategories, tags, all of the above to help you navigate. And it might be worth checking out.
Absolutely. Yeah.
And then Posette is obviously a virtual conference that we like. We like it enough for me to have stayed up all night and for you to have spent a good part of your day in Italy at. But there are other Postgres conferences that are pretty wonderful. And these are just some of the ones that are coming. I've given a talk at Swiss PG Day before. It's in a beautiful location on a lake in Switzerland, an easy train ride out of Zurich, nice academic location, usually 2 tracks. The year I was there, it was 1 English track, 1 German track. Really, really fun event. And then PG Day UK and Lowlands, those are like sibling events. They happen kind of sort of back to back.
Yep.
And you're involved.
Absolutely. So actually, in this nice conference that we have 3 co-hosts that are actually organizers of PG Day Lowlands. We had yesterday Floor Dress, and we are going to have also Dirk van Ven. Also, some of the speakers that were here in Posette are also going to be speaking at PG Day Lowlands, because yesterday we published the I was going to say schedule, but I never can pronounce that word. So the program for the conference. And we have more. What else do we have? I'm in Italy right now, and nearby relatively, we're going to have PG Day Napoli also in September, near to a nice volcano.
Yes, and near Sorrento and near the best pizza in the world and a beautiful bay, and it's just a gorgeous area. PG Down Under, a friend of mine, Thomas Monroe, is on the talk selection team for that, and he's actually going to be a co-host on Livestream 4 as well for Posette, another Postgres contributor who's involved in this conference. So definitely worth checking out if you need a reason to go to Australia, or if you're already there. And then we've got some big events. PGConf New York City happening in late September, early October. Schedule hasn't come out yet, but should soon at some point. And then Latvia, PGConf EU, the biggest in-person Postgres conference in the world, correct? I think that's true. And it just gets better and better every year. And the CFP, the call for proposals, I guess. Some people say call for papers. That really confuses me, because they're talk proposals. There's no papers. We're not writing papers.
No.
So I don't get it. But anyway, it's open till June 30th, and it's going to be in Latvia. So
Could also be call for presentations, the P. I don't know.
Oh, it could be that.
Put it on Discord. What do you think the P is for? And it's not for 3.14, 5, 15, 9, etc. It's a different P.
It doesn't even matter.
Yeah.
It doesn't even matter.
Are you going to submit anything, Claire, for PGConf Europe?
Yes, absolutely. I'm submitting a longer version and a deeper dive with some news stories of a talk that I just gave at PGConf Dev, which is about how 10 Postgres major contributors kind of got their start, got involved in Postgres, became the hackers that they are. So that's one of my proposals. I submitted another one as well. So we'll see what happens.
And I think that everyone who wants to submit something but doesn't have an idea yet, I suggest you listen to a podcast. There's some nice podcasts there on the air. One of them is one of my favorites. It is called Talking Postgres. So do you want to maybe say something else about this podcast?
Well, this is an example where you're not lying, because you screenshotted your Spotify and what's that called? Spotify Unwrapped end of the year. And it showed me the music that you would listen to the most on Spotify and the Talking Postgres podcast. So like, I know you absolutely do listen to every single episode, which I think is freaking awesome. We've had 27 episodes to date. I never meant to become a podcaster. This is one of my most favorite things that I do. People in my family call me on Wednesdays at the beginning of the month usually, and they're like, so Claire, have you done your podcast yet? How did it go? What happened? Who was on there? And I'm like, this is like my mom and my son. And so it's a thing in my life. But it's really about the guests, and I do my best, like Michael Christophanides does with his Postgres FM podcast. I try to make the guests look good, but also just try to have a real conversation, and you all get to eavesdrop on it. So there's nothing is scripted. There's no pretenses. And we just dig into how people got where they are. Why did they do what they do? We have a live recording next week, in fact, with Peter Cooper from Postgres Weekly, and it's titled 12 Years of Postgres Weekly. So I'll be starting to share that link soon. But these are incredible people, and I thank them for spending time with us and sharing their stories.
Yep, and plenty of ideas for maybe going further with something that was explained during the podcast, to have a nice talk or a blog post. It doesn't have to be always in front of people like that, because that's not as obvious for everybody. So writing blog posts is also super good. Now, 2 slides before, you had like, amazing guest. You are missing awesome host.
Oh, that's very sweet. That's very sweet. I do my best. We also have to say thank you. In the open source world, like gratitude is really, really important because nothing happens without volunteers and without people's time and a lot of hard work. And we don't always get paid to do the work that we do in open source. Although when you do get paid to do the work that you do in open source, that's pretty damn cool. But I want to say thank you to this organizing team for Posette, an event for Postgres. Teresa Giacomini is the chair. It's her picture in the bottom right. But there's a lot of other people involved from Microsoft in making this happen. And you can see Aaron Wisling on the Discord. He's actually the admin for the Microsoft open source Discord, amongst all his other engineering responsibilities. And Abe, Amma, Bilge, Jeremy, Linda, Pooja, like lots of support across the board here. So thank you.
And who selected all these talks? I mean, because there were a lot of submissions, I guess, and you need to pick it up only some of them and then maybe letting something out. But then who did all this work?
So Daniel, KK, and Melanie could not have done this without them. They worked really hard. 230 talk proposals had to get reviewed to whittle it down to the 40 that we accepted. And then the keynote speakers are invited. So there are two keynotes, obviously. And then also thanking the other hosts. So up next in just a couple of hours now, Melanie Plakeman and Dirk Van Veen are going to be the hosts for Livestream 3. And then Thomas Monroe and Adam Vogt for Livestream 4.
I heard that Dirk was going to be playing chess with people while he was doing some of the activities because he's able to do this in parallel. So might be an opportunity for him.
You people might think you're just kidding around, or maybe this is an instance where you're teasing or something. But I remember being at a dinner once with Derek, and all of a sudden, I don't know where it came from, but he pulled out a piece of leather that he unrolled, and it was a chessboard, and reached into his pocket and started pulling out pieces. And next thing you know, you guys were playing chess. So.
Thanks for confirming that I was not just kidding here with my comments. But do we have more co-hosts, right? Because tomorrow morning we're going to have 2 different co-hosts, isn't it?
Well, it's tomorrow, Livestream 4 in the European time zones. Thomas Monroe and Adam Vogt are going to be the co-hosts. The one that starts in a couple hours, that's Melanie and Derek. Yep. So, yeah, thank you to them. And again, if you want to go get your stickers, be sure to go to aka.ms/Posette-swag and get your code from the Discord as well. And remember to do your surveys. And is there anything else we want to say? I
did 9 today.
You did 9 out of 11? That is impressive. Okay. So you're setting the gold standard. I will do 11. I've done 0 so far. So,
it's recorded, so you need to
yeah, now I need to follow up and keep my promise. That's true. So do tell your friends. Don't keep this all to yourself. There's some pretty amazing talks here. Obviously, the beautiful thing about a virtual conference is if you do miss all the fun on Discord and you're not here for the live stream and you don't get to hear Boris and I banter, you can always watch the talks on YouTube, maybe from a beach in the Mediterranean or from a high rise in a city somewhere. I don't know wherever you want. That's the goal, is to make it available to everybody. And then thank you to my boss and the team at Microsoft that has paid for all this and helped to organize it. I really, really appreciate it. And that's what we've got.
And thanks for making this available for the community, because people like me coming from EDB can also participate, helping to increase the knowledge of everybody so that we are really kind of a collaboration among competitors or a competition among collaborators. I like to say it like that because we are a community, and that's super nice.
Can you say that again?
Collaboration among competitors or a competition among collaborators. I learned about this going to a meetup, so a different open source community. It's not my quote, by the way, but I like it a lot.
I like it a lot too. All right. I'm going to quote you on that someday.
Yeah, you can do that.
All right, cool. Well, thank you, everybody. It's a wrap. Try to come back for Livestream 3 or Livestream 4 and tell your friends. And yeah.
Yeah. Remember
really
that no animals were damaged during the live stream, and we are very happy that you follow this, and we will see you in the next live stream with other co-hosts that are also going to do a great job.
All right. Thank you. Ciao.
Bye, everyone. Cheers.